Software development. When we talk about software development, what we mean is developing software for specific purposes. Now, in today's world, we have software development being used in every other place. It's become the pinnacle of our society. We wait for development and more advancements in software development so that we can advance as a society. You see that it can be used in research, it is used in commercial use to make products as well as services, and it is also used in warfare. So it has so many different uses. It would be redundant to list them all. What I'm trying to get over here is that software development is a very important thing to us as a society. But the thing is, a lot of times people forget to ask, how does it work? How does software development happen? Now, we know that software development is a long and arduous process because there are a lot of intricacies that go into it. And DevOps is one of those things that helps us to make our software development process more efficient and more excellent overall. So guys, in this tutorial, I will be going through all the different topics that are in DevOps and teaching you how to become a DevOps engineer. Hence, DevOps tutorial.
Before we get started, I want to introduce you to Great Learning Academy, a free learning initiative by Great Learning, where you can access over 200 plus courses with 1,000 plus hours of free content on trending high demand domains such as data science, machine learning, artificial intelligence, programming, cloud computing, digital marketing, DevOps, management, and many more, absolutely free. Award-winning academicians and leading industry experts design these courses. You can also get a free certificate of completion when you enroll and complete these free courses. You also get access to the presentations, code, notebooks, datasets, and quiz. We have courses in English and Hindi to give you the best learning experience in the language you're comfortable with. Check out the description of this video to access the relevant course on Great Learning Academy. So what are you waiting for? Register now and start your learning journey today. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.
So let's start off by discussing what are the different modules we will be covering in this DevOps course. So the first module we will be talking about is DevOps Overview, where we will be discussing all the different details about DevOps, what it is, why do we need to learn it, how does it help companies, and all those different things. Then we'll move on to talk about source code management. Now, source code management is very important when we talk about software development and DevOps. So it is important to discuss this over here also. Then we will talk about microsystems and containerization. So microsystems and containerization help us again in software development and also are a very integral part of DevOps. And the tool we will be working with is Docker. Then, we will be talking about continuous integration, how we can connect all the different parts of a software development process together. And the tool we would be using for that is Jenkins. Continuous monitoring. So we'll be using tools such as ELK to learn how to monitor specific things. Module 1, DevOps Overview. So guys, let's start by discussing why DevOps in the first place. So when we think about DevOps, we talk about software development as we discussed earlier. It is very important to make sure that the software development process you have is as efficient as possible, and that too based on the requirements that you have as an organization or as a person who's developing a specific service or a product. Now, if we were to talk about software development in its infancy, when people back in the early days, back in 50s, 60s, 70s, and 80s, during those days, we didn't have as many methodologies, as many concepts for software development, because software development was still in its infancy. People were still discussing new ways to do certain things. And in those days, they used to make use of a certain methodology called Waterfall methodology. So waterfall methodology is one of the very basic methodologies or very standard methodologies that are used in many different places. So if you looked at it, you can see that this it has multiple phases. The first phase is requirements phase, then you have the designing phase, then the implementation phase, then the testing phase, then the deployment phase, and then the maintenance phase finally. So we have six phases over here. So the first phase is requirements phase. In this phase, basically people sit down together and they look at what are the requirements for their product, what are the functional and non-functional requirements for the software that they're going to be developing or the service that they're going to be developing. So they note that down, and then they move on to the designing phase, in which they start planning out everything based on the requirements that they had discussed earlier. They will assign tasks to specific teams, they will schedule these tasks to happen at a certain time, and they'll also make sure that they have enough resources to perform these certain tasks, etc. And then they will go to the implementation phase. Now implementation phase is where the thing happens, where you go ahead and you develop the software. The coders will sit down and basically start coding the software. Then you come down to testing phase. Now in testing phase, all the testers will go ahead and test our software for specific things. They will go ahead and test it based on the requirements that they were listed earlier. So that's your acceptance testing, making sure that the software that is being developed has all the requirements that are needed. Then you'll do integration testing, in which you check if the software is integrated well with other things, and you perform other types of testings also, like unit testing, etc. Then once the testing has been completed and the testers have given a okay for the software, then the software will go ahead and it will be deployed. So what we talk about when we talk about deployment, what we mean is that the software is given to the final end user. So basically the end user will start making use of this particular software. So that is a deployment phase, in which you deploy the particular software so that the end user can start making use of the software. And then finally we come to the last phase, which is the maintenance phase. So in the maintenance phase, we basically maintain the software, make sure that if it crashes, we put it back up, or if there are new updates we want to push, then we do that. So guys, this is the waterfall model. Now there's something that you might have noticed with this. It's very, very long. Like generally it would take 6 months to a year even to develop software using waterfall model. If it's a very big software, then definitely it will take that like all that time. The thing is that waterfall model isn't inherently bad. It was very, very useful when it was being used in the early days, like in the 60s and 70s. It was perfectly fine in the research environment, where they had to come up with certain software to help them in research, or during warfare, where they had to come up with certain software that would help them in warfare. So it was totally fine over there, because they had certain requirements and they were ready to fulfill it, and they knew how much time it would take. So it wasn't a big problem. So in the early year of software development, when it was just coming up, waterfall model was used. Waterfall model is a very standard model used in many different fields, not just software development. It was very useful when the requirements were concrete and the development life cycles were long. So since the requirements were very strong, they knew what they wanted, it wasn't much of a big problem. But the thing is that waterfall model doesn't really hold up in today's day and age, because in today's day and age you have many different kind of use cases and different scenarios where you cannot make use of this model. Why? So let's discuss why it can't do that. So when we'll be talking about the drawbacks of waterfall model. So we have long development life cycles. Now it's good in a certain way, where that you have this much time and you're going to be putting a lot of effort into it, this particular software, so that it comes out as polished as possible. But the thing is, in today's market, people don't exactly expect polished material in the start itself. They want a good ratio between amount of excellence there is in this product or service and the time they get it in, because today's market is very thirsty. You have customers who ask for updates every other second. They see a change, they give you the feedback, and you have to make that change. So in that matter of fact, then long development life cycles really can't happen, especially in commercial use, where if, for example, if you have a game that you have on the Google Play Store, and you have to give a lot of updates to that game, because you have to push balancing updates. You have to make sure that the UI is great. If the you taking you customer feedback, and then you have to apply that feedback. So that way you can't do it in a very long development life cycle. You have to do it in smaller sprints, smaller time periods in which you go ahead and do all of this. Then another drawback for waterfall model is it's difficult to backtrack. Now it is difficult to backtrack because it's a long process. So that plays into this problem, because once you reach the testing phase, or once you reach the deployment phase or the maintenance phase, and you figure out there's an issue with the whole software, then you have to revert back to the requirements phase or the design phase. So it takes a long time to fix any problems there might be, or it's like a big train, and to stop that train, it's going to be very difficult. You have to apply brakes really hard, and to go back you have to reverse all the way. So it's going to take a long time to do that also, and it's going to be very time consuming, as well as it will take a lot of extra budget or capital. Then no finished product till the end. So what we mean by this is basically we have long development life cycles, and we're not able to show the end user what the end product is going to be, because they have literally no idea till they get the product at all. But this is different when we talk about methodologies being used today. In those kind of methodologies, you have software being developed in smaller parts, so the end user gets the smaller parts, and he can give the appropriate feedback back to us, so he has an idea of what software is being developed. Tougher to plan for. It's definitely very tough to plan for, because it's a very long process, and when you have a long time period of like 1 year, 2 years, 6 months, you don't always know all of the variables. There are a lot of different variables to consider, and to consider them, you still can't consider them. So you can do your best, but you won't be perfect. So you definitely gonna look past a lot of problems that may occur, and they will occur. So it gets very difficult to plan for such a thing. High risk. So that's why when we talk about waterfall model, we say that the requirements have to be concrete, because in the end the reward that is assumed is going to be a high reward thing, because they already know what they expect, and they expect to get that. And it involves a lot of risk, because all these different drawbacks you have. It's very difficult to backtrack, so it's again high risk. You might lose all of your money if you implement a waterfall model. So that's why it's high risk. So you can see all of these different drawbacks makes waterfall model very unattractive in today's market. But that's not always the case. Waterfall model is still being used today in places where it's very suitable, like where you have to develop the software only once. Now there are some there are some games out there which only require to be made once. In those games, you can go ahead and use waterfall model, because you're not going to be pushing any new updates regularly. But there are also games out there where you're pushing updates regularly. So it depends on your requirements of how fast you want the software, how long are you ready to wait to get the first part of the software at all, if you are ready. So waterfall model is not just used there, it's even used in government agencies, where governments don't have to give regular updates to the websites. They just have to create one website or one software. So it's still used in specific locations. It's still used in researching. It's still used in warfare, etc., etc. Now, there are new methodologies that were developed to solve the issue. Like you have methodologies like Agile, Spiral Model, Extreme Programming, Feature-Driven Development, and Lean methodologies. So all of these methodologies and frameworks together, they're used extensively these days, because people prefer these methodology, especially in commercial market, because you have to develop the software very fast, and if you make use of these certain values and principles that these methodologies provide you, then you're definitely going to get the better end result. So in the same way, we have all the different methodologies like Agile, Extreme Programming, and Feature-Driven Development. We have DevOps also. So transitioning into DevOps. So let's discuss what is DevOps. We know that DevOps helps us. Why DevOps? Because we use it to basically overcome the problems of previously implemented methodologies. So what is DevOps? So if we talk about DevOps, there are a lot of different ways to define DevOps. You can't define it one way or the other. Yeah, there are definitions that tell you that DevOps is this and this, but it's like a nebulous cloud where you have a certain idea of what it is, but you can't always put it into words. But if you really had to put it into words, you could say that it's a mix of a way of software development where there is a certain set of principles and values you have to follow in DevOps to get the better software development process. Or you could say it's a set of values and principles, only a set of values and principles. Or you could define it as a methodology. Or you could say it's a set of tools. Or you could say it's a way to automate things. It's a lot of these different things. Instead of thinking of all of these different definitions as single definitions for DevOps, what you can do is you can just think of them all together. It is a way of software development. It is, developing software with a set of values and principles instilled in the people who are working in the software development. And it is a methodology. And there are tools that you use in DevOps, and you do automate the whole software development process. So all of these different things combine to tell us what DevOps is. Now, the name DevOps comes from developer and operations. So DevOps bridges the communication gap between the software developers and the IT operations team. So you have the developers who develop the code, that's their sole job, and you have the IT operations team. They manage the whole infrastructure on which the whole software is being developed, and they're the ones responsible for making sure that the software is given to the end user. So what DevOps person does is it basically bridges the gap between being a developer and being an operations person. So that's how the name comes in. The dev from developers and the ops from operations. So DevOps. Now, if we look at the proper definition of DevOps, we can see that DevOps is a set of practices that combine software development and IT operations. It aims to shorten the system development lifecycle and provide continuous delivery with high software quality. Now, DevOps is complementary with Agile software development. Several DevOps aspects came from Agile methodology. So it's something that, it's not alone again. You don't use exactly only DevOps. It's always based on what your company's or your organization's requirements are. You will use DevOps in certain locations and you will use Agile in certain locations. So what are the benefits of DevOps? Now we know what DevOps is. It's basically a methodology, a culture, a mindset, a set of tools that help us to improve our software development process. And there are many ways to that. We will explore those ways when we talk about DevOps in more detail. So let's discuss what happens when we implement DevOps. What are the benefits of DevOps? So some of the benefits are having high productivity. Now, on implementing DevOps, you're definitely going to see a very high increase in the amount of productivity you have, because a lot of processes that were originally being handled by humans are now being automated. They're being scripted now, and that definitely increases the productivity you have. Other people can then go ahead and concentrate on the thing that they have to solely concentrate on. A developer doesn't have to worry about ops things, and he only has to worry about writing the code and then pushing the code and then waiting for it to be deployed, get a feedback, make the changes, and then repeat the cycle. That's his job. So that way productivity definitely increases, and you get an excellent product in the end, or a service in the end. Whatever you're providing to your user, you provide the best particular product / service there is in the market, because you're improving your quality, because you're improving your productivity, and hence you're improving your quality also. And there are a lot of certain aspects that we will talk about that help us to improve the quality of our product with continuous testing, whether it be dynamic testing or static testing. Then returns. So when I talk about returns, I'm trying to say the profits or the revenue that the organization will generate will increase because of the other two factors. Because of high productivity and because of excellent product, you will definitely see a rise in the returns, or the ROI, the return of investment, the revenue that the company generates, or the profit they're generating. And a lot of other benefits are having a speedy and rapid delivery. You're able to deliver the software that you want very fast, because you're automating a lot of the processes. So you're able to deliver the software you want very fast. Robust security. So when you talk about DevOps, you also have to consider the security aspect. There is a specific field in DevOps called SecDevOps, which concentrates only on the security aspects. They try to make sure that the whole software development pipeline is very secure. There are no security vulnerabilities, whether it be in the networking, whether it be in the software code itself. It makes sure that the software code you have is as secure as possible, because the software is the company's asset. It's the product. So you have to make sure that nobody steals it or makes or misuses it. It helps you to track everything that is being done by any person who has an interaction with the software. So that creates a layer of security that definitely helps you protect your software. And better scaling. To explain better scaling, let me tell you guys about what happens when a small company grows into a big one. You have a small startup, and they have a really great idea. They want to expand even further. They have only 10 people working for them, but they're able to deliver some product in the end. They're able to put band-aids on cracks that they see, and give the product as they can. It's not the perfect software, but then it's giving them the thing that they require, the users that they require. Now they decide to expand their whole organization because they get generating revenue. They want to expand. So what happens in that scenario? Well, in that scenario, this startup will face a lot of problems. They will have to rewrite a lot of the old code, because the old code is it's band-aid code, because they're just writing whatever they can to make whatever software there is, because the amount of resources they used to have weren't enough. But now that the company is expanding, they have enough resources, so they have to rework a lot of the things. So in that matter, the scaling is not happening perfectly. So that's why you have to keep in scaling in mind when you as a startup also. So DevOps, if you implement DevOps from the start itself, you can see the benefits of it by having better scaling. The whole software development pipeline can be scaled accordingly. You can have multiple sets of different teams working on the same infrastructure, because you're able to scale it very well. So that's again a very important benefit of DevOps. So these are the different benefits that DevOps provides on implementation. All right, so now let's talk about DevOps phases. So DevOps has certain phases inside of it. You guys will understand more when we start discussing it. So we have the first phase, that is the continuous development phase. Then we have continuous testing phase, then continuous integration phase, continuous deployment phase, and continuous monitoring phase. So let's go through these one by one. So you have continuous development. So in continuous development, you're developing code for the software continuously. In continuous testing, you're testing that code continuously. In continuous integration, you're connecting all the different parts of software development process. That is your development process, that is your testing process, that is your deployment process, that is your monitoring process. It connects all of them together. So that's what happens in continuous integration, and it does so continuously. And continuous deployment, you're basically deploying the software continuously. And last, continuous monitoring, where you're monitoring the deployed software. You're making sure whatever happens in the software is being monitored. If some crash happens, if there is a bug, then you need to know about it, so that you can make sure that the coder rectifies that mistake later on in the next cycle. So you can see the trend over here. There is continuous in all of these phases. Now, continuous makes sense because what DevOps tries to implement is automation and continuous integration and delivery of everything. To do that, they make sure that every person just does what they're defined to do, and it instills a mindset in the developers and everyone else who's working in this whole pipeline, that they have one goal, that is to deliver software. So that's why we have continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring. It keeps on happening continuously, and everyone has one mind set in their instilled in them, that they have to just deliver the software. That's their job. So these are the different DevOps phases. DevOps principles. So guys, now let's start talking about the different DevOps principles or certain values that are usually used when you implement DevOps. So these are the principles you have to keep in mind whenever you're making a decision. So let's look at these different principles. So one of the first principles is customer centric action. Whenever you take a decision, please keep in mind that this decision has to benefit the customer in the end, or try to make the decision so that the end result helps the customer in the end. Any decision that has priority, or that is to be given priority, has to be given priority based on the fact, or based on the thought whether this decision is going to help my customer in the end. That's why any action you take should be customer centric. Is it going to help the customer? Is it going to make the customer comfortable? Is it going to give the customer the best experience possible? Are we doing the best we can for the customer? So you have to keep that mindset when you are making any decision. Create with end in mind. So whenever you're creating any process, or whenever you're creating any part or any new thing, and you're experimenting with any new thing, you have to do it with an end goal. You have to make sure that in the end you're going to have something real or something tangible in your hand that you can give to your end users. And another principle is having end-to-end responsibility. So when you implement DevOps, you have to instill the mindset into the developers, into the different teams that are working in the software development process, that they have end-to-end responsibility. Whatever they create, they have to keep responsibility of that, whatever they've created. If there is any feedback, they're supposed to resolve any issues based on that feedback, and they can't push the blame to other teams. So this is the kind of culture, work environment that is being created, where whatever you do, you have to take responsibility for it, even if it happens down the software development pipeline. You can't blame others. That's the kind of mindset that is, or that's the kind of work culture that is trying to be instilled in, when you're implementing DevOps. No silos. So basically, normally software development has specific teams working on specific things. You have specific you have testers working on specific things. They're testing something. The software development team is developing something. The IT operations team is handling the operations part. But when we're talking about DevOps implementation, we're trying to make sure that all of these teams are well balanced. They're not siloed off into single thing. They can do a lot of things by themselves. Any responsibility that they need to take, they can do it. So we have a lot more flexibility in the development. If suppose one team is not able to solve something, the other team can do it. So that kind of flexibility is important.
Then comes continuous improvement. Here, there might already be an already existing pipeline. So you have to come up with new improvement ideas. You have to keep in mind that you always have to keep on improving on whatever already exists. Doesn't matter if you already done it in the past. There are always going to be new techniques and methods that you can make use of to improve the whole process.
And automate everything. That's the last principle. You have to make sure that everything is as automated as possible. Wherever you can automate, wherever you can write automation scripts, you have to write those. So these are the different DevOps principles you have to keep in mind to instill a work culture that instills the mindset in developers, in different teams, that they are responsible for whatever they're delivering, to maintain a very healthy work environment, to make sure that everything you're developing is of the best quality as much as possible, and to automate everywhere or wherever you can. So these are the different DevOps principles. Now let's talk about the relationship between Agile and DevOps. So Agile methodology. So the whole idea of Agile is to make sure that teams work faster and more efficiently in regular sprints, and to keep on improving based on feedback given to them. So the whole idea of Agile is that you work in shorter bursts, but you deliver quickly and you improve upon your process by getting feedback from the end user. This can be a customer, this can be a client, whoever is going to be using the software. Earlier, Agile was used only by developing teams. It hadn't trickled down to other parts of the whole software development process. Like only developers were using it. The whole the testers and the operations team, they were not making use of Agile. So while successful at improving development speed, testing and operations were still very lacking. So while we did improve a large part of our software development by using Agile, we weren't able to solve the deployment part or the operations part. And that's again very important. Every part needs to be as, optimized as possible. And with that, a need to improve testing and operation was realized by a lot of different companies. It was achieved with the help of automation, and that's where the concept of continuous integration emerged. So the whole idea of automation is kind of borrowed, or it's kind of something that you naturally come to. If we took an example of car development or the whole car industry or the automobile industry, we saw that Ford revolutionized everything by including the production pipeline, where he had workers doing small menial tasks and on every small car. But then slowly as we became more technologically advanced, we started to replace these workers doing menial tasks with automation machines doing the menial task. In long run, they saved a lot of money because maybe they cost a lot, but over the years the cost reduced. It was way more efficient to automate certain parts, and that kind of ideology trickled into software development also. Now, automation definitely helps us. Humans make errors, and automation, if you've already thought of the possibilities and you've analyzed all the risks, you can come up with a suitable automation for certain parts of the software delivery. Now, companies small and big quickly took up the initiative and improved their delivery part as well, not just their development part. So then onwards, Agile and DevOps were used in unison to develop and deliver software. So generally, when we talk about DevOps, we never talk about DevOps alone. We talk about DevOps with Agile. It's usually used with Agile or any framework Agile or whatever other new methodology is being used with DevOps. Because based on your requirements, you're going to have a certain methodology, but you're going to implement it with DevOps, because DevOps affects different parts of the software development process, not just development. Whereas Agile or other similar frameworks, tackle the problems in software development, in the development part itself. So this is the relationship between Agile and DevOps. All right, so what are the different tools being used in DevOps? So DevOps has many different domains. We discussed that there were 5 phases: the continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. All these different 5 phases have certain tools that are used in them. And not just those phases, there are certain technologies that you use in software development, and there are tools associated with those certain parts of software development. So let's discuss all of those different tools being used. I will label the role they play also. So the first role is continuous development, in which you're developing the code continuously. So you might be using an integrated development environment like PyCharm or IntelliJ or Netscape or Eclipse, all those different IDEs that you might be using. So that's kind of a part of continuous development, but not exactly DevOps. You have tools like Git and Mercurial and Azure repository. Now these tools are important because they are version control systems. Now what version control systems are? They're basically used for versioning. We will talk about this more later. So they definitely help in continuous development. So these are some of the tools that you might need to know. Now Git is an absolute must. It's an open source tool and it's very easy to start, and you can start using it pretty fast. If your company uses Mercurial, then you can go ahead and learn Mercurial. Then you have building tools. Now building is a process in which you take the software code, you take all its dependencies. These can be the libraries or functions that are used to run the code, and you put them all together into one single executable file. Like you have .exe files in Windows, right? They're basically that. So those are the executable files. So to make these executable files, you have to use tools like Ant, Maven, Gradle, MSBuild. Now Ant, Maven, and Gradle work on Java. Ant is an older version. Maven is a newer version. Gradle is used for Android, and MSBuild is used for .NET. So these are different building tools. Then you have database management tools. So in database management tools, you have like MySQL, MariaDB, Liquidbase, or MongoDB, or any of the AWS or Azure provided services that help you manage your database. So there are many different tools used for database management. Continuous testing. So you want to test your software to make sure that the software is as polished as possible. So you use static testing tools like SonarQube, PyTest, Catalan, and then you use dynamic testing tools like Selenium. Then you have continuous integration. So continuous integration basically connects all the different parts of software development. You connect your development, you connect your testing, you connect your deployment, and you connect your monitoring together. To do all of this, you make use of tools like Jenkins or Circle CI or GitLab or Bamboo or TeamCity. So in these, Jenkins is an open source tool that a lot of companies make use of. It has a very big community, and this is the tool that we will be working with. Continuous deployment. Now, continuous deployment is deploying the software continuously. In there, you have Excel deploy, Juju, Octopus deploy. So these are the different tools that are used in this particular phase. In configuration management tools, so you have Puppet, Ansible, Chef, SaltStack. So configuration management is basically writing a set of configurations and passing those configurations onto certain servers. So if you have hundreds of servers, right, and you want to update those hundreds of servers, how would you do it? Would you do it singly, one by one, or would you take a set of configurations and just push to them? So this is what these tools do. Puppet, Ansible, Chef, and Stack, they basically take these set of configurations or these set of settings and update them onto those hundreds of servers. So this is basically what their job is. Then you have orchestration tools. You have tools like Docker, Kubernetes, Nomad, Apache Meso, EKS, and ECS. Now, Docker is a containerization tool which helps you create containers, but it also has a specific service called Docker Swarm, which is an actual orchestration tool. Now, Kubernetes is one of the most popular orchestration tools out there. Then you have artifact repositories. So if you guys remember, we talked about those executable files, right? So they're also called artifacts. Now, these artifacts can be stored in specific dedicated locations. So a lot of companies provide these locations, and there are JFrog Artifactory. Then you have NPM, Node Package Manager. Then you have Sonatype Nexus. Then you have certain cloud services. So you have to learn about cloud also, in which you have different tools like different cloud services like AWS, Amazon Web Services, Azure that is provided by Microsoft, GCP that is provided by Google. Then you have OpenShift, Cloud Foundry, DigitalOcean, Alibaba. All these are cloud services. The cloud providers who provide you services. Then you have continuous monitoring, in which you monitor your software, the system, and the logs. So you have ELK, Prometheus, Grafana, Splunk, Nagios, and Google Analytics. And finally, you have scripting. Now, scripting is not technically a tool, but scripting is important because you do your automation using specific scripts, and you access servers using bash shells and etc. So you need to know Python, PowerShell, Perl, Java, .NET, either one of these. So guys, these are the different DevOps tools. Now, let's talk about who is a DevOps engineer. Who is a DevOps engineer? What does he do? So a DevOps engineer is basically a person who is responsible for designing, maintaining the software development pipeline. He also makes sure that software is deployed properly without any issues. Now, he can do this by making sure that there aren't any cracks in the whole pipeline. He can do this by making sure that the communication that happens between different teams is very clear, the ideas are exchanged without any miscommunications, and that there's no office politics, and people generally have a very healthy working environment. A DevOps engineer knows how to automate processes and writing automation scripts. He also knows how to keep the whole infrastructure, infrastructure which is used to deploy and maintain the software, secure and robust. So it shouldn't crash or it shouldn't break down, and it should be secure. So that's his job. A DevOps engineer has excellent communication skills that help him to convey ideas and exchange information between different teams. Now, a DevOps engineer will be interacting with a lot of different types of teams. He'll be interacting with the development team, the testing team, the IT team, the database team, or the networking team, all the different teams. He has to talk to them because he's kind of a jack of all trades person who has knowledge about a lot of certain things, maybe not exactly deeply, but he knows enough to deliver all of his deliverables. And on a daily level, a DevOps engineer is responsible for making sure scaling needs of cloud are fulfilled, optimization happens, managing of permission happens, and documentation is happening. So this is a DevOps engineer. These are his responsibilities, and this is his job basically. A DevOps engineer has a wealth of knowledge. So, like I told you, he's a jack of all trades, but he also excels at all of those trades. That means that he has to be good at those technologies. So he has to have a knowledge of Linux, Windows operating systems, how to handle them, how to manage all the processes. Then he needs to know about the database technology, the server technology, how to handle servers, orchestration technology, cloud technology, source control, continuous integration and deployment, automation, scripting, networking, and definitely excellent communications. So these are the list of skills a DevOps engineer must have. He must be good at all of these things, or he must be good at, giving his deliverables, making sure that there is an excellent software development pipeline in place and the software that is being, given to the end user is of excellent quality. Basically provides some value to the company, right? All right, so let's see some DevOps case studies. So we have companies like Etsy, The Telegraph, and Netflix. All of these different companies have implemented DevOps over the years. Now, some of these companies are new, or they have started, software development recently, and after 2000s. So they aren't new to the idea of software development, but they aren't exactly legacy companies who are using a legacy software. But then some of them did have to change and start implementing DevOps, but some of them started using DevOps, early on. Now, what happened when they started using DevOps? Companies like Etsy, Netflix, and The Telegraph, they saw better productivity in their whole pipeline. They saw that people were doing much better since their whole goal was defined. They had a clear mindset, and the whole process of software development was automated, it was optimized, it had become more efficient. So they saw a record revenue. They saw the productivity increase in their employees, in their software development process itself. Then they saw a layer of security being layered onto the whole process. Since DevOps does also concentrate on the security aspect, it made sure that the product that they were delivering, the service that they were giving to their customers, was secure. There were no data leaks, and there were no security vulnerabilities in their software code. Then the product that they delivered was of excellent quality. Now, that Netflix has one of the best streaming services out there. Netflix gives us the best streaming product that we have till date. That is definitely true. They pay their software developers a lot. They pay the DevOps engineers a lot, and they give the end users the best product in the market. So you can see how it does affect them. Now, the same case with Etsy. Now, Etsy and The Telegraph, they are very specific use cases. Now, Telegraph is a news organization, and Etsy, is a platform for people to sell. Even on these different types of companies with different use cases in different markets, they're able to implement DevOps and get the best product out there in the market, and hence increase their revenues. They definitely saw a rise in their revenues with the with increase in the excellent quality of their product, and the productivity increase. So they definitely saw high amounts of revenue being generated, and it gave them an option for better scalability. Now, Etsy, Netflix, and The Telegraph are companies that are definitely looking to expand. Netflix is ever growing. It started expanding into a lot of different countries, and even in countries where there's not good access to internet. Even in Africa, Netflix is there, not in all countries, but in certainly in the richer countries, and they definitely want to expand later onwards. So with implementing DevOps, they have seen that the scalability options that they have increased also, and this gives them a higher ground above their competitors who are not making use of DevOps. So guys, this is the DevOps case study where you see that these companies have used and implemented DevOps and seen, their revenue increase, and get better scaling options, have a layer of security, see a rise in productivity, and having an overall excellent product. Now let's talk about the prerequisites that you might need to start learning DevOps. So there are basically two prerequisites at all if you want to get into DevOps. You just need to know basic Linux commands, and if you don't know those also, but that's totally fine. I'll give you guys a brief intro to them. And you just need to know basic coding. So these two are the two prerequisites. You need to know a little bit about the coding. You necessarily don't need to know a specific language, but if you do know, that's good. Just know the fundamentals of them, and some Linux commands. So these are the prerequisites. If you don't know any of these, that's not a matter. Over the time when we start learning about every different things, you will get to know about them, but they're definitely recommended. Source code management with Git. So guys, we'll be learning about source code management or version control system using the tool Git. Now, this is a very integral part of DevOps, as it is a part of continuous development phase, which is again a part of DevOps. So let's go ahead and look at the different topics we'll be covering under this topic. So we have what is version control. We'll understand what version control itself is. Then we'll see the need for a version control system. What are the different version control systems available? Then Git Overview. We'll talk about why Git, what Git is. Then we'll get started with GitHub. Then we'll learn how to install Git on multiple systems and configure them. Then we'll basically learn the Git basic commands, then Git branches, merging, and Git Workflow. So these are the different topics we'll be covering when we are talking about source code management with Git. So let's get started. What is version control? So when you think of the word version control, what comes to your mind? Well, as the name suggests, it's version control. You control the different versions of a thing. Now, when talking about this with software development, right, it is important because you have to version control your software. Now, in software development, you write source code. This source code is then used to create a software. Now, you will definitely have multiple versions of a software. To have those multiple versions of software, you'll have to have multiple versions of the source code. And that is where version controls comes in. Now, these days when software is developed, it is not developed with the mindset that there will only be one piece of code that will be deployed, and that's it. You will definitely be writing multiple lines of code and multiple versions of that code, because you will definitely try to improve upon your previous code, and to improve upon it, you will write new versions. Now, these days, smaller snippets of code are deployed in regular successions with regular feedbacks. So what this means is that you write small pieces of code, you push them, and you get a feedback, whether it's from your team or whether it's from the end user, and you improve upon that code by writing newer versions, and they are again smaller snippets. So this way you're writing many different versions of a code, improving every time you write a new piece of code. This leads to many different versions of the code. And that creates a need to organize the code and all of its different versions of it. This is where version control comes in. You have to control the different versions. So version control is basically a practice of managing and storing different versions of code. Now, if I were to give you guys an example, think about a college student or a school student who has to do his final year project. And he has finished his final year project. So he's doing his project in, analyzing how a particular website processes a certain thing. Now he's completed his work and he has made sure he's documented everything, and he's written down everything that is related to the code. Now he's on the deadline because that's the last day and he's finished his work, but he feels like he can do better things. He can improve upon his existing project because he feels like he needs a better grade, and to get a better grade he needs to show his professor that he's done his best, and he's done his best in every other part. So he sees that there is a need. He tries to identify if there are any problems with the already existing project, and he sees that yes, there is. He sees that he can optimize the processing part of his project even more. Now to do this, what he does is that he writes the new code for optimizing the whole project over his old code. When he does this, he takes a lot of time. Maybe he takes like 4 or 5 hours or maybe 6 hours, and he sits down in one place and does all of the changes. Like he makes all of the changes. And once he's done making all of the changes, he tries to execute the code. But this is where a problem occurs. The code doesn't run properly. Why? Now he doesn't know why the code doesn't run properly. So what should he do? Should he panic because like the next day is the deadline? He has to go and show to his professor what he's done, and he can't show anything because he has a project that is not running. The mistake over here that he made was overwriting his previous code. If instead what he had done was write the new code in a separate file and back up his older version of the project in another file, in another location. This way, both of them don't interact with each other, and there are no conflicts or there is no overwriting. There is no miscommunication. If you suppose don't do well in your new version of the code, you can always go back to the old version. And that, in his case, he couldn't do that because he had overwritten his older code. So you can see what would happen if he had introduced version control system and how important version control system is. So this is one of the examples where you understand the need for version control, because you can always make mistakes, and if you make mistakes and you don't have time to rectify those mistakes, then you're gonna be in trouble. But if you manage your versions of different code, you can always go back to the different versions, the older version, the working versions. So this is especially the case with larger companies that have multiple projects and multiple teams working on them. So for example, there's a team that has a website for it's a shopping website, and they have multiple projects on it. They have project A, they have project B, and they have project C, and there are different teams working on them. There's team A working on project A, team B working on project B, and team C working on project C. And project A is for their payment feature, project B is for their shopping feature, and project C is for their cart feature or their warehousing feature, the backend, where all the items come in and get stored, the warehousing feature. So all you can see that all these different teams work on different versions and different features of the website. So let's examine project A. So project A is basically your payment feature, right? So there are 3 versions to it. There's A1, A2, and A3. Now the A3 is the latest version of the code. Right now it's not being deployed. The team is still working on A3. A2 is the one that has been deployed. Now A2 has been deployed for a good amount of time. The users have used it for around 6 months and there have been no crashes. It's working perfectly fine. But you always have to make improvements on what you've done before. So the team identified the places where they couldn't make those changes, and they came up with the idea of A3, the latest version, and they're working on it, and they've actually done working on it, and now they're planning to deploy it. So what they do is they pull back A2 and they immediately push A3 as the latest version. But then they see that A3 starts crashing. They start crashing when the client enters a specific number or specific something. They haven't exactly identified the problem, but it crashes the whole website, and that affects the other teams also. So this is important. This is a great mistake. So in this situation, what they can do is they can make sure that the application or the website that is provided to the end user remains there. Like this shouldn't happen that there is no application for the users to use. So to do that, what they can do is they can pull back A3 and push back A2 again, because A2 was the latest stable version that these people were using, and it was working fine for 6 months. There were no issues with it. So this way they make sure that their clients or customers have an end working product. While this is happening, while A2 has been pushed, they go ahead and debug A3. So they can go ahead and see what is a mistake made in A3. They can rectify it. And while they're doing it, there's no downtime for their final application. And this way, project B and project C can still, go on working without any integration issues. So this is again why, version control is important. It helps you organize all of your code. It allows for greater collaboration between different teams. You can manage different projects at the same time. So this is exactly why people go ahead for version control. All right, so now we know what version control is. Now let's see, why do we need it? We've already discussed some of the reasons. So just as we discussed right now, the purpose of version control systems is, as the name suggests, it controls the different versions of the code. Now, how does this go with DevOps? So the idea of a version control system, or a VCS, meshes very well with the DevOps ideology. What is the DevOps ideology? We studied a few principles, but the whole goal in the end was to make the whole software pipeline as efficient as possible. And the idea of VCS meshes very well with that ideology. It helps us to make the whole software development as efficient as possible, because we're using a version control system where we organize everything. That increases productivity as well as efficiency, and it also allows us for quick delivery of code and automatic job triggering. So when you want to push a specific code quickly, you can do so because you already have version control system. So you can create triggers. You can create triggers in build jobs where the whole process is automated. This way, there's no human intervention always required. You can automate even more. So this is very integral for DevOps. This allows for easy automation of the whole software development pipeline. That's why version control goes really well with DevOps. Now, there are a few benefits to version control systems also. So let's study them. So it gives you complete control. So that is one of the big benefits of version control systems. A good version control system, or a SCM tool, will allow you to completely control all the aspects of the code that you are going to write. Why? Because you will have complete access to every facet of that code. Who's writing that code? Where is he writing? Or when is he uploading the new feature onto the master branch? All those kind of details will be stored as logs, and you will have exact control of who has access to that code in the first place. You can control it, completely. No one who does not have authorization to access your code cannot access it. So that way you have a lot of control over your code, and you can create triggers. You can, create build jobs where you can put your repositories. That way also you have control. Then comes security. Now, implementing a proper source code management system creates a layer of security around the code and allows for only a need to know basis of accessing the code. This again relates back to the control benefit of a version control system, where you have a lot of control, where you know who is accessing the code, where you give authorized access to only a certain group of people, and where you have a list or a log of every change that is happening to the code, every commit that is being made. So this is why security is again a big benefit of version control system. To give you guys an example, if you had, let's talk about the previous example we took. Project A, Project B, and Project C were being handled by different teams. Now, the developers in Project A will not have access to the source code in Project B, right? Because that's not what they're supposed to be doing. So they don't have access to it unless, there is some cross, talk, and they want to collaborate on a specific thing. So the team lead can give access to the developers in team A. So this is how it could work. Then it gives you the option of fast delivery. A good version control system also helps in fast building, testing, developing, and deployment of the software by being connecting to the deployment tool. So if you have any CICD tools, continuous integration / continuous deployment tools like Jenkins, you can easily, deliver your product. So all you have to do is, create a build job where you assign specific configurations, where it tells Jenkins or the CICD tool that it needs to pull the code automatically without any human intervention and push that code into the deployment or the production environment. So that way the amount of downtime you have for a specific application is reduced greatly. And if you reduce the amount of downtime for an application greatly, the amount of money that gets wasted when the application is down reduces a lot, and this in turn increases the revenues for the organization or the company. Then the last benefit that I want to talk about is availability. Now, availability is kind of related to reliability also. All the code, all the source code that is created is stored in a cloud repository. Now, basically, you will write features in your own local repository or your local system, but you will be pushing it to the cloud. Once you pushed it to the cloud, it is available to everyone who has access to it. So anyone from anywhere can pull the code into the system at any time without any issues on the planet. Whether even if there's a pandemic going on, or even if there's a whole natural disaster going on, or the society is going to collapse, you can still access the code as long as the servers that host that code are still running, and you need to have internet access, obviously. So these are different benefits of a version control system. So what are the different version control systems available to us? So there are multiple tools for source code management or version control system or version control that are available to us for using. They're usually very similar with the exception of small, some features that cater to different requirements. So they normally are, your AWS code commit, GitHub, and Git, and your Mercurial with Bitbucket, and then you even have other versions for your Azure repository or your Subversion, so you have a lot of different options. Now, a lot of people definitely, they go for Git or Mercurial because, Git is actually, a lot of people just go for Git because Git is an amazing tool. We will talk about this a little later, but Git gives us a lot of different features. As you may have expertly deduced also, we are definitely going to be talking about Git and GitHub in this topic. All right, so let's talk about Git. Git overview. So what is Git? So, Git is basically a version control system. We discussed that. And we know Git is the VCS. So Git is an open source VCS. It's an open source version control system that allows the user to keep track of all the changes that have been made to the source code of the software. So you have developer 1, developer 2. They are, independently, responsible for creating feature 1 and feature 2. So once they write their feature 1s and feature 2, they go ahead and push it using the tool Git onto the GitHub. So the distinction between Git and GitHub here is that Git is the tool that helps you track all the changes, helps you do pushing and pulling, and GitHub is the dedicated storage repository which versions all of the code that is being stored. So this is how, this is what Git is. Git is an open source, version control system. Git's full form is Global Information Tracker. And, it was developed by a group of Linux kernel developers back in 2005 when they weren't satisfied with any of the free source code managers that were already available. Since they weren't very satisfied with what was available, they just came up with their own thing. That's how innovation happens. When there is a need, someone will create. There were paid softwares also, paid source code management systems also, but people, generally wanted to use free ones because of their own use, maybe personal use, or maybe, the requirements weren't fulfilling enough. Now, Git and GitHub slowly became the industry standard as people gravitate away from legacy version control systems towards open source tools like Git, as they provided the same features, but it was completely free. So it was completely free. That this became a very attractive offer to many different people, especially like startups and amateur developers, because not everyone has the resources to pay millions of dollars for a software, right? And when you don't have that accessibility to resources, you tend to go for cheaper options. And being free is an amazing offer over here. So Git has that, feature of it. Now, there are a lot of other features of Git. Let's discuss them. So those features are like, system compatibility. Now, Git has absolutely no problem running on any type of operating system, be it Windows, be it Linux, or be it Mac. Git is also great when it comes to inter-version control system compatibility. as it can work together. It can work with other tools repositories. For example, if you wanted to use Git with some other repository, not GitHub, if you wanted to use it with Bitbucket, if you wanted to use Bitbucket and Git together, you could do that, really. And if you wanted to use Git and SVN together, Git has no problem pulling and pushing code to and from distributed repositories of SVN or any other repository than GitHub. So it's got great system compatibility, not just with operating systems, but also with other repositories. Then comes collaboration. Now, Git allows for heavy collaboration. A team of developers or different teams of developers can maintain a hierarchy and work on the same main code, but on different snippets of features simultaneously, and then merge all of their work when they're done to form the software that is to be deployed and be presented as the end product. Now, this allows for easy tracking of who's working on what part of the project and what changes they have made, which again, relates back to whatever details they have, whatever details have been or of changes have been made are stored as logs. Then comes speed. So speed is another feature of Git. Now, Git is very efficient at handling code and allows the user for easy forking and cloning of major repositories onto local system. So if you're working in a company and you're working in a specific developer team, and you want to pull the whole code into your system so that you can start working on a new feature, then you can do so very easily and very efficiently. It is also much faster than all of its alternatives. So if all the other alternatives like Mercurial and AWS Code Commit, it is much faster than them. So that is again a big thing about Git. And then another feature is distributed system and reliability. Now, this facet of Git allows multiple users to work on the same piece of code from anywhere in the world, as it is stored in a distributed repository accessible from the internet. This allows for companies to hire people without having to worry about their location, but rather their abilities. Not only that, people can start working from, their homes. Work from home becomes very easy, especially in situations where you have a large pandemic at hand, where people can't travel to the office due to security and safety reasons. Then you can, just rely on whatever is available on the cloud or the distributed repository. Just pull your code, work on it, and then push it back. So it removes any dependency on the location itself. You don't have any dependency on what your location is. That is a great improvement from before. This provides a sense of availability, as the code is always available to the developers. They needn't worry about the server maintenance or the upkeep of that server also. Unless you had your own dedicated server where you were storing all of your source code, you would access the cloud. And that is not maintained by your company. Or if it is, that is fine, but that's still not your job. If you're making use of any services that are provided by AWS or Azure or GCP, then they are maintaining those servers. So there is no upkeep for those servers. You just have to pay them and they will guarantee the availability to you. And then the last feature I'll talk about is security. Now, we've already discussed this when we talk about version control systems, how they will create a layer of security. With Git also, you have the same. It keeps a track of all the changes and all the commits that were made as logs. This allows for easy investigation if or whenever any issue occurs down the pipeline. So if any issue occurs down the pipeline and you want to figure out why that issue occurred, then you would just go ahead and check out all the commits that have been made to your master branch. And if you see that there are some issues, you can easily click on them and make changes accordingly. Now, Git is overall one of the best source code management tools that anyone can use. You can be a software developer, you can be a data scientist, you can be a student or a professor or even an academic researcher or even hobbyist. Everyone can make use of it because it's so easy to learn and it's so easy to use that anyone can make use of it. Even if you're not using it for software development, you can even use it for just storing your files. It's just amazing. All right, so now we've understood a lot of things about Git and version control systems. Let's understand how the code flows within the Git system itself. From so far what we have learned, you can probably deduce that you will write the code on your system and that code will be pushed onto the distributed repository or the cloud, which is exactly what is happening in Git. But there are a few steps that we didn't mention. Now let's start talking about those steps. So the first step is, assigning a working directory. So first, a working directory is assigned. So this working directory is basically the location where all of the working code will be stored, and this is where the user will be working from. So suppose in your system you create a folder called project folder and you start working from that project folder, then that project folder, like you store all of your code like index.html, index.js in that project folder, then that project folder is your working directory and you have assigned it. So like there's no official step, but you are assigning it as a working directory. Then comes the next step in this life cycle, that is initialization. Now this is a step that you will be doing using Git. So once you are you have assigned the working directory, the next step is to initialize that working directory. So to initialize, once you initialize that directory, you basically tell Git that this directory or that folder called project is now to be regarded as a local repository, which can later be pushed onto the distributed cloud whenever there is a need. So it's basically telling Git that this folder is the folder that I want to work with, and please keep a track of all the files that are staged and unstaged. This is when Git basically starts tracking all the files in the directory. So then comes the next step, that is staging. So once the initialization has been completed, the work on the code can begin. All the changes that like addition or deletions are made. So once you've made those changes to your code, right, you already might have some code like index.html. You make those changes in that code, and then you go ahead and stage that code. So you'll basically be working on the code between initialization and staging. So staging is basically telling Git that what are all the changes made to a specific file. So you can stage a specific file, and then Git will basically automatically identify what were the changes made to this file compared to the previous version. This is when Git starts checking for all the changes that have been made. So this is staging. So once you've staged, you go to the next step. So in the local storage, right, you're going to be committing. So once the work on the code is done, once you stage the files are then committed. So committing basically means that you're saving the changes that you've made. So suppose in that index.html file, you made a change where you added some header tag and some paragraph tags, and you want to save those changes onto your local system. Now you can just Control S it, but to inform Git about the saving that is done, you need to commit them. So once you commit them using Git's command, that save will be changed as a specific commit in the local storage. Now that you've done all the work, it's in the local storage. The next step is to push it to GitHub or the local or the distributed cloud. So then the code is pushed from the local storage to the cloud or the distributed repository. With Git, it's GitHub where the code is stored. So this is the life cycle of code within Git. So it goes from working directory where you assign one working directory and you start creating all the files inside that working directory. Then you initialize that folder / directory, and then you start working on that code. Do whatever you want, make all the changes, and then once you're done making all the changes, stage whatever file you want. If you have 3 files in the system and you only want to push 2 of those files out of those 3, then you stage only those 2 files. And once you stage those 2 files, all the changes are tracked by Git, and once you've done staging, you can go ahead and commit that code. So once you commit that code, all the changes are saved on the local system. They are stored in like those track of those changes are stored in a commit, and basically then you go ahead and push the code to the GitHub. Now the code can be later be pulled on to make newer changes, and this whole cycle will be it'll start repeating again. So this is the life cycle. Now let's get started with GitHub. When we talk about Git, it is important to also mention GitHub, as GitHub also plays a major part in this source code management. Now the job for source code management is usually divided in this way. You have Git. So Git is the tool that tracks all the changes. It pulls and pushes the code, solves any merge conflicts or does any merging or rebasing. And GitHub is the one that is responsible for storing all of the code. It's the distributed repository which stores all the code. Now to effectively use Git, we need to know how to use GitHub also. So let's start by creating an account on GitHub. Head to github.com and then fill out the form in the sign up like so. So let's start doing it. So committing basically means that you're saving the changes that you've made. So suppose in that index.html file, you made a change where you added some header tag and some paragraph tags, and you want to save those changes onto your local system. Now you can just Control S it, but to inform Git about the saving that is done, you need to commit them. So once you commit them using Git's command, that save will be changed as a specific commit in the local storage. Now that you've done all the work, it's in the local storage. The next step is to push it to GitHub or the local or the distributed cloud. So then the code is pushed from the local storage to the cloud or the distributed repository. With Git, it's GitHub where the code is stored. So this is the life cycle of code within Git. So it goes from working directory where you assign one working directory and you start creating all the files inside that working directory. Then you initialize that folder / directory, and then you start working on that code. Do whatever you want, make all the changes, and then once you're done making all these changes, stage whatever file you want. If you have 3 files in the system and you only want to push 2 of those files out of those 3, then you stage only those 2 files. And once you stage those 2 files, all the changes are tracked by Git, and once you've done staging, you can go ahead and commit that code. So once you commit that code, all the changes are saved on the local system. They are stored in like those track of those changes are stored in a commit, and basically then you go ahead and push the code to the GitHub. Now the code can be later be pulled on to make newer changes, and this whole cycle will be it'll start repeating again. So this is the life cycle. Now let's get started with GitHub. When we talk about Git, it is important to also mention GitHub, as GitHub also plays a major part in this source code management. Now the job for source code management is usually divided in this way. You have Git. So Git is the tool that tracks all the changes. It pulls and pushes the code, solves any merge conflicts or does any merging or rebasing. And GitHub is the one that is responsible for storing all of the code. It's the distributed repository which stores all the code. Now to effectively use Git, we need to know how to use GitHub also. So let's start by creating an account on GitHub. Head to github.com and there fill out the form in the sign up like so. So let's start doing it. So I will open up my browser. Go ahead to your browser, just type in github.com. And when you do type in github.com, if you already have an account, it will directly redirect to your account. Like I already have my account over here, so this is my home page. But if you don't have an account, what this is the page you will get. Let me just open up incognito mode and type in github.com. And when I do this, I will get another page. In this page, it will ask me for signing up for GitHub, and this is what you guys should see also if you don't have a GitHub account. So just go ahead and enter any username. So I'm gonna put Jane 4556, and I'm gonna type in some 4556 at gmail.com. Please go ahead and enter your email address over here and your username. Email is invalid, already taken. So let me add another 6 and it's valid. Okay. So, and I'm gonna give it some random password. Yeah. So, I've given it some random password. Make sure it's a little bit strong. Yeah. And then you can go ahead and click on sign up for GitHub. So when you do sign up, it will ask you to verify your account. So make sure that you're not a bot, So to do that, it's not loading it yet, but it probably will ask you to move an image of an animal in the straight location, like in a vertical manner. So it should be in the right orientation. It will ask you for that. And you have to solve basically a small puzzle, and then you can verify your account. And, we get it verified from your Gmail also. All right, so once you've finished all your joining in formalities, you can click on join a free plan. Okay, it's not doing that because I've not entered a right password or anything, right email address. So when you do join in, this is what you should see. You will see this as your home page, and you can see this is my page, and I can see my profile, my repositories, my projects, my stars, my gist. So if I want to search for someone else's repository or some other person, I can do that over here, right? So right now you can click on your profile, and then you can check your profile out. If you want to change any details in your profile, you can go ahead and do that. You can see this is my repository. I have 2 repositories right now, 3 repositories right now. I can create a new project if I want, or a new repository if I want. So let me just go back to the home page and show you guys how to create your own repository. So if you guys remember, I said that you can create your own repository, and you have 2 types of repositories: your local one, the one which you store over here, and your remote one that you store in your cloud. So this is going to be the cloud or / distributed repository where you're going to store all your code. So to do that, just go to left hand side over here. There's a button to click on new over here. Once you click on new, it will give you a lot of options, right? So it's going to ask you who's the owner. You can change the owner if you have multiple accounts. If you want, you can give it a name. So let me give this a name. I will give this a name my demo website. Yeah, let me just normalize this. Yeah, and let me spell website correctly. Yeah, my demo website. So this is the name of my repository. I can go ahead and give this a description. This repo will store all the source code that will run my website. This is my description. You can make it public, or you can go ahead and make it private. I'll leave it public so you guys can go ahead and check this repository out. Then once you've done that, you can initialize a readme. So readmes are basically explain what your project is about or what your repository is about. So if you're creating a specific package, you can create a readme, initialize it, and add whatever you want. But we don't need to do that right now. So I'm just going to go ahead and click on create repository, and this will create a new repository for us. So once we do create a new repository, the most important thing you have to take in consideration over here is the URL. This is the one URL that you will be using. So if I copy pasted this URL into my browser, I should get access to this repository. And I do get access to it. So this is an important one. Copy and keep it, or just remember whatever your name is, github.com/username/repository name. And you can see there are a lot of details over here to take in. One of the details is it helps you create a new repository command line in your local local system, push an existing repository, or import code from another repository. You can check out issues, pull requests, actions, projects, wiki for security, insights, and settings. So there are a lot of options over here. You can see GitHub is full of different features. You can create webhooks. You can perform a security analysis, check integrations, and etc. etc. And this is where your code will be stored. All right, so we've created our own repository. We have created our own account and our repository. So this is what we will need for now. So let's move on to the next thing. Now we will install and configure Git, because we want to work with Git. So Git is a two-man source code management is a two-man job. It's with Git and GitHub. So let's go ahead and install Git. Now you can install Git on any of the various different operating systems. Like I mentioned before, it's independent. It works independent of the operating systems. You can work with Linux, GitHub on Linux, GitHub on Windows, GitHub on Mac. So I'll explain how to download GitHub on Linux and Windows. All right, so I will go through these process more briefly, comprehensively. All right, so let's go ahead and do it for Windows first, then we will do it for Linux. So let me go back to my browser over here. We'll close these. All right, so open a new browser, new tab, and type in Git download. So when you type in Git download, you should click on the first link. It will be gitscm.com. Just click on that, and it will give you various options. It will give you options for downloading it for Linux, downloading it for Windows, and downloading it for Mac. So the one we will choose is downloading it for Windows. So let it just load. All right, so we're going to go ahead and click on Windows over here. You can directly click on download 2.2.8 for Windows. Now, once you click on Windows, it will automatically start downloading it. So you can see Git 2.28.0 64-bit is downloading. If you have a 32-bit system, go ahead and click on 32-bit for Windows setup. Just wait for this to get downloaded. All right, so once the .exe file is downloaded, you can go ahead and click on it. If it does not automatically download, you can go ahead and click here to download manually. So once the executable is downloaded, go ahead and start it up. I'm going to click it over here. It start opening Git installation wizard. Now in the installation wizard, it will ask us a lot of things. I want you to leave most of them default. All right, so when you have the installation setup appear in front of you, just keep on clicking on next. Make sure you have it in the right directory. You can change it if you want, but I would recommend just keep on clicking on next. Leave everything default, because you're new to Git. If you're not, you can go ahead and change them. If you want to change the editor, you can change it to Sublime, Atom, or whatever you're comfortable with, Visual Studio. We'll leave it as Vim here. I'm going to keep on clicking on next, because these are advanced configurations, and usually the default one is fine. So I'm going to click on next. I'm going to click on next, and I'm going to wait for it to download, install. So as you can see, it's starting to install Git for me. So we'll just wait for it to install. So once your Git installation has completed, you can just click on launch Git bash, or I'll show you guys how to launch it manually. So just click on next again. Once you're done installing Git, you can right click anywhere. I'll show you guys. Just right click anywhere on the screen or any folder, and you guys will see two extra options over here. So Git GUI here and Git bash over here. So Git GUI here is basically Git graphical user interface, and Git bash is basically a terminal. It's the bash terminal that if you're acquainted with the bash terminal, you can go ahead and use the bash terminal. If you're acquainted with the GUI, you can go ahead and use the GUI, whatever you're comfortable with. So this is the GUI. All right, so you can see it tells you all the unstaged changes, whatever is missing. Stage changes will come in. All right, so this is good, but the terminal is better. It makes you look cool also. If you have any friends who don't know anything about computers, you can show them you're like a hacker if you use the terminal. And terminal is a lot easier for me also, because all the commands that we use for Git, they're easily doable using the terminal. And if you're working with the integrated development environment where you're writing the code in an integrated development environment, you can basically make use of any Git plugins. So if you're working with IntelliJ or any other integrated development environments, they all have their own plugins for Git. And Visual Studio Code has Git embedded in it, so you can definitely use it like that. So guys, this is how you would go ahead and install it. Git in Windows. Now let's go ahead and do this for Ubuntu or Linux. Since I'm going to be using Ubuntu because it's one of the most used Linux distros out there. So let me go ahead and open that up. So I'll be using a AWS instance over here. As you can see, I've already launched one instance, Ubuntu instance. Let me just rename this to Git. All right, so I'll explain to you guys how to basically launch instances when we're talking about Docker, since we'll be talking using these more intensely. Right now, I just want to show you guys how to install Git on a Linux system. So while this is loading, let me open up my PuTTY tool. This is my SSH tool. It will allow me to connect to that instance. I just need the IP address. Let's finish it loading. All right, so let's go ahead and copy the IP address over here. I'll paste this. So let me go ahead and paste this over here, and we will open it up. All right, so let me log in. Okay, so we are now logged in. Right, so we are logged into Ubuntu instance. So there are two ways to install Git on Ubuntu. You can go ahead and use one of the Ubuntu repositories itself, or you can use download Git directly. Now downloading Git directly is a little longer procedure. It will give you the latest version of Git, but mostly Ubuntu repositories are also updated with the latest version, mostly, right? So there'll be like maybe one version late or something. That's it. So to install Git, what we're going to do first is we're going to go ahead and update this instance. So to do that, I'm going to use the command sudo apt update. This will update my Ubuntu repository in this particular instance. And once that completed, I can go ahead and install Git. So the command to do that is sudo apt install Git. Now, the thing with the instance that are launched with AWS here, that Git is already installed. So if you have an Ubuntu system that you're using, instead of using an AWS instance, you wouldn't have Git installed already. So you can go ahead and type in this command. Or if you're using the AWS instance, it will already be installed. So you don't really need this command. But I want to show you guys nonetheless. So if I press enter, it will start installing it, but it's already there. So if you want to do it in CentOS or RHEL, the command for that is sudo yum install Git. So this is the command for CentOS and RHEL. So if you're working with that. All right, so now that we have Git installed, we can go ahead and use the first Git command. So the first git command is basically git hyphen hyphen version. So it will give us the version of Git that is being used there. So we have Git version 2.17.1. All right, so let's go ahead and do the same over here. Let's check it in the bash. Let me increase the font size so it's more clear to you guys. All right, so this is the different version for Windows and this is the version for Ubuntu. Right, so now that we've installed Git, let's go ahead and configure Git. So to configure Git, what I try to say is I'm basically going to be entering the username and the password, the username and the email address. So let me show you guys how to do that. So here, what you will first do is you will type in git config hyphen hyphen global. This global tag basically tells that these settings should be there in the whole system. Then I'm going to type in user dot name, and you can type in whatever your username is. Since mine is Remy code, I'm going to enter this, and then git config global user dot email, and you can enter your email here. Now let me just show you guys what email are you going to enter. I mean, you can enter your email address, like if your email address is jane5446@gmail.com, go ahead and enter it. So right, so then you can go ahead and press enter, and to check whether your settings have been saved or not, you can type in git config list. This flag will list all the configurations that have been made. So just check for a username, user.name and user.email. So this has been configured. Now if you wanted to change them, all you have to do is type in these commands again and change the value. So to exit this, just type in q and you will exit. Same thing over here. You can go ahead and type sudo git config hyphen hyphen global user dot name and then the name of the user. So my name is here again Remy, so code, and enter. And I'm going to do the same thing again for my email address. Dot email, and I'm going to enter my email address. It is jane4556@gmail.com. right? Now if I wanted to see the list of configurations, I would use the same command, but just with sudo git config and the list flag, and you can see the list of configurations for Git over here. All right, there's another way to do this. You can use the Vim editor. Go over here /git config. You can see the configurations in your git config file. You can come out :q. We'll use the same command in Windows also. We can use the same command v git config. All right, so let me just exit out of here. All right, so those were the basic configurations for Git. So now that we're done with that, we can move ahead to the next topic, that is basic Git commands. So let's go ahead and learn all of the different basic Git commands. All right, for all the Git basic commands, we'll be using the Windows version because it will give you guys a much better idea of how to work with Git. And I know a lot of you are inclined towards using Windows, so let's go ahead and use that. All right, so our first step here is going to be opening up our Windows system. So guys, here what we want to do is we want to use all the different commands. We have to understand what are the different commands that will help us achieve the Git life cycle. So if you guys remember, we had to first create a working directory, assign a working directory, then initialize that working directory, then stage all the files, and then commit them, and then push them to GitHub. So that's exactly what we're going to be doing here today. So first we will create a folder or a working directory. To do that, we will use the mkdir command. So I will type in over here mkdir, and I'm going to type in the name of the file / directory I want to create. So the directory I want to create is called project. Now you can use the same command for Linux also. If you're working with Ubuntu, you can use exact same commands because they're using the bash terminal. All right, so I'm going to go ahead and press enter over here, and this will create a file or folder called project. So to check that, I can type in ll over here, and it will show me all the files, and this is the file I created. So I will head into that file using the cd command. So cd project, and I am now inside the file. So you can check the address or the location or the directory over here. All right, and this tells you what branch you are on. We will discuss branch later. So let me just clear the screen. All right, so our first step is completed. We have assigned a working directory. So we will be working inside of this directory. Any files that we create inside of this, they will be part of the working directory. All right, so our next step is to initialize this directory. So if I type in git init, this will initialize the directory. So if you remember what initializing did, it basically told Git that all the files are to be tracked in this particular folder. So if I create any file, suppose I create a file called, I use the command touch, index.html. So now this file will be tracked. So it will tell us whether these files are staged or not. So if I type in git status over here, so it will tell us that these files are not tracked. So basically it will tell us that whether these files are staged or not. All right, so let me clear the screen again, and now we have an unstaged file, that is index.html. So let's go ahead and enter some values into this index.html. So I will type in nano. You can use v also, but nano is a little bit easier. So I'm going to type in nano index.html. It will open the nano editor for us. All right, so inside of this we will enter the code for this. So I'm going to put some HTML code. All right, so then I'm going to give it a header. And then I'm going to end it. All right, so we have our sample HTML file over here with a lot of tags. So let me go ahead and save it. To save it, I'm going to type in Control O and then press enter. All right, so I've saved it. Now to exit this file, I'm going to type in press Control X. So this will exit my file. Now to check the contents of my index.html, I can again press nano, but I'll just use the cat command. So it will list everything inside of index.html. And you can see this is the contents of my index.html. All right, now that we've added some basic code to one of our files, we need to go to the next step. So we've worked on our file. Now our next step is to stage this file. To stage this file, we have to go ahead and use the git add command. So there are two ways to do it. I can type in git add and type a dot. So dot will basically stage all the files in this particular folder. But if I want to, basically only stage one file, then I have to mention that file's name. So I'm going to mention it index.html, right? Okay, so if I press enter, it will stage the file. So if I do a git status again, so remember git status is to check the status of the local repository. This is my local repository. All right, so let me press enter. All right, so no commits yet, but there is a new file called index.html, right? So our next step here is to basically commit this file. We have staged this file. Now we have to commit this changes made to index.html into the local repository. So we have to use the git commit command for that. So I'm going to type in git commit, and this is the syntax for it: git commit, right? Git commit, and then write -m. So this is for adding a message. You have to add a relevant message to whatever commits you're making, so you remember what you did. So what did we do over here? We added a HTML file. So I'm going to write here added index.html. All right, so I'm going to press enter, and it will tell us there's a commit made, added this is the commit message, added index.html, one file changed, 8 insertions happened. Okay, so see, you can see that it's tracked all the changes that happened. Now if I do a git status again, it will tell us that on the branch master nothing to commit, because the working tree is clean, because we've made all the commits. So there is only one file which has been committed. So our next step is to generally push this file onto our remote repository. Okay, so now we have committed our file. Our next step is to basically upload it. So we have a repository. Let me show you guys. So this is our repository again. So this is the link. So just go ahead and copy this link. Make sure this is the same repository you want to upload to. And once you copied the link, you can go ahead back to your terminal. And inside of your terminal, you will add this repository as a origin location. So we will use the command git remote add origin, and we will paste the URL. So this will basically add this particular URL as a origin in our system for this particular directory. So let me go ahead and press enter. All right. Okay. So we have added our remote repository. Now we can go ahead and push the changes we have made onto this repository. So we can use the command git push origin master. So it will push it, but it will need authorization. All right, so it's done pushing to this particular location from the master branch onto the repository. So if we go back to our repository over here and refresh, we should see the new code over here. So we have index.html appearing over here. All right, so there was one commit made to it. You can go ahead and click on that commit. You can see the commit history. There is only one commit made to this. We come back over here and we click on index.html. And once we click on index.html, we can see our code over here, right? Okay, now let's head back. We have uploaded our file onto the system, and you can see that it's onto our local remote repository, and you can see it's been added. And the commit is also over here. All right, so now let's do another thing. We have done this once. Now let's try to make more changes and upload the newer file, right? So what will happen in that? So I will go ahead and open my index.html again. And over here, I'm going to add a paragraph tag. I'm going to close this tag. I'm going to save this with Control O, Enter, Control X. I will verify if I have made the changes. All right. Now I'm going to go ahead and stage this file. Now let me show you how it does, staging. So first we will create another file, hello.txt. If I do an ls, you can see there are two files, but I will stage only index.html. All right. So if I do a git status, yeah, there is one untracked file, that is hello.txt. So any changes made here into this hello.txt will not be recorded. So once we have committed our index.html, we can go ahead and commit it. Git commit m message added p tag to index.html. A relevant message. Always add a relevant message. Then press enter. So you can see that one file was changed and 3 insertions were made. Okay. So if we do a git status again, it will tell us that one file is not being tracked, but one, our index.html has been staged and committed. So I will do git You can see nothing added to commit. All right, so git push origin master. All right, so it's pushed all of the changes I made onto the remote repository now. So if I reload the page again, I will see that there are now 2 commits. If I just look it up, you can see the latest commit always appearing on the right hand side. There are 2 commits: added index.html, added p tag to index.html, right? They have their own commit IDs. You can go back, you can open index.html, and you will see the changes that have been made. Okay, so this is how you would go ahead and version it. You can always go back to a previous commit if you want. We can go back to the older version if you wanted, right? Right, we have an older version. So, this is why Git is useful. You can do a lot of things, especially go back to older commits. Now, if I come back over here, I want to show you guys one more thing. It's the git clone command. To do that, I will come out of the project directory, our working directory. I will create a new directory, mkdir, call this temp, and I will head inside temp. Now, once I head inside temp, I'm going to go ahead and use the git clone command. So this basically clones any person's repository onto your local system. So if I go back to code, I click on code over here, copy the URL. You can do this with anyone's code. You can go ahead and do this with my code also. Just go, it's public, so you can copy this, come back, use the git clone command, and then paste the URL, and then press enter. Right? Okay, so if I do an ls now, I can see my demo website is created as a working directory. So let me just go inside here. And if I do an ls, I can see the index.html. All right. Now I want to show you guys one more command. We will head back to our project directory. And over here, we will use a command called git log. So git log basically gives you an idea of how many commits were made. So if you wanted to add one more commit, you can see all the previous commits, added index.html, added p tag to index.html. If you wanted to add another commit, so let me just go ahead and quickly add one more thing to index.html. I will commit this. One insertion was made. If I do a git log again, you can see the new commit has been made. But you can also see that this origin master, so this means that this one has been pushed onto the remote repository, whereas this has not been. Let's quickly do that. Git push origin master. All right, so now we are done. Now there is another command called git pull command. It is exactly like clone, but clone is generally used in the starting when you have a fresh new start. That's when you use git clone. And git pull is generally used and it's better to use when you are pulling from a main repository. Git pull is, if you are working with a team and you need to update whatever code you have. Suppose this is my master code index.html. But a lot of more people kept on adding to the index.html, not just me. So I want to pull these onto my system. So what will I do in that case? Instead of using git clone, I will go ahead and use git pull command. All you have to do is write git pull and copy the code and just paste it. Press enter. All right, so it's already up to date. That means everything is already added. So if somebody added another file over here called hello.html separately, you can go ahead and use git pull, and it will merge all of it in your local repository, right, with all the changes you have made. All right, so guys, those were the git basic commands. Now let's move on to the next topic. We have git branches. So let's study git branches. So what are branches over here? Now you might have some idea of what branches are because I've told you about master branch, right? So branches basically allow easy management of different parts of a software. For example, let's say your team is working on delivering a website. Now this website will have different features, right? Each of these features will be counted as a branch within the Git that will be worked on separately by different developers. Once they are done with their work on the corresponding branches, they will issue an PR, a pull request, and then the branch will be merged onto the master branch on the Git repository. So the master branch will be the one that goes into production. This sort of falls into the idea of changing a small part of that old code without affecting the whole code at large. You can imagine branches as separate timelines. So let me show you guys with the diagram. So we have a master branch over here. We have made some commits and we decide to create a feature one branch. So we have created a feature one branch over here, and feature one branch will have its own commits as well as feature two. So you can see feature one was pulled from the master at one point, and they made the changes and then they merged it back onto the master branch. And then similarly, feature two branch we have over here, feature two branch pulled from the master branch, they made their own commits and then they merged it later on. So the latest version of master will include both feature one and feature two, whereas the earliest version will not. So this is how branches work. They're basically like timelines where you can work on different timelines and then merge those different timelines together. Now, each branch has its own unique commit, right? So these commits are basically like checkpoints that are created whenever you use the git commit command to save the changes like we studied. They are also created when you merge the branches. So when we learn about merging, I'll talk more about merge commit. So basically what that means is that, whenever you merge it back onto a master branch, there's a commit created. So these circles are basically commits. All right. So these are branches. Let's see a few common commands to work with branches. Let me come back. Git branch is one of the very common commands. It basically tells you all the different branches in your system in the local repository. There's only one branch, that is master branch. So make sure. So to create a new branch, we will go ahead and use the command git branch, and I'm going to give this a name, feature one. Let me give it a proper name. Git branch feature one. So if I do a git branch again, I should see two branches, but you can still see that I'm on the master branch, and feature one branch I'm not there on. It's there in the system, but I'm not on it. All right, to go to the feature one branch, what we can do is you can use the command git checkout. So git checkout will basically help you to go to the other branches. So git checkout, switch to branch feature one. If I do a git branch again, you can see that I am switched to feature one as a branch. Now to delete a branch, right? So make sure you first come out of a branch. So let me check out master over here, and I will create another branch, feature two, and I will go ahead and delete feature one branch. To do that, I will use the command git branch -d. And when you use the -d command, just go ahead and type the name of the branch you want to delete, feature one. Deleted branch, feature one. So if I do a git branch again, I can see that feature one branch is not there anymore. Now this command won't work if you are deleting the branch you are currently in. Now you can rename a branch also. So let's go to feature two branch and rename it. Git checkout. You can only rename branches if you are in those branches. So that's why I have to go to that branches, feature two. And now I will rename it using the command git branch -m and the new name. So the new name I'm going to give this is feature B. All right. So if I do a git branch again, I can see feature 2 has changed to feature B. All right. So if you suppose pulled a branch, right? So if you cloned a specific repository from somewhere, so suppose if you clone this repository and there are two branches, you won't see those branches because they're remote branches. They're not local branches like these because they're over here. So to see all of them, you have to use the command git branch -a to list all the branches, right? So it will appear in red just like here. Okay, so there is a shortcut for one of the things that I want to tell you guys. So if you want to create a branch and switch into it directly, just use this command git checkout. Let me just clear the screen, and then type in -b and then create the branch. So feature one. So this will create feature 1 from me, and it will switch to feature 1 for me also. You can see the branch changing over here also. So if I do a git branch again, you can see all the different branches over here, right? Let me just go back to the master one. Just remember the master one is the most important one. Don't delete this one. All right. So now let's go ahead and talk about the next topic, that is merging. So merging is important because you have different branches always. You're going to have multiple branches and you would want to learn the concept of merging. Git merge allows a user to merge different branches into one. It will create a new commit on merging. Here, the history of commits are not transferred. So that is important to remember. So let's take that example of our image again, the diagram. We have master branch, we have feature 1, and feature 1, you can see, has different commits over here. And in this feature 1 branch, you can see that when it gets merged back onto the master branch, there is a commit, merge commit created. So this is basically merging. Every time you merge a branch back onto the master branch or any other branch, there is a commit created on the receiving branch. So feature 1 branch is the committing branch, the joining branch, and master branch is the receiving branch. Similarly with feature 2, you can see when the feature 2 gets merged back onto master branch, a merge commit is created. So here you can see that any of the features, any of the commits that are made on feature 1 branch or feature 2 branch aren't transferred. Only a unified history of them is transferred to the master branch, not all of them. So, merging is good, but it's not really best if you have a project where there are way too many people working on it, because, you might have way too many merges. Now, we'll talk about that more when we're talking about rebasing. So let's go ahead and try merging some of the branches here. Alright guys, so to learn about merging, I have created a new directory over here. We're going to call this my project, and I have written a new file. It's called base.py. It's a Python file. So if we open it up, let me just show you the contents of it. We don't need to open it up. Right, so it's just main code. I'm just trying to simulate that this has the main code. Now what we want to discuss here is how the merging will happen and what kind of branches are we creating. So guys, we're going to create 2 branches. To create those 2 branches, let me first stage and commit this file. I will quickly do this and added file. Alright, so we're done doing that. So let's say that there are 2 developers, developer A and developer B. So these developers are going to be working on this particular project, and their jobs respectively is to basically create features A and features B. So let's go ahead and create those branches for these developers. So if I do a git branch right now, we can see all the 3 branches: the master branch, which has the main code, then we have feature A branch on which developer A will work, and feature B branch on which the developer B will work. Right now we are on master branch. You can check, you can figure that out by seeing where the star is, or whatever is next to your directory. So this is what it tells us. Now let's go ahead and see how developer A will work. So right now, if we check out feature A, my bad, let me go ahead and, so we are in feature A, as you can see with this. Now if I do an ls over here, you can see that base.py has been copied to it. Now the developer is going to basically create a new file. So let me nano it, feature A.py. So he's basically going to write the code for feature A. He's going to go ahead and save this. And let's say that the developer B is also going to do the same. So we will head to feature B branch. And over here, we're going to go ahead and create. Let me show you that we only have the base file. Right, so we did not stage and commit this. Let's go ahead and stage and commit the file in feature A, because if you don't do it, it will appear in all your other branches. So this is a warning for you all. So just go to feature A. Always do a git status if you're not sure before you changing your branches. So over here, what you can do is you can go ahead and type git add to stage the file and then git commit to save the file. All right, so we have committed the changes. Now, if we go ahead and check out feature B branch, we are not going to see the file. We're only going to see the base.py. And if I list the contents, there's nothing new in this. So let's say that the developer B is also going to write feature b.py. So let's go ahead and do that. Feature b.py. Let me open it up using the nano editor. And over here, we're going to write some code for feature B. Let me save this. Let me go ahead and stage this so that it doesn't appear in other branches, and then we will commit this. All right, so now we have done doing that. If I do an ls, you guys can see the file, and if I head back to my master branch, you guys can see only base.py is over here because those developers were working on their separate branches that were isolated. Nothing was being exchanged. The only reason it was exchanged because we didn't commit it, right? So now we will go ahead and merge our feature A branch with our master branch. This is to signify that the developer A has finished working on all of his work, and now he's going to merge whatever he's done onto the master branch. To do that, he will use the command git merge. So we will go ahead and write git merge, and we will write the name of the branch that is going to be merged, that is feature A. So whenever you want to merge a certain branch, right? So two branches, go to the receiving branch. In this case, it's going to the master branch that is going to receive the merge, and write the name of the sending branch or the the branch that is going to be merged. So we're going to write git merge feature A, press enter. All right, so here if I do an ls now, we can see feature A has now been copied onto the master branch. But I want to show you guys something. If we write git log over here, we will see that there is no commit, there's no merge commit. So I've told you guys that every time you do a commit, every time you do a merge, a commit is formed. But right now there is no commit for no merge commit formed over here. Only the commit from the feature branch has been transferred over to the master branch. So this is basically called a forward. So forwards basically happen when there are no changes made in the earlier branch. If the history of master branch is same, it's similar to feature A, as in if no changes were made to master while feature A was being changed, then this fast forwarding can happen. So if in case we had added something else to base.py, or if we added a new file altogether to master, and then we had merged feature A to master, then we will get a merge commit. Only then a merge commit happens, right? So we can see that when we merge feature B onto master. So let me go ahead and do that. Git merge feature B, and I will press enter. Right. So now you can see that it's asking me for the message of the merge commit. So over here, this is going to be the message of the merge commit, merge branch feature B into master. And to save this, or if you want to write anything, go ahead and press insert and enter whatever you want. Since we don't want to enter anything, we will just backspace whatever extra we added. And we will go ahead and remove the insert by pressing Ctrl C, then pressing Shift : and pressing WQ. So this will write this commit message and then exit. So you can see that a new commit has been created. And if we go ahead and do a git log, we will see a new commit over here. That is the merge commit. Merge branch feature B into master. Now this didn't happen when we did with the same thing with feature A, because it was a fast forward. We didn't really need to do anything because master hadn't changed at all since feature A was being merged. But when we were merging feature B, there was a new change in the master. There was a new commit in master, and that's why we needed to do that's why a merge commit happened. So if you want to exit your git log, just press Q and you will automatically exit. So guys, this is how your merging basically happens. Okay guys, now I want to talk about Git merge conflicts. When do they happen and how can we resolve any Git merge conflicts? So let me go back to the terminal over here. So I've created a new directory to explain this to you guys. It's called the temp directory, and we're gonna go ahead and create a file. Actually, I've already created a file over here called hello.py, and I already staged and committed it over here with git log. You can see the commit. Now we're going to go ahead and create two branches again. I'm going to name this feature, I'm going to just name this fee1 and fee2 for convenience sake. So these are feature 1 and feature 2 branches. And if I do a git branch, we can see the branches over here. All right, so we have two branches. Let me go to feature 1 branch. And if I do ls, we can see the hello.py file over here also. So guys, we want to simulate a merge conflict. So when does a merge conflict happen? To understand that, let's assume that we have three branches over here, and feature 1 branch is being developed by developer 1 and feature 2 branch is being developed by developer 2. Their jobs are respectively to create feature 1 and feature 2. While they're doing it, some third developer or maybe the team lead adds a new hotfix to the master branch. So let's go ahead and add that. So in master, I'm going to create a new file over here. Actually, let me just edit the already existing hello.py file. We're going to add hotfix code over here. All right. Hotfix code has been added. So let me go ahead and commit this. All right, so we added the hotfix. Now we will go back to our feature 1 branch, and in feature 1, our developer is going to add the new code into the hello.py file. So he wants to add his own code. So he's going to write over here feature 1 itself. Let me go ahead and save this, and we will stage this. Then we will commit this. All right, so he's committed it. All right, so now what he wants to do is he realizes that the master branch has new code in it. So to run the code on his system, he has to basically merge the master branch onto his own system. To do this, he will go ahead and do a git merge in his branch, that is feature 1 branch. So once he does that, git merge master, all the basically contents of master will be joined into the feature 1 branch. So if you press enter, you can see that there is a merge conflict in hello.py. Now the automatic merge failed because there are some conflicts within the same code. Because why? Because in our hello.py in feature 1 has different code than the one that is there in master. The master has the hotfix code, whereas our file does not have it. Now generally your merge conflicts appear because of sometimes developers may work on the same file, and once they do work on the same file, they might push it independently and the other developer might not know about it. So he realizes that mistake, so he pulls the code and then he will go ahead and get this message of the merge conflict. All right, so we can see that there's no commit formed here because we haven't resolved the merge conflict. To resolve the merge conflict, we will go ahead and use the vim diff tool. To go ahead and access that, we will use the command git merge tool -t, vim diff. So this will allow us to basically see what are the differences in our code and basically resolve it into a final file. So let me just press enter and it will open up the editor for us. All right, so here is the editor. We can see the two files over here. This is the feature one. This is the hello.py file in the feature one, and this is the hello.py file in your master branch. And this is what is going to be our main file. So we can go ahead and edit it over here. So you can see there's some extra things. We can remove them. What we will basically keep only those things that we desire. So we only desire feature 1 and the hotfix code to be in our file. So we will go ahead and delete all of these. So once you've recognized your desired file, or made your desired file, all you should do is basically press shift colon and then write wq. So it will write it and then quit this file. For all the other files, you can just go ahead and shift colon and q. You don't need to save any other file here from here. All right, so once you do that, you can press ls and you will see that the two files hello.py. You can go ahead and remove this file rmf. You can remove this original file. You can go ahead and keep this file itself. So if I cat the new hello.py file, I can see that the main code is over here, the feature 1 file is here, and the hotfix code is also here. But we still have to basically create the commit. The commit has not been created, so we have to do that manually. So I will write here git commit -m merged master to feature 1 branch. All right, so you can see that this is back to normal. If we go back to master and if I do git log over here, you can see that there are no extra commits because there were no extra commits made in this. There were commits made in feature 1. Now let's see what happens when we do the same thing in a feature 2. But before that, the feature 1's new file has to be merged back into the master, because the feature 1 has to be merged back into the master because the developer 1 is done with his work, so he will merge it back to master. So we will type in git merge feature 1. So you can see the fast forwarding is happening because basically the commits are similar because these two files have the same base. So basically it just did a fast forward. All right. So if I cat my hello.py file over here, I can see that the feature 1 is there. All right. So now let's head to our feature 2 branch. In our feature 2 branch, if I do a cat of hello.py, you can see that only main code over here. So the developer 2 will start working on this code. So let's assume we are developer 2 and we add the new code, feature code for feature 2. We'll save it. Then we will go ahead and stage it and commit it. All right, now that we've done that, we will go ahead and merge the original branch. Now, instead of developer 2 writing the new code in the starting itself, he could have merged the original file and then started working on it. It's his wish, however he wants to do it. So we will go ahead and type in git merge and then master. So all the contents of master will be merged with feature 2's contents. So let's press enter. We're getting again a conflict because the master branch has different content than your feature 2 branch, and they don't have a common base because there are more commits in master than in feature that feature does not recognize. So let's go ahead and use our merge tool, git merge tool -t vim diff to get our desired file. All right, so we will go ahead and edit our file to get whatever we want. We'll remove this greater than and head these equal to signs. this master. So we have code for feature 2, feature 1, hotfix code, and the main code. So we can go ahead and save this. So shift colon WQ and Q for the rest of them. No need to save them. All right, you know the drill. Just check ls and we see the remove the original dot original file rm-f hello. All right, so you have hello.py. Let's just check it to make sure that it has all the contents. All right, so this is how you would go ahead and resolve any merge conflicts that you face. Now let's move on to the next topic. It's called rebasing. So rebasing is very similar to merge. Now the git rebase basically allows a user to shift a set of commits and give them a new base. It is similar to git merge, but the difference here is that the history of commits of the branch is also carried over when it is joined with the current branch. So basically you have your master branch, and from the master branch you create a new feature branch, and in that feature branch you make a few commits. And once you make those few commits, you don't merge it back into the master branch, you basically rebase it. So what you do is you copy the commits over here, and once you copy them, you paste them onto the master branch. You extend the master branch and you paste them over here. So it's like, shifting the whole set of commits onto the master branch. So it's pretty cool. So it's not same to merge where a merge commit is created. You are just basically shifting the whole set of commits, but you're not shifting the same commits. You're creating new commits that have the basically the same history as the feature branch commits. So the reason that a rebasing may be used instead of merging is when you have a file or when you have a project where a lot of different team members are working, where you have a very busy project, where you have hundreds of developers, pushing and pulling and pushing and pulling the code from the master branch. So this creates a lot of unnecessary merge commits. So merge commits can basically clog up the pipeline when you want to investigate any issues. So in that case, a lot of people use rebasing. So it's a lot more cleaner. The history is, it's not unified into one commit. You have the history clearly put out in the master branch itself. So people can go back and look at the history without having to go into any of the smaller branches. So they can just view the master branch and be sure of whatever they wanted to look at. So that's why some people prefer rebasing, and it basically, it's a requirement based on particular situation. All right, so now let's go ahead and learn how to rebase. So let me come back over here. All right, so we have the temp directory again, but I have a different file over here. It's the main.py. Let's see the contents of it. It's just main code. Now I want to show you guys how rebasing works. So what I will basically do is I will first also show you the git logs to show you that there is only one commit right now, that is called added main.py. That is the commit for the master branch. So we will go ahead and create a branch called feature. I've used feature way too many times to give you guys a better idea. Let's say the other branch's name is develop. All right, so git branch develop, and then we will go ahead and check out the develop branch. Now once we inside the branch, let's make sure that our main.py file is over here, and in the develop branch we're going to add one more file. Now let me go ahead and give this the name hello, or let's give this name kitty. Yeah, kitty.py. Inside of this I'm going to write kitty code. All right, so let me go ahead and save this. Then we will then we will stage it, and then we will go ahead and commit this. Now I'm gonna basically, to help you guys identify, I'm gonna give this hash over here so you guys can identify when we do the rebasing. And now I will write the code commit statement. Oh yeah, right, let's remove the n git commit added kitty.py file. All right, so let's make one more change. I'm gonna go ahead and make one other change into kitty.py. I'm gonna add doggy code. All right, so let me go ahead and save this. Then we will stage it, and then we will commit it. I'm gonna add the hash again so you guys can identify easily. Added doggy code to kitty.py file. All right, so we made a lot of commits in our develop branch. Okay, so let's just use the git log command. Yeah, so we can see that there are, basically three commits. That is one from the master branch, and the other ones are your develop branch commits. Okay, so now let's go back to the master branch. Git checkout master. In our master branch, if we do a git log again, we see only one commit is over here. Now let's go ahead and rebase our master with our develop branch. So remember guys, what basically is happening is that we have one master branch and the feature branch is getting merged onto a master branch. Only difference from normal merging is that all of the commits, both of the commits that were made in feature branch will be copied onto the master branch. So let's go ahead and use the command git rebase and the name of the branch. So that will be develop. So you can see that it's successfully rebased and updated. So if I clear this and if I do an ls, and remember this is in my master branch, I should see kitty.py. If I do a cat kitty.py, I can see all the kitty code and doggy code. Alright, so we have successfully merged it. Now if you look at git log, you will see the actual difference. You can see in our master branch itself, we have the extra two commits, and you can see the hash also, and that helps you identify that these are part of the develop branch and not the master branch. So this is what happens with your basically rebasing. So I hope you guys understood what rebasing is. Well, now let's move on to the next concept. So the next concept is called Git Workflow. So guys, basically when you're working in an actual software development company, a lot of you guys already might have some idea about it. You don't basically have a single or a very simple architecture like how we use to practice all of the git merge rebasing commands. You have a lot of different branches because you'll be working with a lot of different people, and there has to be hierarchy maintained in a very organized manner. So Git is a powerful tool, and leveraging it effectively in software development is very important. This is where the approach of Git workflow comes in. Git needs to be designed. So you need to design a perfect workflow that suits the needs of your team as well as your organization, where you're able to deliver the perfect product with a complex architecture that basically complements that perfect architecture, that perfect product, right? So you can see over here, this is just an example where you have master, hotfix, release, develop, and feature. So all of these are different branches. So let's say that master branch is started out with version 0.1, and feature basically is a branch created of the master branch. Actually the develop branch is created of the master branch. So we have the develop branch. So this branch is where basically all of the features are merged onto. So if you have feature 1, feature 2, feature 3, all of them will be merged onto the develop branch. It contains all the functional code that will be responsible for running the software. And once all the features have been merged onto the develop branch, it can go to the release branch. So let's actually go through this one by one. So we have version 1, and it's made so a branch is basically created out of the master branch, that is the develop branch, and from the develop branch we make a commit, and then we create the feature branch. So feature branch, well, this is basically representation of all the features that there might be in your software. This branch is the one that most developers will be working on, and any and all of the features of the software are coded in these branches. So the developers will pull from the master branch into their local systems, then create a pull request and do their work, and then when their work is done, they it's reviewed by the senior member, and if it's approved, then the branch is merged onto the develop branch, and then your develop branch basically contains all of the different features. And once all of the features have been merged onto the develop branch, then the develop branch is merged to the release branch. So this is the branch where all of the code is reviewed for extra bugs. Release preparation is done and the documentation is completed in this basically branch, and then the release branch is merged onto the master branch. And once it's merged onto the master branch, you have your version 0.2, and the version 0.2 can go ahead for deployment. But the thing is, if there are any issues that were overlooked in develop branch or release branch or feature branch, they can be fixed using a separate branch called the hotfix branch. So this branch, as the name suggests, is used to make quick fixes to the code. This branch allows for the workflow interruption. This allows for basically no workflow interruption, and you can resolve any bugs without doing that. It is quick and it serves a singular purpose of solving the bugs. And then we have definitely our master branch, where basically the code is tagged with a version and it's pushed for building purposes, testing purposes, and deployment according to a certain schedule that there might be, right? So this is how a Git workflow might work in an organization. This is a very generic one. All right, so let's go ahead and try and create our own Git workflow. It's going to be very similar to this. So let me just clear off the screen. So let me create a new folder for this. I will call this workflow. And then we will enter this folder. All right, so once we enter this folder, I'm going to go ahead and initialize this folder. Right, and once I've initialized the folder, I'm going to create the first file, nano main.py. Inside this, I'm going to write all of the main code. Save this, stage this file, commit this file, added main.py file. Alright, so once we're done that, we can go ahead and create our other branches. So first branch I'm going to create is feature A branch. Then I'm going to go ahead and create feature B branch. So they're going to contain features A and features B respectively. Then I'm going to go ahead and create the develop branch. Alright, so we've created the develop branch. Then we will create the release branch. Alright, so we have created almost all the branches. I will create the hotfix branch in the last. So let me just show you guys quickly how it looks like. Git branch, and you can see all of the different branches over here. We have develop, feature A, feature B, and release and master. Right, so we have some code in master. Let's also go ahead and tag that code. And I will initialize this code again. Sorry, stage, commit the code. All right, so we are done doing that. Now we will move on to feature branch A. To do a cat name. All right, so we made one mistake. That was, basically we created all the branches without having the final code. So the code has not been copied. So let me just redo this quickly. So it was a good thing we didn't create the last one, huh? Less work for us. Alright, so if I do a git branch again. Alright, so let me just create them again. I'm doing this because I had forgotten to basically update my main.py code. So let me just do that again. Git branch feature A. Then we will create feature B. Then we will create the develop branch. Then we will create the release branch. All right, so we have created all the branches we want. We will also create the hotfix branch in the end. All right, so let's go to our first branch, that is feature A branch. So the developer A will be working on feature A branch. He will be working on, that is, main.py file. So this is the version 1. So his job will to basically add, extra features. So he will add feature a.py code for feature a. Let's stage it, commit the code. So once the developer is done making all the changes in feature A, he will go ahead and commit the code, added feature A. All right, so he's done doing that. Now we will move on to feature B branch, and we will do the same thing over here. We will create feature b.py. So this will be worked on by developer B. So code for feature B. Let's save this. Then we will perform the same acts again, basically staging the file. Then we will commit the file, added feature B. All right. So let me just change this commit. We keep on adding that N. I shouldn't be doing that, right? So we have basically added our features, right? So our next step is to basically merge these features onto the develop branch. So the developers are done working on their code. Now their job is to basically merge these branches onto the develop branch so that this, it can be reviewed by the team leads or the senior developers. So to do that, we will head to our develop branch. And over here, we will use the git merge command. So let's just show you guys that there is no other code over here. Then git merge feature A, then feature B, right? Okay. So if I do an ls, we can see that feature A and feature B are over here, and our main.py code also here. So these, basically this code will be reviewed, and if the code is deemed successful, then it will move on to the release branch, right? So basically we have our functional software. So this basically makes a functional software. Now this will move on to the release branch. So on the release branch, right, we will move to the release branch, and we will go ahead and merge our develop branch. You can see that the fast forwarding is happening. All right, so we have all the things we need in our release branch, and all of our code is over here. Now, it will sit in the release branch until the scheduled date comes for, for pushing it to the, for building purposes, for testing purposes, and for production purposes. And all the documentation will happen, and all the rest of the extra bug checking will happen. So once all of that is done, right, so it will be merged back onto the master branch. So let's go ahead and do that. Git checkout master, and we will merge release branch. So let's suppose that this is the date it was scheduled for the basically pushing. So this is what we are doing. All right, so if we check our master branch, it has all of the new features now. Okay, so basically now the code can go ahead for basically building purposes, testing purposes, and production, for the go to the production environment. So our job here is basically done. We have created a successful Git workflow. We are missing out one branch, so that branch is usually used when there is a quick fix needed. So suppose there was some issue in feature b.py that was overlooked by everyone. We will go ahead and create a hotfix branch for that. And let's check out the hotfix branch. And if I do an ls, you can see all of the features are already here. Now in this, we can go ahead and change So inside feature B, they wanted to change the code. So we will write over here, code was changed in hotfix. Right, so let's save this, let's exit it, and we will go ahead and stage this and commit. Git commit message added hotfix to feature B, and enter. All right, so our work here is done in feature, that is our hotfix branch, and we will go back to the master branch and merge hotfix onto the master branch. Git merge hotfix, and there we are done with the whole workflow. So if I do ls over here, we can see our feature B again, and if I list the values, we can see the values are here now. Now guys, I want to show you guys how it might look, all the commits, how it looks. If I do a git log in master, you can see a lot of the things over here. Let me show it you in a graph form, so we can do that. Git log hyphen graph. You can see the graph over here. So this is what it looks like. We have one master branch, and we have a lot of other branches coming back and committing and merging onto our master branch, right? If you wanted to see it in a little better way, we can go ahead and use another flag called online. Sorry, one line. Yeah, so this is how it looks like. I hope you guys understood how the workflow works and it was helpful for you guys. Oh, one more last thing I want to leave you guys with is a command that is called git pull. Now git pull is the one that you guys will be mostly using a lot, because instead of git clone is originally used when you want to clone a specific repository from remote cloud onto your system. But once you've done that and you want to update that the whole file you have, if you want to update that whole master branch you have on your local system, instead of cloning it again into another location, you just pull again from the remote repository. If there are any changes made onto the remote repository, you basically pull it and it will update your local repository after you use the git pull command. So that's how your git pull command works.
Microsystems and containerization with Docker. So we'll be learning about microsystems architecture, that is used to deploy software, and then, the containerization aspect of software development itself. And we will be learning all of this in conjunction with the Docker tool. So we'll be asking questions like, why do we need containers? What were the issues we used to face before containerization? How does Docker help us in all of this? And, what is orchestration? And how do we make use of orchestration, etc., etc.? So let's get started by, discussing the issues we used to face before containerization. Now, this is an important thing to discuss because we want to know why containerization is there in software development in the first place. To understand this, we have to see what used to happen before containerization was a thing. So let's imagine a standard delivery pipeline. We have a developer. This developer writes some code, and this code is taken together with the dependencies. These dependencies can be your libraries or your functions. They're taken together with the code and they're built. So the process of building happens, the code becomes an executable file, and then it goes to the tester. Now the tester starts testing this build for various different things. He will do unit testing, acceptance testing, integration testing, and all the different types of various testings there are. He wants to make sure that the product is as, perfect as possible, and it meets all of the requirements that were discussed in the requirements phase of the whole software development process. So if he thinks that the software is not up to the mark, he notifies the developer of the same, and then the developer starts rectifying that mistake. Now, once the developer has, finished rectifying the mistake, the whole thing repeats where the developer sends the code again. The code is taken with its dependencies, the libraries and functions. They're built into a single executable, and they go to the tester again, and the tester tests it again for all the various different things. Now, this time the tester says, okay, it's fine to go ahead for deployment. So this software goes ahead for deployment. So this is a very simple yet standard delivery pipeline, right? So it's not obviously going to be like this. You'll have a lot of various requirements that will change how a certain software delivery pipeline will look like. But this is a standard, right? So keep this in mind. Now let's talk about what are the issues that can occur in such a pipeline. To understand those issues that can occur, let's start discussing the environments that the developers and testers use. So let's look at the developer's environment. Now let's take up a scenario also in our minds. Let's say that the developer is a backend developer. So let's look at his environment. So he has a CentOS operating system. That's the company standard that's being used. And he has PyTest 5.4.3, the software he's using for testing his Django backend code. And he's using the PyCharm integrated development environment. And he's writing the code in Django, that is your Python framework. And he has certain dependencies so that the code can run. Right? These can be the frameworks or the libraries or the functions that are used to make the code run. So on his computer, this developer has made sure that the code runs. He's, used the latest version of PyTest because that's what works with his code. That's what his requirements, make him use. So these things form his environment completely. Now let's look at the tester's environment. So the tester has a similar environment, but you'll see a little bit, of different versions. So you see that the CentOS operating system is again being used, but the PyTest is of the older version. It's 5.3.0. And the integrated development environment he's using is Spider. But he's working on the same code. He's working on the same Django backend code, and he's working on the same dependencies. So the environments are pretty same, but they have some differences. So what happens when they have these kind of differences? So let's, say that the developer, he's made sure the code runs completely fine on his system. He's fine-tuned the code so that it can run completely, normal on his system. He says that this code runs fine on my computer because he's made sure that it runs fine on his computer. Maybe in the starting it didn't run, so he, corrected a lot of his mistakes by, using some other version of a certain thing and made sure that the code runs on his computer because that's his job, right? And then the code goes to the tester. Now the tester tries to do the same thing, but he doesn't know exactly about the context of the code he's working on because he won't always know it. He will know through the documentation, right? And through the meetings and the discussion with the developer, but he won't always know the exact context. So he tries to run the same code on his system, but this time he says, the code does not run. So he says that this code does not run on my system. Now you can see that it's the same code and it's the same dependencies, but the code is not running on one system while it's running on the other. Now, why is this the case? To understand this, we looked at the environments. So if I bring up the developer environment, the test environment, you can see that there are two differences, that the developer is using PyTest 5.4.3 and PyCharm IDE, and the test is using PyTest 5.3.0, and he's using the integrated development environment Spider. Now he's using PyTest to perform, they're using PyTest to perform all the test cases. Even the developer runs his own, smaller test cases. He wants to make sure that, all the basic things are running, whereas the tester also wants to do that. But the difference is that they're using different versions. Now, this won't always be the case, but sometimes when the versions of a particular software are different, the compatibility issues start to occur. Now, this is very clear when you're working with Java. So all of those people, who have worked with Java know that Java 8 and Java 11 don't always have the perfect compatibility. Sometimes code runs on one and it doesn't run on the other. Sometimes it runs on both, right? Now, these people have a lot of headache already on their mind. They have to deliver software on a certain deadline. Compatibility issues should not be one of those headaches that should be on their head, right? So to resolve this, we make use of containerization technology, right? So now let's see what happens when we introduce containers. So when we start using containers, we see that the developer and testers don't have any problem at all. Now, why is this so? How does container solve the issue that we were facing? Now, that's a very interesting topic, which we will now discuss when we talk about what is a container. So let's see what is a container. Now, containers are software that wrap up all the parts of a code and all of its dependencies into a single deployable unit that can be used on different systems and servers. So you have your code and libraries, which is put inside of a container, right? So this is exactly what's happening. You're taking your code, your libraries, and even your operating systems and putting them into one container. So imagine this container as a box that contains all the integral information, software, tools, and the source code itself that is required to run the source code. So basically, it's like a VM where you're running everything inside of it. So this basically removes any compatibility issues we may have had earlier. Now, this is so because in the diagram, you can see that the container is the one that is being passed along. The developer takes the container, puts all of the necessary items inside of that container. This is the code, these are the dependencies, and this is the environment, like that is the operating system. And he shifts all of it together in one container and gives it to the tester. Now tester takes this container and he executes the code and then runs test scripts inside of the container itself. So this way, the code is not interacting with the outside or the host system. So this way, even if the developer and the tester have different systems or different versions of specific, tools, it does not really affect how the code is working in their systems, because the code is just, being shipped in a package and it's being executed inside of that package itself. So this removes all of the compatibility issues that may have occurred in their systems earlier, because the developer specifically added in the container the CentOS operating system, the PyTest 5.4.3, and he put in the code and the dependencies all together and he gave it to the tester. So the tester doesn't have to use his own PyTest. He already has everything he needs to execute his test scripts inside of that container. So this way we remove any possibilities of having compatibility issues. Now the great thing about containers is that they are very portable and they are platform independent. They can be executed in certain platforms without having any issues themselves. So that's where they're amazing, right? So again, let me reiterate, containers are software that wrap up all the parts of a code and all of its dependency into a single deployment unit that can be used in different systems and servers. So, that's what containers do, and that's what containers are. Alright, so you can basically create multiple containers also, and you can launch these multiple containers together to form microservices which can be easily managed using any of the orchestration servers. So if you have multiple containers and each of these containers contain different parts of a code, then you are forming a microsystems type architecture, and you can handle them, all of them together, using either, Docker Swarm, Kubernetes, or any other tools that are available out there for orchestration. Alright, so to understand containers better, we will go ahead and compare containers to virtual machines. Remember I told you guys to think of containers as virtual machines? They're actually not the same thing. They're different. So we will go ahead and take a container and we'll take a VM and we'll compare them using a set of criteria. So let's compare them. So here's the criteria that, we've used. We are going to compare them based on the operating systems, the architecture that is being used, the isolation that they both provide, the efficiency with which, they can do certain tasks, the portability of each of them, the scalability, and lastly, deployment. So this will give you guys a better idea of what containers are and how we can use them. So let's look at the operating systems of the containers versus VMs. So with containers, they only contain the bare minimum parts of an operating system that is required to run the software. So like we discussed in our example, right, the CentOS operating system, it will not be completely included in the container. Only the bare minimum parts of it that are required to run the software are included in the container. Now, this is important because you don't necessarily have to include everything of a particular operating system. Let's say you're working with a Windows container. So in that container, you will only have the basic parts that run a Windows operating system. You won't have its GUI because you don't need the Windows system GUI to run the software inside of it. You need the Windows operating system itself. So making updates in containers is very easy and it's very simple to do for the operating system. Whereas with VMs, right, the virtual machines, they contain the complete operating system that is normally used on systems for general purpose. Like the normal everyday Windows system we use, if we wanted to run a VM, we have to run the whole operating system on it. So this way it eats up a lot of resources, and updates are, usually very time consuming and they're very tough. So you can see how containers are much better in this scenario where they only have the bare minimum parts versus the whole, whole blown guest operating system. Alright, so now let's move on to study the architecture of each of them. How do they occupy space in the host operating system? Now, both containers and VMs, they are independent machines, but they don't run independently. They need a host server or host system to run on. So we have a host operating system, which is on some hardware, and inside of it, you can see there are apps and services and kernel. So container basically occupies a very small space where it, basically uses any of the resources it needs from the kernel itself directly. It has its own apps and services, but it does not, it's not completely isolated from the whole operating system. It does not form its own operating system that is based on the hardware. You can see that the case is totally different with virtual machines here, where the host operating system is its self-contained thing and the virtual machine is its own self-contained thing, where you definitely interact, with the virtual machines using the operating system, but then the whole resource management is handled by someone else. Like you basically use hypervisor to, allocate resources in a virtual machine. We will not talk about it. It's a, different topic altogether. So just understand, a hypervisor used in virtual machines. So you can see with virtual machines, you have apps and services and it has its own kernel. Whereas with the container, it does not have its own kernel. It basically makes use of, the operating system that is already present kernel. So it kind of acts like a, normal software or a normal program, the container versus the virtual machine. So this is how the architectures differ from each other. Alright, so now let's go ahead and talk about isolation in containers versus in virtual machines. So the isolation provided by a container isn't as complete as of a VM, but it is adequate enough. Whereas with virtual machines, they provide complete isolation from the concerning host system, and they're also way more secure. This is because, the virtual machines have their own operating system where they have their own kernel, their own apps and services, and they have very limited interaction with the host operating system. Whereas containers act as, programs or softwares within the operating system itself. They're not that isolated. Now, the isolation with containers is adequate, whereas with VMs, it's much, much better, right? With VMs, if you have any malware that is affecting the host system, it will, barely affect the virtual machine. So that way VM is way more secure. So you can see the difference over here in the isolation policies for containers and virtual machines. Then let's talk about efficiency, the differences between the containers efficiency and virtual machines efficiency. So containers are way more efficient as they utilize the most necessary parts of the operating system only. They act like any other software on the host system. Whereas with VMs are less efficient as they have to manage full-blown guest operating systems. VMs have to access the host resources through a hypervisor. So you can see with containers, they only need very little, resources because they're making use of, only the bare minimum parts of an operating system. They're not making use of the whole thing. And since they're not making use of the whole thing, they don't need that many resources. This makes them more efficient. You can run way more containers you can do on the same resources on which you can run a set number of VMs. So if you had like 3 VMs, you could run them on maybe 30 resources. Then for 30 resources, you could run like 6 containers or 10 containers. So this way containers give us more efficiency compared to virtual machines who have to handle, the whole guest operating system. So they have to utilize way more resources. Portability. So let's talk about the differences in, containers portability versus VMs portability. So containers are self-contained environments that can be easily used on different operating systems. Whereas VMs aren't that easily ported with the same settings from one operating system to another. Because again, the whole having, being lightweight versus, heavyweight. So containers are very lightweight and they're self-contained environments. So they're portable across multiple platforms. And that is the whole purpose of containers also, where you use them, to maintain a consistent environment across different platforms. So they're designed in such a way. But with VMs, this isn't the case. It's very not difficult, but it is very time consuming. And it, you have to put in a lot of effort to shift one VM from one system to another. So this way, container shows more promise in portability versus virtual machines. Scalability. Now, scalability is important when we're talking about a growth in a company or, having an auto scaling feature depending on how many users, how many resources you have and, how many services you can provide at a time. So let's compare that for containers versus virtual machines. So with containers, they are very easy to scale. They can be easily added and removed based on requirements due to their lightweight. Whereas with virtual machines, they aren't that easily, scalable as they're very heavy in nature. Since containers are such lightweight contenders, you can easily, just take them out of a cluster and, put new ones in the cluster if you want to. So, that way you can see the promise of scalability that containers have versus virtual machines. Virtual machines handle, big OS, big operating systems. So it takes time to remove them, add them into the whole architecture, and they use a lot of resources also. So you have to think about the resource management that is going into the managing all of the different virtual machines you have in a set cluster. So this way, again, containers get the upper hand with the scalability they offer for software development. Now let's talk about deployment. So deployment is again important when you talk about software development, because you have to give an end product to the user, and the end product you're giving to the user should be very easily managed and should be very easy to maintain. The upkeep for the software should be low. So with containers, you can see the containers can be deployed easily using the Docker CLI or making use of cloud services such as AWS and Azure. And similarly with VMs, VMs can be deployed using PowerShell or by using, Virtual Machine Manager or using cloud services such as AWS and Azure. So you have a lot of options for containers as well as VMs. So containers, you have, the management part is much more easier because you have a lot of orchestration tools that are specifically designed to, launch these smaller, lightweight containers in a cluster, manage these clusters, and, scale them, auto scale them based on requirements. So this way, again, you can see how the deployment happens with containers as well as with VMs. You have a lot of different services that help you do the deployment. So these are the different, differences between a container and a virtual machine. So I hope that gave you guys a better idea of what containers are and how are they different from virtual machines. In conclusion, containers are lightweight virtual machines. You can think of them like that. And they have some, they have some unique advantages. So we will talk about this right now. Why do we need containers? So there are two important aspects to containers. One of them we've already discussed. One aspect is that, they give us the ability to have consistent development environments across our delivery pipelines. So if you guys remember when we were talking about the standard delivery pipeline, that, the developer and the tester had certain, differences in the environment that they were making use of. And, because of the differences in the environments, they were having compatibility issues, which was a big headache because they already have to worry about delivering a product / service, and they shouldn't be worrying about compatibility issues. And this way, containers really helped them out, by, giving them consistent environment, making sure that everything you need to execute a software is inside of a container itself. You have the operating system, you have all the dependencies, the code, and the tools that are needed to execute the code inside that one container. And you just, pass the container across the whole different set of environments. And this way, the developers and testers don't see any compatibility issues. And they're successful in developing, testing, building, and deploying the code. So this way we keep consistent development environments. There is another reason why containers are very significant in software development, and that reason is because of microservices. So when you talk about software development these days, you don't talk about monolithic, architectures where you have like one single file which has all of the code. You usually divide the software application into different parts. It can be 5 parts or 6 parts, depending on how many services you're providing within your product. So let's say you are a food delivery app. We'll take that example again, where, you have to give your customers many different options. You have to, tell them how many restaurants there are nearby. That's one feature. There's a payment feature, and there's a tracking feature, how long your order is going to be taking. And there's a grocery shopping feature where you can directly contact the grocery shops nearby. And there's a account managing feature, there's a subscription feature. There are a lot of different features, and all of these different features are worked on by different teams. And they create these features in iterative process where they release the better versions of these features, in regular successions after getting feedback from customers and teammates alike. So these features basically together form the whole application. So if you look inside an Android application, you see that, there are multiple features, right? And these multiple features together combine to form the single software. And that's where the microservices architecture comes in. It's basically saying that, you have multiple different services. You have multiple different microservices. And containers help us in, creating a microservices architecture by helping us contain these services, together. So you have 5 services, let's say, and all of them are connected together by making use of containers. You keep these services inside of these containers, and these containers are inside one cluster, and they talk to each other inside of this cluster for integration purposes. You can scale them, based on your requirements, and you can scale either one feature itself or the whole software itself based on what you need to do. So this way you can see that there are 2 aspects of why containers are very much needed and why they are so helpful in software development process. So now that we have completely understood what containers are, we can move on to learn about Docker. What is Docker? So Docker is basically a containerization tool. It is a tool that helps us in developing, building, deploying, and executing software in isolation. It helps us to do so by creating containers that completely wrap up a software. So we talked so much about these containers, right? So who creates these containers? How do we create them? So that's where Docker comes in. Docker basically helps us to create these multiple containers in which we can contain our application / software. And once we have contained it, we can go ahead and perform all the different things we do in software development. That is develop the code, that is, build the code, that is test the code, and, deploy the code, monitor the code. All of it happens, in these multiple containers that we use to contain our software. So you can see that, you have an application. That application is, contained in multiple containers, and then it goes ahead for deployment. Now, a good thing about, using Docker is that, creating containers using Docker creates a layer of security around the software. This is because of how secure the Docker containers are. Now, there are a lot of different types of containers you can use, like created by different tools. You can use the ELK containers. You can use the RKT containers. Now, the whole concept of containerization isn't something, that, Docker has created. The idea of containerization has been there for a long time. It was in people's mind, and people were actually implementing some form of it. The thing is that Docker popularized the idea of it. It made it very easy to use containers, and orchestrate these containers. And Docker it's an open source tool, so you can go ahead and learn from Docker, using their open source community editions. But there are also enterprise editions also. If you're looking for that, you can go ahead and use them for your organization. Now, it was developed in the year of 2013, and since then it's been one of the most popular containerization tools that a lot of people use. Now, you may use a different orchestration service to handle all of these containers, but a lot of people definitely gravitate towards using these containers that are created by Docker. Alright, so why Docker itself? So on their website, they list a lot of different reasons. Now, Docker is a company, so they do have to make money. So they do, try to sell their product. So they tell us why you need to use Docker. So let's see these reasons that they've given us. So it's simple. Yeah. So what they say is true. Docker is pretty simple. You can use Docker CLI. You can learn it in 1 hour or even less. And it's very fast. Yes. When it comes to deployment purposes, Docker is very fast in doing that. It provides you the ability to have easy collaboration, which is again true. If you have any images for Docker, then you can easily upload them to a central repository or even to Docker's own Docker registry, where you can store your Docker images and share it with your teammates, or keep it public so that anyone can use. So definitely true. Yeah, it has very easy collaboration feature. Built for developers by developers. So it was built by a developer. So they took in consideration of what would a developer look for, and they developed the container in such a way. And then Docker community. So they say that the Docker has a very big community, and that's true. Docker has a very large community since it's a very popular open source tool. A lot of people, tend to contribute to Docker, and this way they give it a lot of other features and other parts. Docker, they provide contributions to those so that everyone else can benefit from it. So yeah, it has a very big community also. So these are all the different reasons you should go ahead and use Docker, and they're kind of true. They all make sense, and they actually do benefit us in software development. Alright, so now let's quickly go ahead and learn how to install Docker and set it up. So you can, basically work with Docker on almost any operating system. You can use Linux, any of the Linux distros there are. You can use Windows, or you can even make use of Mac. Now, generally, Linux and Windows are the more popular ones, where you run your servers for your software or application on either Linux servers or on Windows servers based on your requirements. All right, so we're gonna do two things. We're gonna go ahead and download Docker on Linux, and we will download Docker on Windows. Now, to do it on Linux, I want you guys to go ahead and follow this method. Even if you have Linux on your system, I want you guys to go ahead and follow the system I'm gonna use, the way I'm gonna be launching a Linux distro on AWS Management Console. Now, why are we going to do this? We're going to do this because, when we start learning about more advanced, complex, methodologies and technologies, we will require, using multiple servers at the same time. So for that, we will need to use AWS Management Console. So the first step for us is to go ahead and create an account. I've already done that. And once you've done that, go ahead and log in into AWS Management Console. All right. So once you've logged in, click on Services and go ahead and click on EC2. So this is the EC2 dashboard. What we're going to do here is we're going to launch an instance. So EC2 is a service that allows us, it's an AWS service that allows us to basically launch multiple servers or, instances. To launch these instances, go ahead and click on Launch Instance and click on Launch Instance in the drop menu. And when you do that, it will give you a lot of options. So it will give you an option to choose a different image for launching these instances. Now you can use any kind of operating system you want to use, generally speaking. But in this session, we'll be, basically using Ubuntu. Now Ubuntu is one of the most, popular Linux distros out there. So, it will be, some of you guys may already know how to use it. And if not, that's all right. Okay, so when you come to this page, you will see an Amazon machine image. So you can choose an Amazon machine image. So it is basically a template that contains software configurations, basically your operating system, your application server, and applications, right? So we will go ahead and select Ubuntu. If you can't find it, go ahead and search it over here. You can use many different options, generally Amazon Linux, RHEL, Ubuntu this is the one we're going to use. Go ahead and click on select over here. And make sure that you're using a type t2.micro because it's part of the free tier. So, when you're getting the free account, you want to make sure that you're not spending any real money. So go ahead and click on t2.micro and click on next configure instance details. Over here, we only want one instance. And I'll suggest you guys leave all of the other details as default. Then click on add storage. We will leave this also as default. Then even add tags, we'll leave this as default. In configuring security groups, we're going to go to click on, type, the type, and we'll make it all traffic. And the source will be anywhere. So this is basically to avoid any networking issues. We'll later learn how to, basically make it secure. And then click on review and launch. Then you're going to go ahead and click on launch. And here you have to pay attention. So choose an existing key pair. So here guys, if you already have a key pair, go ahead and select this. But if you don't have a key pair, click on create a new key pair. And it will ask you to type the name of the new key pair you will be downloading. So let me type in over here, Docker practice -practice. I'm going to click on download key pair. It will download a .pem file for me over here, as you guys can see. And this .pem file is basically your, it's your key to logging into this instance. So let me just close this. Launch instances. So it will start launching instances based on the configuration details you've given it. And you click on view instances. And you can see that your instance is, it's loading up. While it's loading up, you can go ahead and name this Docker session practice No need for such a long name. We'll just keep it short and simple, Docker itself. All right, so this is your instance. You can view all of your ID details for your instance that you launched. This is the IP address. You're going to be accessing it using this. Now there are two ways to access this instance. You can go ahead and SSH into it using any terminal you have, use SSH command and make sure that you have the key in your working directory. And there is another way to do this. You can go ahead and use a SSH client. So the SSH client we'll be using is PuTTY. So PuTTY basically will help us to connect to this, Docker instance, this Ubuntu instance. Now to download this, what you can do is you can go ahead and type in PuTTY download on Google. You should click on the first link that you get. So download PuTTY, a free SSH client for Windows. Go ahead and click on, you can download PuTTY over here and it will download PuTTY for you. Now the thing with PuTTY is you need to basically, download, so you can go ahead and click on PuTTY 64-bit installer. So once you click on this, it will give you an option to, download it, and you go ahead and download it. I already have it, so I won't be doing it. So with the thing with PuTTY is you need to use a .ppk file instead of a .pem file that we had downloaded. Now to get the .ppk file, you need to convert it from .pem to ppk. So what you can do is open up your search bar, just type in PuTTY after you've downloaded PuTTY, and you will have two options, PuTTY and PuTTY-gen. So click on PuTTY-gen. So this will basically create the .ppk file for you. To generate it, you need to load up your .pem file. So go to the location where your .pem file is. So here is my .pem file, docker practice.pem. I will go ahead and click on open over here. So this is loaded now. I'm gonna click on OK over here. All right. So once you've loaded your file, right, you can go ahead and click on save private key. So it will convert your .pem file to a .ppk file. Are you sure you want to save this key without a passphrase? Click on yes. And it will ask you for a location to save this file on. And you can go ahead and type the name in. You can type in docker practice, remove the .pem, and make sure this is putty.ppk and click on save. And if you go to that working directory, you will find your practice file over here. All right. So this is your PuTTY private key file. So this is your first step done. Now you're going to go ahead and click on, just find your PuTTY itself. Just open PuTTY, not PuTTY-gen this time. And when you open it up, it will ask you for a host name. So go ahead and, copy the IP address over here and paste the IP address. You can change the appearance if you want. I'm not going to change it. Then click on SSH under connection, go to authorization and click on browse. Once you do that, go to the directory where you have your new key saved. My key is Docker practice. So I'm going to click on Docker practice and I'm going to click on open. Yes. Make sure you do all of this process after the instance state is running. Okay. So it will ask you a login as. So the login as will be Ubuntu. So that is the username I'll be using to log in. Let's go ahead and change the appearance so that this is more clear and visible to you guys. All right. So now we have logged in into our instance. So we have a Linux instance open. So if you guys have followed my steps, you should also have this instance open for you. So this is our Ubuntu instance. So there are two ways to install Docker in this. You can go ahead and make use of Docker's own repository and install Docker from there, or you can, get it from Docker directly if you want. So we'll go through both the ways so you guys understand how to do it. So for practice purposes, use the easy way. So let me go ahead and do that. Sudo apt. We'll first update this instance. All right, now that we're done updating it, we will go ahead and install Docker. Sudo apt install docker.io. So this is the easy way. Basically one command itself Go ahead and press enter. It will ask you yes or no. Click on write Y and press enter, and it will basically install Docker for you. All right, so let me show you the second way also. So let me first remove Docker right now, and we will install it again. So for the steps for those are here. So first, you updated. We've already updated our instance. Then we need to go ahead and install some packages to our instance. So the command for that is this. Let me copy it and paste it. Sudo apt get install app transport https ca certificates and curl software properties common. Let me press enter. Yes. All right, so we have installed a few packages. Now we're going to go ahead and get the key for the repository so that we can install Docker. So for that the command is over here, and we've added the key. Now let me go ahead and get the repository, copy. All right, so we added the repository. Now we will go ahead and update our instance once more, and we will go ahead and install Docker CE, that is the Docker Community Edition. Yes. So this method is a bit longer, but it will get you the latest version of the Docker Community Edition. Whereas, using the simple command of, Docker install docker.io will get you the version that is there on the Ubuntu repositories. All right, so we have installed Docker over here. Now I just want to show you guys to, the command that you use to check the version of Docker. So that is sudo docker. You don't need to use sudo, just hyphen version. So press enter and it will give you the version of Docker that you have on your system. All right, so this is how you would install Docker on Linux. To install Docker on Windows, what you need to do is just go to your browser and go to Google. Search this Docker installation on Windows. So the first link, just go ahead and click on that. Install Docker desktop on Windows. Now you can directly click on this download from Docker Hub, but make sure to read the system requirements. So you have a few system requirements here. Like Windows 10 64-bit, it's a must for you to have this, especially the Pro version or the Enterprise version or the Education version. And you need to have Hyper-V and container Windows features enabled. Make sure you have a 64-bit processor with second level address translation for at least 4 GBs of system RAM, and BIOS level hardware virtualization support must be enabled in your BIOS setting. And if you don't have this Windows system, what you can do is just scroll down on your left hand side and you'll find something called suspended products and tools. Go ahead and click on that. Click on Docker Toolbox Legacy and just click on Install Toolbox on Windows. So this is something that used to be used before the option we have right now. And for a lot of people who don't have the Pro version or the Enterprise version or the Education version, you can go ahead and use Docker Toolbox. So click on the Install Toolbox on Docker. Just check the versions. Toolbox Overview. And it has a wide description of what to do and how you can do it. You can install this, but if you do have the required versions, just go and install the Docker for Windows. For that, you have an option over here. Click on download from Docker Hub. So you can get the stable version. Just go ahead and click on get stable and it will start downloading the .exe file. I already have the exe file. Let me just cancel this. Open my downloads folder and show you guys. Okay, so I have the Docker desktop installer. You guys will have it too. Just, double click it. It will open up. You should see that, Docker desktop is downloading the package, and then we'll start installing the package. So I already have it downloaded and installed on my system. You guys can see that there is icon will appear on your desktop, and make sure to give it the permissions. And to make sure that you have Docker desktop installed, you can go ahead and press Windows key and R. So go ahead and launch CMD over here. I already have it launched over here. And type in docker -- version, the same command we used with Linux. And if you have Docker installed, you should get this answer. And there's one more thing that you guys should keep in mind. So I've already, installed Docker over here. It will restart Docker once you've installed it. And once you come back, once you double click it, it will probably give you guys this error. So this is the error where the hardware assisted virtualization and data execution production must be enabled in the BIOS. So what you need to do is, you need to follow this documentation that is given over here and enable the BIOS, the data execution production and the virtualization. Now you need to make sure that virtualization and these two are enabled. To do that, just go to the BIOS, and there's a documentation for that. All right. So this is how you would go ahead and install Docker in the Windows system, right? So let's just summarize it. If you want to install on Windows, you need to have Windows 10 Pro or Windows 10 Education or Enterprise version for the latest version of Docker. But if you do not have that, it's all right. You can go ahead and use a legacy tool, that is a Docker toolbox, and you can install that and start working with Docker. So it will just be like a normal terminal when you start working with Docker toolbox. All right, so that's it. That's for installation of Docker on Linux and Windows. We studied how to install Docker on Linux and how to install Docker on Windows. All right, so now let's move ahead and see the Docker common commands. So I will be going through all of the Docker common commands with our Linux distribution that we had, installed. So let me open up that file over here. So first thing we will do is we will go ahead and type in sudo so we get root access. All right. Over here, I want to show you guys a few commands. So one of the first commands is going to be docker image ls. So what this command will do is it will list down all of the images that are there inside of your system. Right now, there are no images in your system. That's why it's not showing us anything. So if we did a docker pull Ubuntu, so it will pull an image for Ubuntu. You can see this is how it will pull the image. And if we do a docker image ls again, we can see that that Ubuntu is there in our repository. All right, so let me clear the screen and show you guys one more command. It's called docker ps. It's basically used to check how many containers are there in your system. So if I do a docker run Ubuntu and do a docker ps, let me just show you guys. If we do docker ps -a, you can see that our image is over here. Is that it exited, right? So there's a reason why it exited. We will talk about it later after we discuss the Docker environment and get to know what are the different objects in Docker, right? So we get a better and clearer understanding. So let's go ahead and do that. So Docker environment. So now let's discuss everything that makes Docker. All of the different parts that help us to, basically use all of the features that Docker provides us. Now, there are different parts like Docker engine, Docker objects, Docker registry, Docker compose, and Docker swarm. And we will learn all of these, one by one. So let's start off by discussing Docker engine. So like the name suggests, it's basically the engine of Docker. It's what, basically makes Docker. It's what, it basically does all of the processes. So as the name suggests, it's the technology that allows for the creation and management of all the Docker processes. It has three major parts to it. You have Docker CLI, Docker API, and Docker daemon. So basically Docker CLI is all of the Docker commands we put in, like Docker version, Docker images, or Docker PS, or Docker run command, all of those part of the Docker command line interface. It's something that we use to interact with Docker. So that's what Docker CLI is. And it forms a major part of Docker engine. And then comes the Docker API, or Docker application programming interface. So this part of Docker engine is basically, it's responsible for communicating all the requests from the Docker CLI onto the Docker daemon. And daemon is the one that, does all of the processing and managing of all of the different various processes that, we can create and manage in Docker. So let's say you were the user and you asked Docker to create a certain object. So you would do that using the Docker CLI. You would, create your image or the volume or a network using Docker CLI. And that request will be communicated by the Docker API to the Docker daemon. Now, once the daemon understands the user's request, it will go ahead and process that request. This request can be to create a container, to create a network, or to create a volume, or, do any different sorts of things that Docker can do. Now, once it does so, we will get a visual output of what is being done. So this is how the Docker engine works, and these are the main parts of Docker engine. Now let's study the different Docker objects there are. So these are the different objects we'll be creating and interacting to, basically fulfill our purpose of containerization. So we have different objects. Let's see them. We have Docker images, Docker containers, Docker volumes, Docker networks, and Docker Swarm nodes and services. So you guys already know one of these. You already know what containers are over here. Now let's see what images and volumes are. So Docker images. So Docker images are a set of instructions that are used to create containers and execute code inside of it. So if you're a user and you want to create that container, we've talked about containers before, and we know containers are wrapping software, or they're boxes that contain everything that is required to execute a software, the operating system, the code, and all of the code's dependencies and the tools necessary to execute and test that code. So how do we create these containers? To create a container, we need a blueprint for the container. It's like how you create a house. To create a house first, you need to basically create the blueprint first, and then you go ahead and create the house, referencing the blueprint. So similarly, a user will first create a blueprint for his container. He will mention all the different configurations inside of this blueprint. He will mention what kind of operating system there's going to be. He's going to mention, what is the port at which this software is going to be exposed at, this container is going to be exposed at, and he's going to mention what kind of network it will be a part of, and he's going to mention what all the different commands are going to be executed inside of it. All of that will be mentioned in the Docker blueprint. Now, this blueprint will then be, created once the Docker daemon basically reads the blueprint. The Docker daemon will read the blueprint and he will create a container based out of it. So these blueprints are called images. So you create a Docker image, you pull a Docker image, and then you create a container out of that image. So that's what Docker images are. They are set of instructions that are used to create containers and execute code inside of it. So for example, if you wanted to create an Ubuntu container, you would basically, mention that in your Docker image. You would write that down in your Docker image. And when the container is created, it will automatically have the operating system inside of it. So, let's go ahead and create our own image and work with it. So right now we won't create our own image. What I will do is I will show you guys how to pull an image. So what pulling is, basically we are taking an image from the cloud. It's a cloud that is provided by Docker. So it's like it's a place where all the basic images are there. So the image we will pull is Nginx. So if you want to pull an Nginx image to create a container out of, you will go ahead and use this command. Now we will learn how to create an image also. All right, so if we do Docker image ls or images, we can see our image over here, right? So now let's see the other objects. So Docker volumes. So Docker volumes are basically persistent storage locations for containers. They can be easily and safely attached and removed from different containers. So imagine Docker volumes as basically hard drives. You have hard drives to store different kind of things, right? Similarly, volumes are used to store different kinds of things for containers. So these containers are our operating system and the code, right? So they need to store data sometimes. To store the data, we make use of volumes because they're persistent storage. Now, these containers themselves cannot completely permanently store data by themselves. They need to make use of these external storage devices. And that's what volumes are. They basically help us to store data for a container. Now you can, easily remove a volume from a container. You can remove it and you can attach it to any other container. So it can basically be, passed around. So that's what makes it amazing. It's like a hard drive that, you pass it around among your friends or among your colleagues to share the data. So similarly, you use volumes to, share the data or, make use of the data in specific functions. So Docker volumes they're basically persistent storage locations for containers. Then Docker volume drivers. So Docker volume drivers allow you to perform unique abilities such as creating persistent storage on other hosts, cloud. They basically help you to encrypt these volumes. Imagine Docker volume drivers as basically drivers that help you enhance the ability of a particular volume. It's like, the whole example with hard drive, if you want to increase the storage space for the hard drive, or if you want to make sure that hard drive is encrypted, then you make use of a driver. Similarly, with volumes also, you make use of drivers to enhance the ability of a volume. You can, volumes can store space in your own local system, or you can make it so that that volume has its, location in a cloud. So you have drivers for these specific kind of things. So those are your volume drivers. All right, so now let's talk about Docker networks. Now, Docker networks arguably is like one of the most powerful, like one of the powerful things that are about Docker, because it helps you basically connect all the different parts of a container together. Not just the container, you're talking about connecting different containers together actually. So a Docker network is basically a connection between one or more containers. So if you have a set of 3 containers and these containers together form one application, so they want to talk to each other because they may be dependent on each other. So you connect them using a Docker network, and you can do this with even sets of different containers. If you have the first set of 3 containers and a second set of another 3 containers, and you want to make sure that these containers talk to each other, these sets of containers, so you can even put a network all around them. So containers, this makes it very easy to isolate and manage these containers, especially when it comes to managing and making sure that there is a wall between containers that shouldn't be talking to each other. So you create some form of abstraction where a certain set of containers only talk within each other and they don't talk to anyone else. So that's your isolation property. So these are your networks, Docker networks. All right, so now let's talk about the Docker registry. Now, Docker registry is basically a dedicated location. It can be any location where you store a set of images. Now, we talked about images, right? They're blueprints for containers. You can have customized blueprints that you create by yourself, and you store them in one dedicated location so that you can share it with your teammates or share it with your other teams, etc. So when I talked about developers and testers sharing that container, they don't exactly share the whole container itself. They share the blueprints. So the developer will create the blueprint, the image. He will create the image for a custom container, and he will push it to a Docker registry. So when the tester wants to use it, he will pull it from that Docker registry, put it on his own system, run it, create a container out of it, and then do whatever he wants. So you can think of registries as like storage locations for Docker images. These images can be versioned in the registry as well. So if you have a Docker registry and you have different versions of an image for different versions of an app, if you have version 1 of a Docker image for application version 1, you store it. It goes ahead for deployment, and Docker image 2, then Docker image 3, and they can be basically taken by other users. So you can version them as well, and as well, use as a storage location. So you have many options for Docker registry. You can go with Docker Hub as your main registry, as there is already a Docker command to pull and push images to it. So a lot of people do make use of Docker Hub because Docker Hub has a very, very, very large, libraries of images that you can make use of. Like how I pulled the Nginx image, that was pulled from Docker Hub. I use the Docker pull command. So, there is a dedicated command for this. But if you don't want to use Docker Hub because, you don't want to pay Docker because you already have your own servers, you can go ahead and use your own servers. Or if you use some other service like AWS's ECR, that is Elastic Container Registry, or JFrog Artifactory, or if you use Azure Container Registry, so you can go ahead and use these also as your Docker registry. But a lot of people make use of Docker Hub. Now, the Docker Hub has two parts to it, where one part of Docker Hub is entirely free, but it's public, so you can't make your images private. So if you're a company and you don't want to share your customized images to everyone, then you can go ahead and subscribe to Docker Hub's premium subscription, where they allow you to make some of your images private, and it has a lot more other features also. All right, so that was about Docker registry. So let's go ahead and create our own Docker Hub account, and then let's try and pull and push an image from it. Okay. All right, so this is Docker Hub, where you store your images. Now, we've already talked about what images are. They're basically blueprints for our containers. So when we talk about sharing containers, we actually mean sharing images. To do that, we need a dedicated location for storing those images. And I've told you guys about Docker registry, right? So Docker Hub is one of those Docker registries. Now, what you can do is you can go ahead and create an account for Docker Hub. It's a simple process of creating your own account. I have my account over here, as you guys can see. And now I will take you guys through basically an intro of what there is, everything, over here. So first of all, you guys need to go ahead and look at the search bar, because this is where you're going to do most of your work, this and, your account. So if you want to look for an image, so let's say you want to look for MySQL image, you search in MySQL and you will see the most popular result is the official MySQL image. Now you can select it and you can see all of the different, descriptions, reviews, or what are the different tags you can use for this particular image. And a lot of different things, basically all the details you would need to run or connect, or everything you need to know how to deal with MySQL. Now, the common command over here is docker pull MySQL, so that you can go ahead and pull the MySQL image onto your system. Similarly, if we typed in over here Ubuntu, if we wanted to create an Ubuntu container, then we would go ahead and get the Ubuntu image. All right. So let's go ahead and try this out. What I'm going to do is right now, this is my instance. I've changed the color over here. If I do a docker -- version and I press enter, I see that we have Docker on this. Now what we will do is we will do docker pull and the name of the image we want to pull from Docker Hub. We want to pull Ubuntu. Now, if you don't have root access, you can go ahead and put sudo over here like this and press enter. And you will see that my Docker client is now pulling the Ubuntu image, and it's completed pulling the Ubuntu image. It's the same command that we saw over here when we clicked on Ubuntu. So if you wanted to do the same for MySQL, we just have to type in sudo docker pull MySQL, and we'll pull the image for MySQL. All right, so now let's do Docker images. So if I do Docker images, you will see it will list all the images I have on my local system, that is MySQL and Ubuntu. And you can see with the sizes that, they're pretty small compared to their actual software. Like with Ubuntu, it's only 73.9 MB, which is very, very less compared to its actual image that is around 1 GB or even more than that, depending on what version you're using, right? So there you have it. We have the images pulled onto our system. Now let's try to do one thing. So you must have created an account over here. Now what we will try to do is we'll basically try to push an image onto our account that we have created. So for that, I want to basically first run a container out of the Ubuntu image that we have over here. And I want to make some changes in it. I want to save it, and then I want to push it back onto my repository. So first what we will do is we will run the container for this image. So I will type in docker run -it-d, and I will give in the name of my container. This can be my container, and I will put in the name of the image that I'm referencing to create this image container. And I will go ahead and press enter. So you guys can see that this is the syntax, that is docker run -it-d, and this is --name. So these flags, the -it flag basically makes the container interactive. That means you can, basically interact with it. Then -d basically makes it detached. So, it runs in the background. You don't see any of its processes working over here, and you can make use of the terminal. And then this flag is basically used to give the container a name. We're giving it the name my container, and then we are referencing the image. So we have a container running over here. So if you want to see if our container is running at all, what we can do is we can type in the command docker ps. So ps stands for process status, and it will list down all your running containers. And we have one container running over here called my container with the container ID, the image being used. It was created 11 minutes ago, and it's been up similar time. Okay. Now we will go inside a container. To go inside of your container, you need to make use of a command called docker exec command. And then you need to use the -it flag again to make it interactive. And now you need to give it the container name, which can be my container, or you can go ahead and give it the container ID. It works with both. And then type in bash. So it's basically allowing you to enter the container using the bash terminal by making it interactive. If I press enter, you guys can see that it's changed from my instance's IP to the container ID. All right, so this means we are inside the container. So if I do an ls, you guys can see that we have all the things that are inside Ubuntu, all the basic necessities for running Ubuntu. If you guys want to see a demonstration, if I do an apt update inside of this container and press enter, it will start updating the container. All right. So guys, now let's go ahead and try and simulate, let's say, running Nginx server inside of this container. So I will go ahead and install Nginx, apt install Nginx, and then press enter. Okay, so we can use the service Nginx status command to see if our Nginx is running. It's not running. Let's go ahead and make it start running. Okay, so our Nginx is running, but it's not, the container is not exposed, so we will not be able to see that. Right, so what we can do now is we can exit this container, and now we've made a change in this container, right? So now we can go ahead and commit this container. That is basically saving all the changes we have made inside of this container. So if I do a docker ps again, I will go ahead and use the command docker commit, and I will use the container ID, and I will give this the name demo image Nginx, and then press enter. So if we go ahead and do docker images, we can see that we have a third new image, that is demo image Nginx. So this image is basically created using the Ubuntu image. We just installed Nginx inside of it. That's why the size has changed. And it's its own image now. So that's the command we use, docker commit. We use the ID of the container, the running container, and the new name we wanted to give it. Now what we will do is we will log in into a Docker account through the Docker daemon. So I will type in the command docker -login. Docker login. So I'm going to give it my username, that is dolphin45, and now I'm going to give it my password, and then I'll press enter. And it tells me that, we have successfully logged in into a Docker account through our Docker client or our Docker daemon. Okay, so we have done logging in. Now what we can do is we can go ahead and push our image onto our Docker hub. So if I go to my profile, I can see that there are no repositories as of now. So when we push, it will automatically create one. So let's go ahead and do that. But I want to tell you guys one thing. Whenever you're pushing images onto your Docker Hub account, you need to give a specific nomenclature for your images. You can't just simply upload your images with the name that they already have. You need to give them a new name if you want to upload them to Docker Hub. That is, to do that, you need to use the docker tag command. So go ahead and type docker tag, type in the name of your already existing image, and give it the new name now. So with the new name, what we will do is we will give it dolphin45. That's my username / and whatever name we want to give it. So let's say I want to give it d image nginx, and then I'll press enter. And if I do a docker images now, I can see that there's a dolphin45 / d image nginx. Now we did this where we had the format of username / the actual name of the image, because that's how you need to name your images before you upload them. So let's say if your username was johndoe45, you will write johndoe45 / whatever name you want. If you wanted to name it something absurd like cat or dog, you could do that. It's your wish. You just have to follow the formatting. That is username / image name. Now we will go ahead and push it using the docker push command. So docker push, and I will paste the name of my image and I will press enter. So as you can see, this will start pushing to docker.io / docker dolphin45 / d-image nginx. Okay, so it's pushed it. So if we come back over here and if I refresh, we can see the image I just uploaded. So that is dolphin45 / d-image nginx. Now we can go ahead and pull this also, this image that we have uploaded over here. So to show you guys, first what I will do is I will go ahead and remove these two images. So for removing an image, you have to use the command docker rmi. So it is basically remove image, and then we're going to take the name of our image and then we're going to press enter. So it will untag it and then delete it. We will do the same with our other image, that is the demo image nginx. We will remove it. So now we basically have no trace of our original image on our system. But no need to fret, because we have it over here, dolphin45 / d-image nginx. So we can just copy this command. If you click on the image, that is docker pull, and we can go ahead and paste this and then press enter. So if we do docker images now, we can see our image over here. We can go ahead and run this, docker run -it -d -p -name, sorry. And then we'll use the name of the image and then press enter. So if I do a docker ps now to check what all containers are running, I misspelled docker. I can see that a new container is running, that is dolphin45 / d-image nginx. Alright, so that's how you create an image. Now I want to show you guys one more thing about creating images, containers. Sorry, this is me creating a container. So while you're creating container, let's see what happens when you don't include the -- name. So if I do -it -d and I don't write in the name, but I do include another flag called -p and write in 8080. So what this basically does is it basically creates a container that is exposed on the port 80. And so we'll see two things. What happens when we include the publishing port? So this flag is used for including the publishing port. And what happens when we don't include the name? So if I press enter, I forgot to add run. Let me go ahead and add run. And if I do a docker ps again, you guys can see we have a third container up and running. So this is the container ID, the image used, but the name is different. The name being used is Compassionate Swanson. And why is this different? Well, apparently if you don't give it Docker any name, then it comes up with its own randomly generated name. So if you don't want that, go ahead and include the hyphen name flag. And you can see that the port at which it's available is 0.0.0.:80. So this basically means that it's available at the default port, because port 80 is the default port. And this is the IP address of your local system. Basically, if it's your local system, it will give 0.0.0. So you can just type in localhost or whatever your IP is, and you can access the container. Since we don't have anything special running on this, we will not be able to see it. Now, if I were to change this, instead of Ubuntu, I were to write Nginx. So it will pull the Nginx image if it can't find it locally. So you don't necessarily have to, use the Docker pull command. You can directly do it. And it says that it failed because something is already allocated at port 80. So if we do Docker PS, we have this container running. So to stop this container, we can go ahead and type in Docker stop and give it the name of the container. So I'll put in the name, and this will stop my container. So if I do Docker PS again, I don't see the container. But if we do Docker PS-A, we can see all our containers, even the one that we just stopped, that is Compassionate Swanson. And we see a fourth container. So this container basically is a failed container. It didn't run properly because there was no location for it to get started, because we already had Compassionate Swanson taking its place. So let's go ahead and remove these two, because we stopped them, but we have stopped one, but we haven't removed them. So to remove it, we need to use the command docker rm. And to forcefully remove it, you use docker rm-f. Just go ahead and put in their names. Okay, now if we do docker ps-a, we will see only the two running containers. Now, docker ps only helps you get the running containers. The -a command helps you get even the exited containers. Okay. All right, so now let's try that command again, docker run. And if we press enter, okay. Now if I do docker ps, I see one container running. Now let's go ahead and access it. I will take the IP address of my system and go to the direct IP address of it. And you guys can see that it gives us the message, welcome to Nginx. So whenever you're launching Nginx without any special configuration, by default, you will get this page. And since we configured it to run on port 80, so it will be running on port 80. That is the default port. So you need to add it. You can go ahead and add it, but you'll get the same answer. All right, so that's how you create your container, and you can expose it at a certain port. Now we learned other commands also, like docker stop and docker rm. Now there's another command called docker kill. So docker kill is exactly like docker stop, but it does things forcefully. It won't elegantly wait for processes to stop. It will kill the container. So if we wanted to kill laughing patrol me, we will just type in the name and it will kill it. Now it hasn't removed it, it just stopped it. So if we do a docker ps-a, we can still see the container. It's just that it's exited 6 seconds ago. And we can go ahead and remove it again by using docker rm-f and the name of the container. All right, now let's move on to the next topic, that is Docker Compose. So when we talk about Docker Compose, we won't be going into detail right now. We'll be talking about it more in detail later. But for now, just understand that Docker Compose is just a service within Docker that lets us launch multiple containers at the same time. Now, we know how to launch containers. We basically reference the images and use the docker run command for it. But the thing is that we can only launch one container at a time using that command, because it's made for that purpose. So what happens when you want to launch multiple containers at the same time? To do so, you make use of something called Docker Compose. Now, Docker Compose is a tool that Docker provides that helps us to launch multiple containers at the same time. Now you might be asking yourself, what's the use of this? Why do we need to launch multiple containers? So as we've talked before, the one of the greater uses of having containers is that you can deploy your software application in a microsystems type of architecture. That means that you might divide your software into multiple chunks and you will deploy it as such. So to keep those multiple chunks in certain containers, you need to create those containers. And it's much easier to create those containers once you have a configuration file that lists down all the things that are needed for the containers. So you can imagine Docker Compose files being like Docker files. They contain all the information that is required for the containers to be launched. You can mention a lot of different things, and we will discuss all of them when we are talking about Docker Compose properly. So now let's go ahead and talk about Docker Swarm. So Docker Swarm is kind of related to Docker Compose in that, it allows us to manage multiple containers. So even with Docker Swarm, we'll be talking about it more in detail later onwards. So for now, just understand that Docker Swarm is a service within Docker that allows us to manage multiple containers at the same time. So let's say that you have two servers, and on those two servers, you have Docker installed. Now you have multiple containers. Let's say you have 3 containers running on server 1 and you have 3 containers running on server 2. So these containers have been launched with the help of different Docker clients, because you're not using the same client because they're not the same server. So what happens when you want to connect all of these 6 containers together that are on separate servers? To do so, you can make use of something called Docker Overlay Network that allows you to connect them, and you can put them on a Docker Swarm. So Docker Swarm will help us to manage all of them. So let's say you have one swarm in which there are 6 containers, then one of them will be a manager node and rest of them will be worker nodes. So manager node is basically the one that manages all the worker nodes, as the name suggests, and the worker nodes are the ones that do all the work. They perform any tasks that have been assigned to them through the manager node. So that's Docker Swarm. It basically helps us to handle and maintain and manage all the multiple containers that we create. Alright, so now let's discuss the Docker architecture. We've gone through the Docker common commands, so we have a better understanding of how to use Docker. But let's go through the architecture to understand Docker a little bit better. Alright, so now let's look at the Docker architecture. So first, we have the Docker CLI, that is the Docker command line interface. Then we have the Docker host, and then we have the Docker registry. So these are the 3 main things that form the flow in the Docker architecture. So with the Docker CLI, you'll be giving in all the commands like Docker build, Docker pull, and Docker run. These are your normal Docker CLI commands, and these commands will be read by your Docker daemon in your host. And once it reads it, it will process it accordingly. So let's see what happens when each of these commands are processed. Starting with Docker build. So when you type in Docker build, you want to basically create an image. To create an image, you have to first create a Docker file. So Docker file is basically a text file in which you write down all the configurations that you will want in your container. So first you have to build your Docker file. So once you write down all the instructions in your Docker file, you will build it using the Docker build command. So when you type in the Docker build command, the command is basically communicated to the Docker daemon with the help of the Docker API. Now once the daemon receives this command, it will process it. So it will see that it has to create an Ubuntu image, let's say. So it will take in the information of what kind of version of Ubuntu image it will be creating, and it will create it accordingly. So that's your first command finished. Now let's talk about Docker pull command. So we've seen what Docker pull command does. It basically pulls images. So when you type in Docker pull, it basically requests the daemon to pull a certain image. So let's say you're looking for the Apache web server image. So Docker daemon will take in that request and will start looking for that image on the Docker registry. So this Docker registry can be configured, and when you don't configure any special registry, it will by default check out Docker Hub. So the Docker daemon will go through Docker Hub, and once it finds the image that it's looking for, it will replicate it onto the local system or server. So that's your second request completed. That is Docker pull of a image. Now comes docker run docker run command. So the docker run command basically tells the daemon that you want to create a container. So you will specify the image that you will be using, and the docker daemon will process that request. And let's say if it's the container of Ubuntu, it will take in the Ubuntu image and it will create a container using it as a reference. So these are all the different processes that happen when you're talking about Docker. So let's say for Docker build, you have, an image being built. Docker pull, you're pulling an image onto your local system, and Docker run, you are creating a container out of an already existing image. So guys, this is the Docker architecture. Dockerfile. So guys, now we will go ahead and talk about Dockerfile. So basically we'll be talking about how to build a Docker image in this. So Docker files are basically scripts that you can write and then build into an image. The image can then be run to create the container. It is like a shell script where you write down a set of commands and you run the shell script so that the commands are run. So similarly, in a Docker file, it's going to be a text file where you're going to write down all the instructions that will help you to create a container. Now, these instructions will basically list down every specification that will help you create that container. But a Docker file will not be directly used to create a container. A Docker file will be built by a user into a Docker image. After it's been built into an image, it can then go ahead and be created as a container. So this is the process where the user first writes down all the instructions that are required to run a container inside of a Docker file, and then he builds that Docker file into an image. And this image will contain all of these details. And once the user requests for the creation of a container, the daemon will basically reference the specific Docker image and it will create the Docker container. Now, to write a Docker file, there are a few formats and instructions that you have to follow. So this is basically the set of instructions that you will be using. Commands such as instructions such as from, add, copy, run, workdir, cmd, volume, expose, entry point, and label. All of these are instructions that help you to create your image. For example, we have the first instruction, that is from. Now, from instruction basically tells Docker what kind of base image has to be used with the container. So let's say you want to create a very custom image where through which you want to launch a container that is basically an Ubuntu container, but it has an Nginx application running within it. So it's your own custom image, but you're using the base image of Ubuntu. So you will be referencing Ubuntu as from Ubuntu. So from is, again guys, an instruction that informs Docker about the base image that is to be used as a reference for the container. So basically, if you have any image in mind whose properties you wish to inherit, you can mention it using this instruction. This is always used as the first instruction for any Docker image, but you can use it multiple times within the file. So whenever you create a Docker image using Docker file, the first instruction that you must mention is from, because you have to reference some kind of image. It can be your own personal image or it can be any other already available image. But if you want to create an image from scratch, you don't necessarily have to mention a base image. What you can do is you can mention scratch. So whenever you write from scratch, you are telling Docker that you want to create a new Docker image from scratch. So it won't inherit any proper properties from any other base image. You'll be basically be creating that image from scratch. And you can use this instruction anywhere in the Docker file, but you must use it whenever you're creating a Docker file in the start. Alright, so that's one of the first instructions. Now let's move on to learn all the other instructions. Like you have the add instruction. Now the syntax for add instruction is add, source, and then destination. So this instruction is used to add new sources from your local directory or a URL to the file system of the image that will become the container in the designated location. So what all these basically confusing words mean are that, basically you're going to be adding specific files and folders from the source directory. This source directory can be in your own system, or it can be a URL that you are referring, and the files from there will be taken and put into the designated location that you mention as the destination. So that's how the syntax works. You write an add, you write in the files in the source, and you write the destination where you want the files to be. Then, basically, you can include multiple items also in the source. If you want more than one file to be included, then you can do that, and can even make use of wildcards. When I say wildcards, what I mean is, using the star that is in your 8 key. Like when you use shift 8, you get the wildcard, and that wildcard basically allows you to select multiple files. Let's say you have multiple files called dog. You have dog1, dog2, dog3, dog4, and you want to select all of them. So instead of writing all of them together, what you can do is you can just write dog and then star. So this will tell your Docker that you want to select all files that start with dog, and it will select those files for you. And if the destination that you have mentioned does not actually exist within the container or within the operating system that you're using inside the container, then it will go ahead and create that destination and put the files in that destination. So this is how your add instruction works. Where you write add, then the source of your file can be any source, can from a local directory or URL, and you can mention multiple files using human wildcard, and then you mention the destination. And if the destination is not a one that already exists, it will create that destination. So that is your add instruction. Now let's move on to the other instruction, that is copy instruction. Now you might see some similarities with the add instructions, but it's a little different. Let's see why. So this instruction is used to copy new sources from only your local directory to the file system of the image that will become the container in the designated location. So this instruction's syntax is basically copy from source and then destination. So again, like add, you can refer your local directory files and put them in your destination in your file system, in your container. Now again, you can use multiple items as the source and can even make use of wildcard. So again, if you have dog1, dog2, dog3, you want to include all of them, you just write dog star. And if the destination that you have mentioned does not exist, then it will create one. So it's very similar to add. The difference is that add can also add new URL files to the file system, whereas copy can't do that. So if you want to copy only files from your local directory, then you can go ahead and make use of copy instead of add. So that's your copy instruction. Now let's move on to the run instruction. Now this specific instruction is used to run specific commands that you want to run in the container during the container's creation. So this instruction syntax is run and the command. So if you want to say, for example, run an update command on your container, then this command will run during the container's creation. So if you have Ubuntu as the container and you want to update it, then you can use the instruction as such, that is run apt get update. So this will update your instance or your container while it is being created. Now we come to work dir instruction. Now the work dir instruction is responsible for setting the working directory so that you can run shell commands in that specific directory during the build time of the image. So basically it defines the workspace that has to be used whenever any processing happens within the container. So for that purpose, we make use of work dir. It's like assigning your own working directory, but within a container. So let's say you wanted to assign working directory to /app and you mentioned work dir /app, then whatever processing that happens, whatever thing you download will happen in your working directory. So that's your working directory instruction. Now let's move on to the CMD instruction. Now the CMD instruction's syntax is CMD command. Now this instruction tells the container what command to run when it gets started. So this specific instruction tells our container to run specific commands when the container starts. So these commands only get run when the container starts. So that's your CMD command instruction. Then comes volume instruction. So the volume instruction basically tells us what volume has to be used. The syntax is volume, then the path of the volume, and it makes a mount point for the volume of a specified name that you mention. So this is your volume instruction. So if you wanted to attach a volume to your container, then you would go ahead and make use of this instruction. Then you have expose instruction. Now the syntax is expose ports. This instruction tells what port the container should be exposed at. But this can only happen for an internal network. The host will not be able to access the container from this port. So when you want to expose a container within a internal network, then you can go ahead and make use of this particular instruction, that is expose at this particular port. So containers within this internal network can talk to each other using this port. Now this cannot be used as a publishing port where you make sure that the container is available from the host. This is different from that. All right. Now that's the expose instruction. Now let's move on to the next one. This is the entry point instruction. The syntax is entry point, command, parameter 1, and then parameter 2. This instruction allows you to run commands when your container starts with parameters. So if you want to give in any specific parameters, maybe password or some secrets or maybe some text, then you make use of these parameter or instruction where you're making use of entry point. So the difference between CMD and entry point is that with entry point, your command is not overwritten during runtime. When you use entry point, it will override any element specified in another CMD instruction. So if you're making use of CMD and entry point at the same time, the entry point instruction will override any elements that may have been specified in the CMD instruction. So this is basically used to run commands with different parameters that you may want to run. That's when you use entry instruction point. Now, the last instruction we'll be talking about is label instruction. So the label instruction is used to add metadata to your image. You need to make use of quotes and backslashes if you want to include spaces in the label. If there are any older labels, they will be replaced with the new label value that you have assigned. You can make use of docker inspect command to see its containers label. So if you wanted to see a containers label, then you can make use of docker container inspect command to do so. And when you want to create a label for a specific container, then you mention this in the Docker file. The syntax for label is label key equals value. So you will assign a key and you will give it a value. Alright, so these are all the different instructions, guys, from add, copy, run, work, dir, cmd, volume, expose, entry point, label. But these aren't all the instructions. There are more instructions that you can make use of, like env, that is for environment variable, and a lot more others. Depending on your requirements, you will use those certain instructions. Now, a key thing to remember here is that every time you write an instruction, it creates a layer on top of the container. Since a new layer is created each time a new instruction is written, it is very important to write it in the most optimized way as possible and least number of instructions as possible, because we want to reduce the layers that we put on a container. That way, we increase its efficiency and we reduce the amount of memory it consumes. So that is again important if you want to make sure that your containers are always healthy and running, to reduce the amount of resources it needs to use to make it as optimized as possible. So write your instructions in the Docker file in such a way that you don't mention any extra details in extra instructions. So this way you will avoid creating any extra new layers. Okay, so with all of that information, now what we will do is we will go ahead and create our own custom Docker image using Docker file. Alright guys, so I'll bring up my instance over here. Let's just make sure Docker is installed on this. Alright, we have Docker installed on this. Now what I'm going to do is I will try to basically run a Python file in my Docker container. For that, we will first create my Python file. So what I will do is I will go ahead and use the nano main.py, and we will write here a print statement. Let's go ahead and say I have the best audience. All right. And just for good measure, hello world. All right, so this is going to be our statement. Let me go ahead and save this. All right, so now I just want to go and install apt install python -y. So I just want to check out if this works in my normal system. All right, so now we'll do python main.py and we can see that it's working. All right, now we will go ahead and create our Docker file. So I will create Docker file. So it's just a text file. So we will just create a normal text file, that is nano Docker file over here. I will press enter and we will start writing our Docker file over here. So if you guys remember, the first instruction that we have to include is the from instruction. So let me go ahead and write the from instruction and I will write Ubuntu over here. All right, now I can mention the latest tag if I want or another version if I want, but I'm going to leave it as latest. I don't want to choose any other version of Ubuntu. Now we will go ahead and mention the working directory. So my working directory is going to be, so for that I'll use the command workdir and I'm going to mention /app. I want my working directory to be this app. And now we're going to go ahead and copy our file from our source. So for that we can use either the add command or we can even use the copy command. So let's go ahead and use the copy command and I will put in a dot over here. So it will copy everything from this area. So it will copy the Docker file and the main.py also. So let me go ahead and specify. We don't want the Docker file to be copied. So I just want the main file to be copied and I want it to be copied from our current directory. That's why I've mentioned ./main.py and I want it to be copied to the working directory, that is /app. Then I'll press enter and now we will use the run command because we want Python to be installed in our Ubuntu instance. So I will do apt update and apt install Python and -y because we won't be there to give it the response. So I'll press enter and now we have done mostly everything. We just have to put in the starting command, the command we will use to run our Python file. So I will go ahead and use the cmd command and I will use the square brackets. Then we will use the quotations. Inside this I want it to run Python command and I want it to run the Python command with the main.py file. All right, so this should go ahead and run my Python and /main.py file. All right, so this is our Docker file. These are all the configurations that are required to create our Docker image. So now we will go ahead and save this. Control O to save, Control X to exit. Now if I do an ls, we can see our Docker file over here. Let me go ahead and build our Docker file now. So I will type in docker build, then -t. Now I'm going to give it the name of my image. So the name of my image is going to be Ubuntu -python. All right, so this is the syntax and you just have to add dot. So this is the syntax where you first mention Docker, then build, then you give it the tag that is going to be Ubuntu Python, and then you mention the location of your Docker file. I did not need to mention it because it's in my current directory, so I've mentioned the dot over here. All right, now I'm going to press enter and we'll see the process start happening. First, it will pull Ubuntu image to form its base image. Then it will run all the other commands. Right now it's updating our instance and then installing Python. All right, so it performed all the steps. Okay, now we'll come back up over here and I'll show you guys each step one by one. So the first step is from Ubuntu. So that's our first layer. And then a second step is basically making the work directory /app. Then we copied our file from that is .main.py into our container or our image right now, and then we ran the command apt update and apt install Python. So it installed Python and updated the instance in the reverse order, and once it completed all that, it went ahead and executed this command. Well, it stored this command and it will basically run this command when we run the container. So let me go ahead and first do a docker images to show you guys what all happened. So first we have two images here, Ubuntu and Ubuntu Python. We have Ubuntu here because to reference the Ubuntu image, it had to first download the Ubuntu image, then it referenced the Ubuntu image, and then it created our image. So now let's go ahead and run this. So docker run -it -d and the name of our image. Let's also mention the name of the container -name, and our name is going to be my container, and let's press enter. So if we do a docker ps, we will see one thing, that the container is not over here. That's because the container automatically exited. And if we do a docker ps -a, we can see the container here. But the thing is that it completed its task, that is to print the statement. So if I do docker logs and I put in the name of my container, so this will show you the logs of your container, we can see that our statement over here was executed. That is, I have the best audience, hello world. So that's what we wanted. So guys, this is how you would go ahead and create your image. First, you need to make sure that you have your project with you if you want to copy your project into the Docker image. And then you need to have your Docker file. So Docker file will, again, if I show you guys, basically contain all the instructions that will help you create your container. The Ubuntu image, the working directory, the file you may want to copy, and running the command. And as you guys can see, I ran both the commands in a single line. I used the and feature over here to include both the lines in one instruction instead of making it two instructions. That's me optimizing over here. And then me writing cmd python /main.py. So this will basically run python main.py, and this will only happen during the creation of the container. So this is a Docker file which we build using the docker build -t, the name of the image, and then the location of the Docker file command. And we created our Docker image, that is Ubuntu Python. And then we ran that as a container, and we saw that in the logs that it had printed our statement. I have the best audience, hello world. So this is how you would work with a Docker file in basic. Docker storage. So guys, now we'll be talking about storage within Docker. So when we normally talk about storage, we talk about how data needs to be stored in a dedicated location for a specific purpose. So similarly, we'll be talking about how data is stored within Docker and what are the different types of methods we use to store data within Docker and how efficiently can we store data. Now, let's go ahead and answer some of these questions. So first, I'll be talking about advantages to the Docker storage types. Now, normally, if you talk about storing data in Docker containers, you're talking about storing data within the container's writable layer. So anytime you store data within a container, you're storing it in its writable layer, not in a dedicated location or anything. You're storing the data in its writable layer itself. Now, this is not an efficient way to store data. It eats up a lot of memory of the container, and it makes the container way less efficient. So that's why we try to make use of different Docker storage types. These storage types have a lot of advantages over the default storage method. So these are the advantages where you have persistent data, transfer data easily, and increase container performance. What are these? So again, with storing data within a container itself, you have two disadvantages. That is, storing the data in a writable layer as well as having the data stored only temporarily. So whenever you stop a container, you basically remove any data that has been stored in it. So it's temporary storage. So when you use different Docker storage types, that time you're basically storing the data permanently. So if you guys remember, when we were talking about volumes, we were talking about a Docker storage type, and it basically allows us to store data permanently, or it helps us to persist the data that we want to persist. So that's the first advantage. Now the second advantage is that allows us to transfer data very easily. So if you're making use of a Docker storage type, you can basically transfer data from one place to another without having any major issues, because the Docker storage types are easily detachable and attachable to different containers or even different locations. So that's why a lot of people make use of Docker storage types. Now comes the last advantage, that it helps us to increase container performance. So again, when we talk about storage in containers, by default, it gets stored in the writable layer. So that decreases the efficiency of the container to work, to do its job. So what we do is we assign the job of storing the data to someone else. So this can be one of your Docker storage types, and they will help you to store the data permanently. And this will reduce the performance issues on the container and hence increase it overall. So these are the three advantages for using Docker storage types: persistent data, transfer data easily, and increase container performance. All right, now we will go ahead and discuss the different types of data. So different data types. Now we have a lot of different data types like volumes, bind mount, and TMPFS mount. So we've already talked about volumes, and we will talk about volumes even more in detail now, and what bind mount is and what TMPFS mount is. So let's start off by talking about how these different storage types get memory from the host system, or how do they store data in the first place in the host system. In the diagram, you guys can see there's a container, there's a file system, and there's the memory for the host system. So the first data storage type is volumes. Now, whenever you create a volume, right, it basically takes up space in the file system of the host operating system. So any operating system will have a file system where it stores files and data. So whenever you create a container and you create a volume, that volume basically occupies a space within the file system. So this area that is called Docker area is basically being managed by Docker itself. The file system has no longer any control of this particular area, and Docker controls and manages it entirely. So when you create volumes, you're basically taking area within this Docker area, and hence the volumes are completely managed by the Docker itself. The file system and the host have no manageability on the volumes, even though volumes still take up space within the file system. Then we have another type, that is bind mount. Now bind mounts are basically very similar to volumes, where they basically map their storage locations in the file system itself, but they're not completely managed by Docker. They can be managed by the file system of the host system itself. So that's the difference between volumes and bind mounts. Whereas in volumes, you can, they're completely managed by Docker. Bind mounts are not. And then you have TMPFS mounts. So TMPFS mounts basically map their storage within the memory directly itself. Now they do this because they also help you store data temporarily. So if you want to store a lot more temporary data, then you would make use of TMPFS mount. And they are unlike volume and bind mount in the matter of fact that they cannot persist data. That means they will basically store the data in the memory temporarily, and when the container dies, the TMPFS mount will be removed. Alright, so these are the different Docker storage types: bind mount, volumes, and TMPFS mount, and this is how they store data. Now let's move on and let's go into a little bit more detail for each of these. So first we start off with Docker volume. So Docker volumes are basically persistent storage locations for containers. They are managed by Docker completely. They can be easily attached and removed from containers. You can back up your volumes also, and this is one of the most used type of data storage. Alright, so volumes are your standard data storage types. They're basically completely managed by Docker itself, and no one else can manage them. And one of the more advantageous things about using volumes is that they can be easily attached and removed to containers. So if you have one volume, you can attach it to one container and store in all of the data. And once you're completed, you can go ahead and attach it to another container and help transfer the data. So they provide that as a big advantage. And you can back up your volumes. So if you ever wanted to store your data and you wanted to back it up for future reasons, so that if something happens to the container, then you have the data in hand, or something happens to the volume, you always have the data in hand, then you can go ahead and back up the volume. And again, this is one of the most popular Docker storage types, because it provides one of the most powerful advantages. That is, it's completely managed by Docker. It's easily attachable and removable, and you can back it up. All right, so now let's go ahead and work with Docker volumes on our instance. All right, guys, so here we're going to go ahead and create a Docker volume first. To do that, we will use the Docker volume command. So Docker volume create, and we're going to mention the name of the volume. So let's say my volume's name is going to be Batman. So if I press enter, it will create a new volume named Batman for me. So again, the syntax is Docker volume create and the name of the volume. Now, if you wanted to see your volume, if it's present in your local system or not, you can go ahead and type in Docker volume ls. And if you press enter, you will see that there is a volume named Batman that has been created. All right. So that's one of the first steps of working with volumes, that is to create a volume. Now, what we will do next is we're basically going to remove this volume. So I'm going to type in Docker volume rm and the name of the volume, that is Batman. So if I press enter, you will see that Batman has been removed. And if I do a Docker volume ls again, which will list all the volumes I have, you will. So it's volume, not volumes. So you can see now that there is no volume at all, right? Before you could see that Batman was there in the volume name and its driver was local, but it's not there anymore because we removed it using the Docker volume rm command. All right. Now, if I want to remove a lot of volumes together, what I can do is I can use the Docker volume prune command. Now, to show you guys how this works out, let me go ahead and create a bunch of volumes. So I will create Batman again. I will create Superman as another volume, and I will create Wonder Woman as another volume. So if we do a Docker volume ls, you guys will see that we have 3 volumes. Now I can remove all of these 3 volumes at the same time by making use of the Docker volume prune command, that is Docker volume prune. And if I press enter now, you will see that there is a message warning me. Warning, this will remove all local volumes not used by at least one container. Are you sure you want to continue? Yes or no? We're going to say yes. And it will tell you that it deleted all the volumes. Now it said that total reclaimed space is 0 bytes because we didn't use these volumes at all. Now, so if you do a Docker volume ls again, you guys can see that there are no volumes. Alright, so now what we will do is we will try to attach one of our volumes onto a container. So first I will go ahead and create one of my volumes, that is Docker volume create using the Docker volume create command. I will create Batman again. I have created Batman. Now I will go ahead and run a container. So Docker run -it-d, and now I'm going to use the mount flag. To use the mount flag, just type in double hyphen and then mount, and then mention the source or the name. So I'm going to mention Batman over here, and I'm going to put a comma, and I'm going to give it the target. So from where the data is going to be stored. So target is going to be inside the container, and we could give it anything. So let's say I want to give it app. All right, so I've given the target as app, and now I can mention the name of the image. Now I'm going to go ahead and use Ubuntu as my image, and I'm going to press enter. So it's downloading Ubuntu, and it will create the image. It will create the container for us. And if we do a Docker ps, we can see that we have a new container running. Now to see if you have the volume attached to this or not, what you can do is you can go ahead and use the Docker container inspect command and type in the name or the ID of the container. So I'm going to put in the ID of the container, and we're going to inspect this container. So when I press enter, you see there are a lot of details over here. And the one that we want to look at is actually, if you scroll up from bottom, if you keep scrolling up, you will see something called mounts. So this is what we are interested in. In mounts, you can see the type is volume, the name is Batman, the source is this, that is /var/lib/docker/volumes/batman/ underscore data. So this is where all your data is going to be stored now. This is the destination folder, and this is the driver, is local driver, and the mode, the RW, and the propagation. All right, so you can see all the mount details over here. So that's how you can check. Now there is another way to check, that is to inspect your volume itself. So if we list the volumes, we have only one volume. Let's go ahead and inspect the volume. So docker volume inspect, and I'm going to give it the name of the volume I'm inspecting, paste it, and you will see all the information relating to the volume, where it will give you the particular date and time at which it was created, the driver, the labels it is using, the mount point for it, its name, the options that are there, and the scope of it. All right. So this is what happens when you do docker volume inspect, the name of your volume. In our case, it was Batman. All right, now let's move on. Now I want to show you guys what happens when we create a container and we mention the name of our volume without actually creating it. So if I put in over here source equals to Superman, and I mention the target equal to /app, and then I mention the name of our image, that is going to be Ubuntu. Let's see what happens. Right, so we need to put in sudo also. So if we do a docker ps now, sudo docker ps, we can see that our container has been created, and this container basically maps to the volume that we created. So if we do docker container inspect in this, and I put in the name of the container, let's give it space over here, and let's get root access so that we don't keep on getting this message again, and I don't keep on making the same mistake again. And we enter, type in enter, we see a lot of details. We want to check out the mounts. You can see in the mounts path, we have type volume and the name Superman. Even though we did not create Superman as a volume over here, it still has been created. So this is what happens when you directly mention the name of your volume without actually creating it. Docker actually just creates it for you. So Docker is stubborn like that. It actually waits for you to create your if it waits for you to create your volume, and if you don't create it, then Docker does it itself. So if we do a docker volume ls, it's a volume ls, you can see our Superman has been created as a volume. Now let's try to attach a volume in another way. So what we're going to do is we're going to type in docker run -int-d, and this time we're going to use the volume flag. So you have the mount flag and you have the volume flag. So over here we can mention the name of a volume. So I'm going to mention over here flash and then colon, and we're going to give it the destination part, that's going to be /app, and the name of the image. So if we do a docker ps again, you guys can see there's a third container that is created called recursing Maxwell, right? And if we do a docker volume ls, we can see a flash volume has been created. So this again basically allows you to attach a volume to your container. So there are two different methods: --mount source equal to your volume name, then comma target equal to your target name. And if you want to write it in a smaller fashion, in a smaller format, you can use the volume flag, where --volume, the name of your volume, colon, and the target destination. All right, so these are the two ways in which you can create your volume. Now, volumes are generally, readable and writable. But what happens when you want to create a read-only volume? So what you can do is you can type in docker run -it-d --volume, give it the name. We are going to give it a new name. Let's say it's Wonder Woman, Wonder Man. So Wonder Woman, and we're going to give it /app, and we're going to write. And then you need to mention colon again and type in RO. So this makes the volume read only. And then you can go ahead and put in the name of your image. This will be Ubuntu. Now you can do this again, the same thing with mount flag also. You just need to remove volume over here, type in mount, and you need to mention source over here, source equal to. Then we need to mention our target, and then we need to mention read only over here. All right, so if I press enter again, and if I do a docker ps, you guys will see there is a fifth container called hardcore Maxwell, which has the volume Wonder Woman with read only defined. All right, so this is how you do it, guys, with volumes. All right, now let's move on to the next topic, that is bind mount. All right, so now we'll study about the other Docker storage type that is called bind mount. So bind mounts are basically very similar to, volumes. The difference is that, they aren't managed by Docker and they're mapped to the host system directory. So basically when you define a bind mount, you're basically defining the location in your host system that will act as the storage location for your container. All right, to understand this better, I'm going to open up my console over here, my system. Now I'm going to clear everything out, and we're going to create basically our bind mount. To do that, we are first going to go ahead and create a directory. I'm going to call this directory data directory. And if I do an ls, we have the data directory. And if you go inside data, and if I do a pwd, it will list the directory location. So this is my directory location. Let me come out of here. All right, so now what we will do is we will go ahead and create our container. So for that, I'm going to type in docker run -it -d. Then I'm going to mention the mount flag. So mount flag is used both with volume as well as bind mount. I'm going to mention the type as bind, then comma, source. In source, I'm going to go ahead and mention this directory. And now I'll mention the target equals to /app. There's no need to, configure the target to be anything else. And now I'm going to mention the name of the image. So we're going to use Ubuntu again. And if I do a docker ps, we can see that upbeat Hodgkin is our container name. Next time we're going to use the name flag because these names are getting more ridiculous and ridiculous. So let me go ahead and remove all these containers and we'll run this again. All right, so let me run the previous command again. We'll use the name flag over here. All right, so if I do a docker ps now, we have our Avengers container. Let's go ahead and inspect this container. Docker container inspect Avengers. All right, so if I scroll up, we can see in mounts that we have bind, and the source is this directory. The one that we created, the destination is /app. So this is your bind mount. Now, whatever data you store will basically be stored in this directory. That is your data. And you can directly go ahead and access that data also if you wanted to. Let's go ahead and create another data folder. I'm going to call this mkdir ro data. All right, so we'll run another container with this. To docker run -it -d -name my container, and we're going to use the volume flag again. And we are going to mention the type is bind, and we're going to mention the source is /home Ubuntu and ro data. And I will mention the target is to be /app, And we're going to mention one more thing, that is read only. And we're going to mention the name of the image that we are using. So this will basically go ahead and create my bind mount with this directory as the source, and will make it read only for this specific container. So if I do a docker ps, you can see that this container that I've created cannot store data, because that particular volume that we created is a read only data storage type, not a volume. All right, so this is bind mount. Now let's move on to the next type of Docker storage type. So TMPFS mount. So this is the third type of storage. So this type of storage maps to the host system's memory. And TMPFS mount is only used with Linux systems. You cannot use it with Windows systems. You make use of another data storage type with Windows called the npipe system. Now TMPFS is not persistent like volumes or bind mount, and gets removed when the container they are attached to are stopped. They only ever get mapped to a single container in their lifetime. It allows you to store more temporary data without affecting the container's efficiency. So if you wanted to store more temporary data in your container without using the writable layer, then you can make use of TMPFS mount. So TMPFS mount will basically allow you to store all the temporary data coming in from any application or software that you might be running, and it will store it in the host memory. And once your container has been stopped or it has been removed, the TMPFS mount will also be removed with it. So if you have TMPFS mount, you can connect it to you have a container, you can connect it to a TMPFS mount. And once you delete the container, the TMPFS mount will also cease to exist. So let's go ahead and, learn how to create our TMPFS mount. So we'll come back over here, and let me go ahead and create a Docker container, docker run -it-d name TMPFS container, and we're gonna give this the mount flag, mount type equals to TMPFS, destination or target, and you mention /app over here, and you can type in the name of the image. All right, so that's it. You don't need to mention any targets because it will automatically assign its own destination. And if we press enter, we can see that our container has been created. If I do a docker ps, we have the TMPFS container. Let's go ahead and inspect that container. Right, so if I scroll up, you can see in mounts we have the type TMPFS and the destination is /app. So that is your TMPFS container. All right, so we'll now talk about storage drivers. So storage drivers are basically used in a situation where you have to write in a Docker's writable layer. So when you have to write in a Docker's writable layer, you can make use of specific storage drivers to help you do it in a much better way. These will allow you to maintain control over how Docker images and containers are managed and stored. So here are a few storage drivers like overlay2, AUFS, device mapper, BTRFS, and VFS. So these specific storage drivers work for specific Docker versions, like overlay2 works for a certain version only, and AUFS also. And they are used to basically help you store images and container and manage them. So for this tutorial, you guys just need to know their names, nothing extra. Docker networks. So guys, we are now going to talk about networking within Docker. So when we talk about networking, normally we try to say, or we try to mean, connections between different software, connections between different systems, and exchange of information through a network traffic. So similarly, we'll be talking about Docker. So Docker networks, right? They're basically a connection between one or more containers. And one of the more powerful things about Docker containers is that they can be easily connected to one another or even other software. This makes it very easy to isolate them, and it makes it very easy to manage them. So you can connect any container to each other, and any bunch of containers to each other. And this is especially useful when these containers may have interdependency. That means, they might need each other to function, to their logical functioning, to keep up with the logical functionings. Let's say that one container has a feature that needs to be, that needs to function, but can only function with the help of the other container. So if you have one payment feature and one cart feature in a shopping website, then these two features have to be connected to each other, because the payment feature cannot go forward without knowing what's there in your cart. So that's an example. Now we have more containers and they are also connected to each other. And all of these containers, they together form the whole website. So if you want to connect them all together, you can also make use of networking. So you have multiple layers of networking over here within containers themselves and to the containers as a whole between different servers or different Docker clients, etc. So this is Docker networking, where you can communicate and exchange information between different containers. And it also helps you to create layers of isolation. And in the end, it all helps you to manage these containers. So that's your Docker network. Now we'll be talking about the types of Docker networks. So when you create networks in Docker, you can create different types of networks. So let's see what are these different types of networks that we can create. So one of the first types is bridge networks. Then we have host network. Then we have overlay network. Then we have MAC VLAN network. Then we have none network. So we have all of these different types of networks that we can use between different containers and different servers. So your bridge network is your most default network or the most basic network that is used to connect two different containers. Then you have host network, which basically allows you to connect a container to the host. So in this case, the container will be sharing the namespace with the host. Then you have overlay network, which is basically used to connect different Docker clients. So let's say you have two different servers and you install Docker on these two different servers. So these two different servers will have their own Docker daemons, right? And what happens when you want to connect these two different Docker daemons together? So you would go ahead and make use of an overlay network. Now these Docker daemons may have created their own containers that cannot virtually talk to each other because they are on separate servers. But if you made use of the overlay network, then they will be able to talk to each other. So generally when we talk about Docker swarms, we'll be talking about the overlay network, because in Docker swarms, you'll have a lot of nodes in a swarm, and these nodes will definitely need to, talk to each other. So that's why you use overlay network over there. Then you have MAC VLAN network. So MAC VLAN network is one of those networks that is used only in very specific cases. That very specific case is when you have a old software or a legacy software that only connects to physical network, because in the olden days we didn't come up with the concept of virtual networking, or it wasn't as prevalent, so there wasn't a need for the software to detect virtual networks. So even these days, even though the software may be old, we still use it in some places. And if you're making use of Docker containers because you are trying to advance the type of software development you're doing, you need to make use of both the old legacy software as well as the containers. Now, to resolve the problem of the old software not being able to talk to the container, we try to make use of MAC VLAN network. So MAC VLAN network basically assigns MAC addresses to these containers, and assigning these MAC addresses basically allows the MAC VLAN network to connect the containers to the old software. So this way the software thinks that it's actually connected to a physical network, but in actuality it's just connected to a virtual network. It's just being fooled into thinking that it's connected to a physical network. So that's what MAC VLAN network does. It basically helps us to connect containers to old legacy software. Then we have none network. Now none network is basically used to disable networking for any container. It is not a network. It is basically an option for you to disable the networking for a container. Alright, so we'll go into a little bit more detail about each of these things when we go to them individually. So let's actually go ahead and do that. But before that, guys, these are the different Docker network types. They're basically drivers that allow you to enable different types of networking within your containers. So let's start off with bridge network. So bridge network. So as we've already said, bridge network is one of the most basic networks and it's a default network. So it basically allows us to connect two containers or more containers together so that they can communicate with each other. This creates a layer of isolation between the Docker container that are connected to each other through the bridge network. So if you have two containers and you connect them by using the bridge network, then they can talk to each other, they can exchange information, and basically they know each other's names. But if you have a third container which is not a part of this bridge network, then it cannot talk to these two containers because it is not at all a part of these two containers network, that is its bridge network. So it basically forms a layer of isolation. So if you want to keep abstraction in your microservices architecture, that is, hide the unnecessary data and show only the relevant data, then you can go ahead and do that in bridge networking, where you basically do not connect containers that don't need to be connected to each other. This further reduces the amount of errors and issues that we may have in future. So this is bridge network. So guys, now let's go ahead and try creating our own bridge network. So I'll open my instance over here. I'll type in docker network create driver equals bridge and the name of the network. So I'm going to give the name for this network. Alright, so let's go ahead and type in our command, that is docker network create -- driver. So you have to make use of the driver flag, and then you have to mention the driver you're using. Since we are working with bridge network, we have to mention bridge as the driver. So I'm going to write in BRIDGE. So bridge network. And now I'm going to mention the name of our network. So this is for us to identify this network. So I'm going to name it rainbow. So let me press enter. And you can see that it's been created. Now to check if your network has been created or not, you can go ahead and type in docker network ls. So this will list down all the networks there are in your local system. So as you can see, our default bridge network is here, the one that we created. And you have another bridge network over here. So this, guys, is basically the default bridge network. So basically, whenever you create a new container and you don't mention any specific network to connect it to, it by default gets connected to the bridge network. So if I show you guys, docker run -it-d ubuntu if we do a docker ps, we have one container. Let's go ahead and inspect this. And you guys can see under network, it is connected to a bridge network. So basically, it is being connected to the default bridge network. Now we can do one more thing, that is to inspect the network itself. But right now, let's go ahead and connect our already created network, that is the rainbow network, to a new image, right? So I'm going to go ahead and type in docker run -it-d. I'm going to name this my container, and I'm going to mention the network I'm using. So I'm going to use the network flag. So --network and the name of my network, that is going to be rainbow. And I am going to give it the name of the image. We'll be using Ubuntu. Now let me press enter. And if you do a docker ps, we see that our container called my container is up and running. Now we can go ahead and inspect this container. And I'll put in the ID. And if I scroll up, you guys can see within the network. So you guys can see that the network that is connected to is the rainbow network, right? So we have done it. We have basically attached a network to a container. Now there is another way to do that. You can go ahead and use the docker network connect function. That is, we have an already existing container that is not connected by us. So let's go ahead and use the docker network connect. So docker network connect, and we're gonna give the name of our network, that is Rainbow, and we're gonna give the ID of the container we want to connect it to. So now if we do a Docker container inspect, and if we go inside this container, you guys can see that it is connected right now to two networks, that is the default network and the Rainbow network. So that's what happens if you do not mention a network at the start of the container's creation process, then it will be connected. So you can see how the Docker network connect command works. Now what we can do is we can go ahead and disconnect our Rainbow network also. But before that, I want to show you guys something. If we check out the network list again, we can go ahead and inspect this network. So I will do a Docker network inspect and our network. So let me go ahead and inspect the Rainbow network, and we can see that there are two containers connected to it. That is your blissful query, that's the randomly generated name for the container that we created first, and our my container. So there are two containers in this specific network. Now we will disconnect a network. To disconnect a network, you just have to use the command docker network disconnect and the name of the container. So first you have to type in the name of the network and the name of the container. All right, so let me go ahead and press enter. And if we do a docker container inspect and we check out my container, we will see that it is no longer connected to the Rainbow bridge network. All right, I hope that is clear. Now I want to show you guys one more command over here, that is docker network rm command. So docker network rm command basically allows you to remove any networks over here. So if I want to remove Rainbow network, I can just type in docker rm Rainbow, but I don't want to remove it. In fact, I want to go ahead and connect my container to the Rainbow container network again. So I'm just going to remove the disconnect. All right. Now I've done this because I wanted to show you guys something. I wanted to show you whether these are connected to each other at all or not. To do that, I'm going to enter one of my containers. So I will do a docker exec -it, the name of my container, that is my container itself, and bash. So it's inside this container. Now from this container, we will try to ping our other container. So, so let me first get the IP address of our other container. You can get the IP of a container by inspecting it. So this is the IP through which the container can talk to this container. So let me just copy this. All right. We'll enter my container again. And this time what we're going to do is we're going to install ping in this, since it doesn't have ping by default. Now to install ping, first we have to update the instance, update the container, and then we will install apt install iputils-ping. So this should basically allow us to install ping in our containers. Let me press enter. I'll first update this container and then it will install ping. Okay, it's installing ping. Okay, done. So what we will do is we'll type in ping and the IP address of our container, the other container. So if I press enter, we should start seeing bytes being sent from this container to the other container. All right, so that's enough. Let me show you the ping statistics. So it was sending pings to this IP address, that is for the other container. 11 packets were transmitted, 11 were received, there was 0 packet lost. So that means they were connected perfectly, no issues. So guys, this is how a bridge network works. Now let's move on to the other type of network, that is host network. So basically in host networking, Docker containers are connected to the host network and they share the namespace with the host. So this basically means that the container will not have its own IP address, and to access the container, you'll basically be accessing the IP address of the host system itself. So they basically share the IP address, and they share the namespace also. So let me go ahead and show you guys how to do that. So we can first create a container. So docker run -it -d, and we're going to name my container 2, and we're gonna give it the network. So network is going to be host this time, and we're going to give it the name. Now a name already we've given. So now what we're going to do is we're going to give this the image to use. So we're going to make it use Nginx. Now I'll tell you guys why Nginx in a while. So it will download Nginx for us. Now Nginx is basically a server platform, so it allows us to basically host websites. So right now if I do a docker ps, I can see that my Nginx container is running. Now if I do a curl at localhost, we should see Nginx data coming in. So this is basically what Nginx does. It gets exposed at port 80, that is the default port. And since our container is directly exposed at the host, because it's sharing the IP address and the namespace, that means that if we access the local host, that is, our host's IP directly, we should get Nginx, and we do get it. So this is how host networking works. So you guys can see that a container and host basically share the namespace. Alright, now comes talking about overlay network. So Docker daemon hosts that are connected by the means of an overlay network can communicate with each other. This means that containers present in different Docker hosts can communicate with each other using overlay network. This is useful when we need a set of Docker hosts to communicate with each other in a Docker swarm. So like I've talked about it earlier, if you have different nodes or different servers on which you have installed Docker, and you have containers running on these separate servers, but you want to connect them, then you can make use of overlay network. So if you have Docker host A, that is your server A, and you have containers connected to each other inside of it, then you have Docker host B where you have server B and you have containers within it. And if you want to connect both of these hosts so that containers within these hosts can talk to each other, then you can make use of an overlay network. Now to use overlay network, you need to have a Docker swarm initialized. So I will just do a Docker swarm init over here. Alright, so my Docker swarm is initialized. Now I will go ahead and create a network that is an overlay network. Now I'm using the driver overlay. Now I'm going to give this rainbow overlay as a name. So if I do a Docker network ls, I will see our rainbow overlay network created. Now the scope of it is the swarm, and I can go ahead and run a service within this swarm. So let me type in Docker service create -name our service, and we've given it the name. Now let's go ahead and give it the replicas. So replicas will be 3, and basically we're going to be using the Ubuntu image. So you can see it's preparing the replicas. All right, there was some issue. Let me do this again. Now let's try this again. I'm going to type in Docker service create name our service, and I'm going to give it the network to connect to. That is going to be rainbow overlay network. All right, so with that out of the way, let me go ahead and mention the replicas. I want 2 replicas, and the name of the image is HTTPD. All right, so HTTPD is basically Apache server, and we have our service running. So we'll have 2 containers since we set 2 replicas. Docker ps, we have 2 services. All right. Okay. Now I'll go ahead and inspect one of these. Docker container in inspect. and you will see that within networks, we have rainbow overlay as the network. All right. Okay, so that was overlay networking. Now let's talk about none network. So a Docker container which has none network configured for itself cannot communicate with any service or system, as networking for the container is virtually disabled. It is used to isolate certain containers. So if you want to isolate a certain container from other containers, you can just enable none networking on it. So let's go ahead and try that out. So I'm going to docker run -it -d, and we're going to mention the network. So we want the network to be none, and we'll mention the name of the image. If we do a docker container, sorry, we did not give it a name. So if I do a docker ps, okay, so this is our container. Let me go ahead and copy this. If you see in networks, you can see that the network is none, and you can see the side effects of it, that there's no IP and there's no gateway, so it cannot communicate at all. So I hope this was clear for you guys. So guys, now we're gonna learn about the Docker Compose tool. So Docker Compose tool is something that Docker provides us to help us create multiple containers or create multiple services at the same time. Now let me tell you guys the concept of service. So a service is basically what the name suggests. It's a service. So if you have a payment service that allows you to pay for things, that's your payment service. Now for this service, you can either have only one container that contains all of the code, or you can have multiple containers for this service. What do I mean when I say multiple containers for this service? So when you have replicas of a service, like those multiple containers are necessarily going to be different containers. They will be copy of the same container. The one container that contains all of the code will be replicated as many times as you tell Docker to replicate it. So these are called tasks. So every time you have a service, you have to define how many tasks you're going to have for that service. Those tasks are going to be the replicas of the code that the service is. So let's say it's a payment feature, or the code for the payment feature will be inside one container and it'll be task number 1. Now you replicate it to 2 other containers. So you have task 2 and task 3. These are replicas of the first task. They contain the same code and they basically are part of the service. Now we have multiple tasks so that, we have higher availability for a service. Suppose the first container goes down for whatever reason. Maybe the resources that it was using weren't available to it anymore. So we still have task number 2 and task number 3, which are the replicas of task number 1, up and running. So this way our service is always available to the end user. So that's what a service is. It's basically our feature. All right. So with the help of Docker Compose, you can launch multiple services at the same time. Now, I said multiple containers at the same time earlier when I was talking about Docker Compose because it was a little easier for you guys to understand. Now you guys know it's a service that you're launching. So Docker Compose is a service, or it's a tool that helps us to launch multiple containers/services at the same time. Now, to use the Docker Compose service or to use the Docker Compose tool, you have to make use of something called a Docker Compose.yaml file. Now, YAML files are basically key value pair files in which you enter the configurations for certain things. Now, with Docker file, you gave it the instructions for creating an image. In Docker Compose.yaml file, you're giving the instructions to launch your multiple services. Let me show you guys an example over here. So this is an example of a Docker Compose file where you have first thing is version, and it's being mapped to the value 3. Now version basically states what kind of format is going to be used to write the Docker Compose.yaml file. You have multiple different types of formats. Some are legacy formats and some are very modern formats. So over here we're using the third format, and in that format you write it in such a way. And you can see then we talk about services, and within services we have 2 services that are web and database. So the web service basically defines a container that references Nginx. So when we build this compose file, we will be creating a web service that is referencing Nginx. So since we haven't mentioned any replicas, there's only going to be one container created over here, and it's going to reference this image, and it's going to be exposed at the port 5000. So this is one of your services. And your second service is basically MySQL. So you'll be launching a MySQL container with the name of database. So this is how Docker Compose allows you to create multiple containers or services at the same time. Now you guys can see within the services, you have special key and values, like image has the value Nginx, build is dot, ports is basically the port number, and database, again, the image is MySQL. So these are the different key values you will be using. All right, so now let's go ahead and work with Docker Compose ourselves, and let's try to launch our own set of services. So I will bring up my instance over here. So this is my instance. As you guys can see, Docker is already installed on it. Now to work with Docker Compose, you can't do it directly. You have to install Docker Compose separately. That's how it is. So what we're going to do is right now is install Docker Compose first. So let me show you the commands. So these are the commands that you will be using to install Docker Compose. So the first command over here is sudo curl -l, and it gives you the location of your Docker Compose, right? So let's go ahead and copy this command, and we will paste this command over here, and we will go ahead and press enter. All right, so we have downloaded our Docker Compose and installed it. Now we just have to give the binary, that the Docker Compose binary, some special permissions. So we're going to go ahead and do that over here. So that's by using the chmod command. So basically we are giving some certain access to Docker Compose. Let me press enter. All right, so that's done. Now we're going to go ahead and check if our Docker Compose is working or not. So for that, I'm going to type in docker -compose -version. So yes, it's working. Why? Because we can see the version that it gives us and the build number. All right, so this is us, finishing Docker Compose installation. Now we can start using Docker Compose, the tool that helps us to launch multiple services / containers at the same time. Now the first thing we're going to do is we're going to go ahead and create our own folder, mkdir. I'm going to go into hello. And over here, what we're going to do is we're going to create our own Docker compose.yaml file. So this is going to be the file in which we write down all the configurations that we talked about. Let me open this up. And now we will try to type in all the configurations that we need. Let me bring up the file. So this is our configuration. We've already written it over here. We're just going to paste it. And that's what I would recommend for all of you beginners out there, to write your configurations in some kind of editor or some IDE, and then copying and pasting it is much better, because the indentation over here matters a lot, how much indentation you leave. So let me show you. For version, you don't have to leave any indentation, but for when you start writing network over here, again, you don't need to leave. But when you need to write something below network, such as the network name that I'm creating, I have to leave 4 spaces as given over here. And every time you write something below another key value, then you need to give 2 spaces extra. So similarly, you guys can see over here, 2 spaces, 2 spaces, 2 spaces, and 2 spaces. So that's how the indentation over here works. So let me explain all of these different configurations one by one. So first we have version. So I'm specifying that I want to use the formatting of the third type. And then we will be mentioning the networks that have to be created when you build this file. So the networks that has to be created is called Batman. So this is our network over here, and this is our driver. So basically we're going to create Batman that has the driver that is of the type bridge. So we're creating a bridge network of the name Batman. All right. So this is what you're supposed to mention when you want to create a network. Now we will come down to services. Again, with services, you have, you can see there are 2 services that are mentioned. So in web, you can see I've mentioned Nginx latest, that is the image. and build is dot, and the port is going to be referencing is the 5000 port. So the containers port will be exposed at 5000 and the host will be exposed at 5000. I'll show you guys how this works out. And then we mentioned the network that it makes use of. So you can see a distinction over here. So below ports, I've mentioned a dash and then the port number. Similarly with networks. Now this is the case when you have more than one value for your key. Now for image, I only have one value. But for my port, I can have multiple values. I can even have 80 over here and more number of ports. Even with networks, this particular services can be connected to multiple networks. That's why I'm using hyphen. So this is a list that is being used as arguments for your network or for your key. All right. Now let's come down to the second service. That's the database service. With the database service, you can see that the image that is being mentioned over here is MySQL. And the network is again Batman. So you guys understand that we are creating two services that are going to be connected to the same network, that is Batman of the type bridge. All right. So if we wanted, we could have attached a volume also for these two things so that, they have somewhere to store their data. Now let me make a prediction that, MySQL is not going to work really because we have not given it any credentials. But I just want to show you guys how this properly works. How your Docker Compose file works, and later when we actually working with the actual WordPress code, when we want to launch a WordPress website, I'll show you how you can type in your username and admin and password. All right, let me save this. Control O to enter the name, Control X to exit. Now if I do an ls, I can see the docker compose.yaml file over here. So to launch or to build this docker compose.yaml file, we have to use the command docker compose and up. So this command will basically allow us to build that file. If I press enter, all right, so there is an error. Let's find out what the issue is over here. So the issue is that we have added an extra quotation mark for Batman. Let's go ahead and remove that. Let me save this again, exit, and we will go ahead and build our docker compose file again. So I'll press enter. And you guys can see it's pulling the MySQL image from Docker Hub. So it first created the network called hello_Batman. Hello is the name of our current directory, and it's using that as the proper name for our web services. All right, so we have a message as we assume that, our database has exited, but that's not of a problem. You can see that the error is you need to specify MySQL root password, which we will do. Now let's just look at the other things. Let me duplicate this session so as to not close it. Now, if you wanted this to run in background, what you could have done is you could have used a -d flag, that is the detached flag, and that will allow you to run this in the background. Now, let me go ahead and do a docker ps. As you can see over here, this is the container that we launched. That is hello_web_1, and it's running at the port 5000. Okay guys, so that was the container. We saw that we launched our own container. Now if I did a docker ps-a, we can see even our exited container, that is your MySQL, and you can see the name hello_database_1, and we can go ahead and check out our network also. If I do a docker network ls, we can see that the network that we had created using the docker compose file, that is hello_Batman. And if we do a docker service ls, we can see the list of services that have been created. So right now, this is an older service. Now, if you wanted to see your docker compose services, what you need to do is you need to head to the directory in which your docker compose file is located. So our directory is hello. We'll go inside this and we'll type in the command docker-compose and ps. So if I do an ls, I can see my two services, my two docker compose services, one of them exited and one of them is up and running. All right. So this was us, playing around with docker compose. Now let's go and really create our own, a WordPress website using docker compose. So let me go ahead and create another directory. All right. So inside of this, I'm going to go ahead and create a docker compose.yaml file. And inside of this, I'm going to paste the code in, or the configurations. These are my configurations. Let me copy them and we will paste them here. And I'll show you what they entail. So as you guys can see over here, we have services. The first service is called DB. The image is MySQL. It has a certain volume. It restarts always. And we have given here the password. That is MySQL root password is some WordPress, and MySQL database WordPress, MySQL user WordPress, and password is WordPress. And then we have another service called WordPress over here. I went out too down. Yeah. So this is WordPress. It depends on DB. So when we say depend on DB, that means it will only be launched when DB has been launched successfully. So this won't launch if DB has failed. Then we have the image that is being referenced, that is the WordPress image, and the port it's using as at 80, and it restarts always. And this is the environment variables for WordPress. That is the host, username, password, and name. So let's go ahead and save this, and let me do a Docker compose up, and you can see it's pulling the images, and it's going to start creating the specific things that we asked it to, like it created the network and volume, as you guys can see. So now it's created our WordPress basically WordPress website, as well as the WordPress DB. Okay, so now we can go ahead and view this. So if I paste in the IP address and we go to the port 8000, press enter, and you guys will see that our WordPress website installation process has started. So this means that our WordPress is working totally fine because it depends on the MySQL. So MySQL is also working. We can go ahead and click on continue and configure our WordPress to be what we want it to be. And we can go ahead and install this. All right, so guys, this was us learning how to use Docker Compose to launch, a WordPress website. Also, guys, if you type in Docker Compose down, it will shut down your service. So if you want to shut down your service, just type in Docker Compose down where your compose file is, and it will remove all the things that were necessary to run your service. So you will see that they are no longer there. So that's how you shut it down. You launch it with Docker Compose up and you shut it down using Docker Compose down. Okay, guys, now we're going to learn about Docker Swarm. So just like Docker Compose, Docker Swarm is another service, but Docker Swarm is not something you'll have to install separately. It comes with Docker itself. So let's discuss what Docker Swarm is, what orchestration is, and why do we need all of these things. All right, so let me start off by discussing why orchestration. Why do we need orchestration at all? Now imagine orchestration as the word's original thing, that is orchestra, where you orchestrate things, where you have an orchestrator, the main person in the middle who orchestrates the music. So similar to that, we have orchestration even in software development, where you have one person dictating how everything goes on. So you have an orchestra of containers, and you have one orchestrator deciding what happens with these containers. So it's kind of in the same vein that you're managing and handling a lot of different containers instead of people over here. So why do we need orchestration? So orchestration allows us to manage and maintain multiple containers at the same time. This is especially helpful in software development, where we may be making use of microservices architecture, as it breaks down the software into small manageable chunks. Now, as I've discussed earlier, microservices architecture basically states that you can divide your software into multiple chunks, into multiple smaller chunks, and with orchestration you can manage these small chunks. So that's why small manageable chunks. Now, having different configurations and environments also becomes easier with orchestration. So you may think that having so many different software chunks may be difficult to manage, but it's actually the opposite case is true, because you have so many different containers, but they have their own specific use cases and their own specific environments and configurations that you can easily identify them, and you can easily go to them and change their settings according to your requirements. So this is why orchestration is very important. So again, orchestration is just us managing and maintaining multiple containers in a cluster. All right, so now let's look at the benefits of orchestration to understand more why we make use of orchestration at all. So here are the benefits of orchestration, where you can see that we have easy deployment, easy management, easy resource management, allows for health monitoring of the containers, load balancing among different containers, easy updating, easy scaling up and rolling back, and creates a layer of security. So easy deployment, right? So where you can easily deploy your software. So when you have manageable chunks of your software deployed or on different containers, it becomes very easy to deploy it because you can very easily put them in a swarm and you can easily put them in a production environment. So once you do that, it becomes, very understandable where your software is and, how you've put it up. So that tells us the easy deployment part. Now comes to the easy management. As I've talked earlier, you have your individual chunks in individual containers or individual nodes, right? So over there, you know where your software is or that piece of software is. So if there are any issues that you may want to rectify, it becomes very easy to do so because you just have to go there and, make the change. And again, resource management also becomes important because you have to divide your resources equally or, appropriately among your software chunks, because it's important to manage your resource pool as well as software, because you can't always give as many resources as you want because you may not have access to so many resources. So you want to give the appropriate amount of resources to all of your software because you have to reduce the cost of deploying your software or you maintaining your software, as well as providing the best product as possible. It also allows for health monitoring of containers. So that is again an important factor here. You need to make sure that your containers are always up and running, and that ensures that your software is up and running and to your end users. Now, if something goes wrong and the container crashes, then you should be able to get the notification for the same. Otherwise, you wouldn't know what went wrong and you wouldn't be able to rectify that mistake. Now, generally in these kind of cases, you will have replicas that try to maintain the availability of certain features. If one container goes down, you have another replica container of that takes its place. So that again helps us to increase the availability in this kind of environment. But health monitoring is still important, where you monitor how everything is doing, not just if it's crashed or not. You even want to see if a container is doing well, resource management wise, or its performance wise, if it's doing well or not. If something is wrong, you need to identify that problem and you need to fix that problem. Then comes load balancing among different containers. Now when we talk about load balancing, we're talking about balancing the type of load these containers take in. So if there is a lot of different tasks being assigned from the manager node onto the worker nodes, and so the work will be assigned on the basis of how many of these containers are idle. If they're idle, they will get the work first, or if they have a resource pool in which they can take up more tasks versus another container that cannot take up any tasks, the work will be divided accordingly to that. Again, load balancing is important because it allows us to maintain an efficient resource management policy where we are dividing the resources equally or appropriately, and we're making sure that our tasks are being run on the worker containers or nodes. So easy updating, it allows us to easily update our manageable software chunks. So you don't have to update the whole thing. If you just want to update a specific feature, you just have to go ahead and update that specific feature. You don't have to update the whole thing. And orchestration, since it manages the whole thing, it allows you to easily do this. And easy scaling up and rolling back. So this is the most important thing, because you want to be able to scale up your operations, and using the help of orchestration, you can easily scale up the amount of servers that are handling your software and the amount of containers that are handling your software. So if you wanted to scale up your operations, it would be very easy to do so if you're making use of an orchestration tool. But if you're not, then scaling up would be a little bit more difficult. And again, if you want to scale down, that is also an option. Now, rolling back, it's like updating, but you're just rolling back a certain update that you had performed earlier. If there was something wrong with the update, or if you remembered that there's something new, better that could be put instead of it, you can just roll back your most recent update. That is an option available with the help of orchestration. And then it again creates a layer of security over all of your containers and nodes. So having orchestration basically helps you, maintain a robust security all over, and all the other benefits like easy deployment, easy management, easy resource management, health monitoring, load balancing, updating, scaling up, and rolling back. So these are the benefits of having an orchestration tool help you orchestrate your software. Alright, so we have many different orchestration tools available to us out there, like Kubernetes, Docker Swarm, ECS, EKS, and a lot of different other services. Now, the one that we will be talking about in this tutorial is Docker Swarm. Now, Docker Swarm is an orchestration tool provided by Docker itself. So let's go ahead and study about Docker Swarm. So Docker Swarm is an orchestration service within Docker that allows us to manage multiple containers and handle them at the same time. It is also a cluster of multiple containers. Now this may have confused you a little bit. Is it a cluster of multiple containers, or is it something that we use to handle and maintain multiple clusters at the same time? Well, the Docker Swarm is a cluster of multiple containers, but the Docker Swarm kit is the one that allows us to manage and handle the multiple containers. So they're kind of same, but you have one as a cluster and the other one managing this cluster. So inside of this cluster, what are you going to have inside of this cluster? What does any cluster have? Any cluster has a number of entities that have similar properties. So this cluster will basically have containers. Containers are similar to each other, right? And you'll have these containers divided into two kind of categories. You have manager nodes and you have worker nodes. So manager nodes are the ones that will divide all the tasks up and give them to the worker nodes. And worker nodes are the ones that are going to be performing all of the tasks. So this is how, normal human work life also works, where you have one manager and you have several workers, where the manager assigns the work to the workers. The manager node need not do the work by himself. So even in Docker Swarm, your manager node need not do the work at all. It may just divide the work among the worker nodes. So this is your Docker Swarm in basic. Now let's study the Docker Swarm architecture to better understand what Docker Swarm is. Alright, so let me show you the architecture over here. And as you guys can see, the Docker engine basically, gives all the requests from the user onto the manager node. And from there, it is divided among the worker nodes. So let's say the user gives specific services that he wants to run on the Docker Swarm, then he will do it through the manager node. Now, once he does it through the manager node, the work will be divided among the workers. So if that service has 3 tasks definitions or 3 tasks, then those 3 tasks will be equally divided among the workers, because that's your load balancing, where equal amounts are divided among the workers until the resource pool gets over. So this is how it works, where you have one manager node dictating the work of all the other worker nodes in a Docker Swarm. Alright, so now let's see the Docker Swarm components. So we have a few Docker Swarm components like service, task, manager, and worker. Now I've already explained to you what service and task are before, but I will talk about them again. Here, manager and worker are basically nodes. And we have one more component, that is your load balancing. So service and task. So as I've talked about service before, service is basically your feature that you deploy on your Swarm. So any feature, let's say you're talking about your payment feature, that can be your service. So you can call your service payment service, and you can define how many tasks you want to have for your payment service. So having having more than one number of tasks basically tells you that how many containers you're going to be having for that particular service in your Swarm. So if your payment feature has 3 defined tasks, then it's going to have 3 different containers running across the Swarm wherever they can be. Now we are running this 3 times. Why are we running our payment feature three times? We don't really need to. We just need one container, right? So the reason why we have 3 containers for our service payment is because we have those extra containers as replicas. They're like backups. So let's say that one of your tasks or one of your containers that hosts the payment feature actually goes down because of some reason. Maybe it's not able to get right amount of resources because the container is not able to provide it, and that is due to some kind of issue. So we can't figure that out like instantly, because we have to sit down and we have to debug and we have to see what went wrong. But while that is happening, we can have the other task take up its position. So if they take up its position, then you don't have your payment feature going down. You have something else covering for it. So this again gives you the reliability for your service, and you get reliability for your service, and you get reliability for your end customers, that you can show them that you have done you can show them that you have a feature, and even though it's down, you can still make use of it. Then you figure out what the issue was, you fix it, and then you deploy your service again. Now, there are two types of services you can launch. There are replicated services, the one I just talked about, and then there are global services. Now, when you initialize your service as a global service, when you mentioned that your service is a global service, then what happens is your service basically has one task running on every node within the swarm. So let's say you have 5 nodes running inside your swarm, and you've made your service global service. Then at least one task of your service will be running on each node. So this is what happens when you make it into a global mode. All right, now let's talk about the worker nodes and the manager nodes. So basically, these are instances. They are basically their own Docker daemons, their own Docker engines. That is, manager will run on its own server, the worker will run on its own server. So when I say nodes, I mean proper servers. So if you wanted to work with different nodes, you will have different servers, and you'll have this separate Docker engines working on these separate servers. So you can have multiple containers on each of these nodes that are separate from each other. So that's what makes it special over here, because you're running multiple nodes instead of multiple containers. Now, I said it's easy to manage and handle multiple containers. And in trying to say that, I was actually saying that it's easy to manage these nodes, and within these nodes you have those multiple containers. So whenever you run a task, right, you have maybe, let's say, 4 tasks of a service to run. They will be running on multiple different nodes. So you'll have like 4 containers running across 4 or how many ever workers you have. So these are your nodes. All right, so now let's talk about load balancing. There are 2 types of load balancing. One of them I've already talked about. That is the internal load balancing, where you divide the tasks among the different nodes within the Docker swarm. Then there is something called ingress load balancing that allows you to basically make your services exposed externally. So let's say you have a certain, feature that you have launched as a service within Docker Swarm, and you want to expose it, externally. Then you would make use of the ingress load balancing feature within Docker Swarm. So these are the components of Docker Swarm. I hope you guys understood, and that was the architecture. Now guys, we will go ahead and learn the Docker Swarm common commands, after which we'll basically be learning how to deploy in a Docker Swarm, and also we will be learning how to manage in a Docker Swarm. So let me bring up my instance and we will start working on it. So as you guys can see over here, we have 3 instances launched this time. Now I've launched 3 instances this time because I want to show you guys how a proper Docker Swarm works. Because we're going to have one master node or a manager node, and we're going to have 2 slave nodes, slave node 1 and slave node 2. Now you guys will see I've color coded them. So the orange one is our Docker manager node, and the blue or the cyan ones are our slave nodes. So we have 2 of them over here. So these are our slave nodes. So now we'll start working with them. So I'm going to head to my manager node, and remember guys, you have to install Docker on all of them for this to work. So first we're going to go ahead and initialize our Docker Swarm. So that is a part of our common Docker Swarm commands. So let me go ahead and bring that command up. First we're going to go ahead and type in Docker Swarm init. Now you can directly do this, or you can add in the flag advertise addr, and you can give in the IP address of your manager node. So let me go ahead and get the IP address of my manager node, and I'll paste it over here and then press enter. Now, once I do this, you will see I get a output over here. First output is that swarm has been initialized. This is my current node. That is now the manager. To add a worker node to this swarm, run the following command. So this is my command, docker swarm join -- token and then the token. So let me go ahead and copy this command. So what I'm going to do with this command is basically we're going to add a worker. We're going to go ahead and add a worker to our swarm. Now I will open up one of the worker nodes over here. Let me paste in the command and I'm going to press enter. So as you guys can see over here, it says that this node has joined the swarm as a worker. Now we can go ahead and do this with our second node also. Let me go ahead and paste this. Okay, it copied something else. Let me copy this command again and we'll paste the command here and we'll add sudo. And you can see that this node has also joined the swarm as the worker. So we have successfully, initialized our Docker swarm and we have added 2 workers to it. Now, how do we check all of that? So we can check all of that easily. All we have to do is type in the command docker node ls. So this basically lists down all the nodes in your swarm. So if I do a docker node ls over here and if I press enter, you guys can see the formatting is a little bit weird. Let me go ahead and change the settings. We'll increase the fonts. We'll decrease the font size so the formatting is a little better. Okay, now you guys can see. So this is our node ID. This is our host name, the status, their availability, and their manager status and their engine version. All of them are using the same engine version, but you guys can see that the leader is a little bit different. So the lead over here is the node that we are on currently. You can even see that there is a wildcard over here or a star. This indicates what node you are on, and we are on this node. You can see the IP matches over here. So this is our leader node, and this is how we check out our Docker swarm. Okay. All right. Now I want to show you guys what happens when one of these, nodes leave the swarm. So let me go to one of the nodes and I will type in the command docker swarm leave. So this command basically helps us to remove a node from our Docker swarm. If I press enter, it will first ask me for permission. So let's go ahead and do this with sudo. And you can see that we get an output that node has left the swarm. What happens when we check the docker node ls command over here again? We can see that it's not, the change hasn't shown any effect over here. Let me go ahead and do this again. It takes a little bit of time, but you guys can see now that the status says down for one of these nodes. So we have basically, made our node go down. So this means that, our node is no longer a part of the swarm. What we can do is basically we can attach the node again using the Docker swarm join token. But if you wanted to remove this node, we can go ahead and use the command docker node rm and the node ID. So if we do a docker node ls again, we can see that that node is no longer there. Now, if you wanted to, join the node again and, we can just go ahead and paste that command that we did earlier. But the problem is that, we don't have the command over here anymore. So how do we get the command? So there is a command for that also. There's a command that allows you to get the worker token. So we will type in the command docker swarm join token worker. So you guys can see that, my command gives me the command again. So let me just copy this command and I'm going to go ahead and paste this again. So this node has joined the swarm as a worker again. And if we do a docker node ls again, we can see that we have the node joined again, this time with a different ID. Now, if you wanted to see the information for our Docker swarm, what we can do is we can type in docker info. So this command basically gives us the information about our swarm, and not just a swarm, basically about every, all the details about a Docker itself on the system. You can see over here there are a lot of different things, like is the experimental value enabled or not? Is the debug mode on or not? What is the Docker root directory over in this system? What is the IP? What is the total memory? A lot of different things over here. So you can even see the server, how many containers are running, or paused or stopped, what images are there, how many images are there. And we can even see the swarm details over here. So the swarm is over here, and you can see that the swarm is active. This is the node on this particular system. And is it the manager? Yes, it is the manager. This is the cluster ID. This is the number of managers. This is the number of nodes inclusive of the manager. And this is the default address pool. So all of the nodes within the swarm will be given IPs based on this, and the subnet size and the data path port. All right. Cool. So this is the information you can check out on your master node or your manager node, or you can, check it out even on your worker nodes. You will see similar information, but there'll be a lot of differences, like, that this is not the manager, and it will give you the manager address separately. All right. Okay, so guys, those are the, basic Docker Swarm commands. Now I want to go ahead and show you how to launch a service. To launch a service within a Docker Swarm, you have to do so from the manager node. So you can't write Docker service create anywhere else other than that manager node. So let me go ahead and write here Docker service create name our service, or let me give it a more fun name, fun service. And we're going to give it the number of replicas. Again, guys, this defines the number of tasks or number of containers for this service that we will be creating. Let me say 3. And I'm going to mention the image I'm going to be using. I'm going to be using the HTTPD image. We can go ahead and put in the publishing port also. So -p 80:80:80:80. All right, so now I'm going to press enter, and we will see that it's creating our tasks or our replicas. It's preparing them, and you can see it's verifying whether they are stable or not. They've already created them. They're running now. All right, so our service has been basically created. Now we can check our service has been created or not using the Docker service ls command. So this lists down all the services we have. So right now we have only one service. It's called fun service. This is the service ID, and its mode is replicated. It's not global. It has 3 replicas, and its image is HTTPD latest. All right. Okay. So now if I do a Docker PS over here, I can see there is one container running over here. So that is one of the tasks. Now it's going to be the same, these 3 containers are going to be the same thing. It's just that they have different names and they are launched on different nodes, because our swarm basically load balance them onto different nodes. So if we come back over to one of our Docker worker nodes, if I do a Docker PS over here, you guys can see that there is one container over here. And if I do similarly on my another worker, you can see that there's a container over here also. So now this would be tedious if you wanted to check in all of them. So there is a special command to check where your service replicas are launched. You can just type in Docker service PS, the name of your service. So the name of our service is fun service. Let me paste this and I press enter. You guys can see that it gives me the list of the replicas for this specific service. And over here we can see that, the fun service 1.2.3, their IDs, their image that they're using, the nodes on which they're launched, what is the desired state, and what is the current state, and is there any errors or not. So we can see that there are no errors and it's been perfectly launched. Now I want to show you guys what happens when I remove one of the swarm workers. So if I come back over here and if I do a Docker swarm leave, then let me do this with sudo. Now you guys can see that this node has left the swarm. So if I do a Docker service PS fun service again, you can see that they're still running. Okay, so this hasn't updated yet. So let me go ahead and show this again. All right, so now you can see that this particular fun service.1 has stopped running because the desired state is now shut down, but we have this running again somewhere else. It's no longer running on the 23 IP node, it's running on the 148 node, right? Now, if we go to that worker node and if we do a sudo docker ps over here, we can see that we have two containers running now. So this is what happened. This basically internally load balance the containers to make sure that the replicas are still running. Our desire is to run 3 replicas, and it will run the 3 replicas no matter how many nodes you have. All right. Now, if you wanted to check out your service information, you can do a docker service inspect, and you can type in your service ID or your service name. You can see a lot of information for your service, like the ports, the virtual IPs, the endpoints, and etc. If you wanted to see this in a better format, you can go ahead and type in the same command and use an extra flag called the pretty flag. This will give it, in a more organized manner. ID instead of the JSON format, you will see it in a text format. All right, guys. Now we will go ahead and deploy a service onto our Docker Swarm. So to do that, guys, what we're going to do is we're going to use a .yaml file. So just like we did with Docker compose.yaml file, we can go ahead and launch any .yaml file with the help of Docker Stack. Now, Docker Stack is very similar to Docker Compose, but the difference is that you launch stack of technologies over a swarm. Now, Docker Compose can be launched within a node or a single Docker client itself, but when you want to do it over a swarm, you can make use of Docker Stack. To show you guys how that works out, let me go ahead and create a file called temp, or let me call this fun.yaml. Now we will open this up and I'm going to paste here the code. So the way you're going to write in the code is very similar to the Docker Compose file. Let me go ahead and copy our WordPress website information and we'll paste it over here. Okay, so basically launching the DB and the WordPress. Let me save this. And now we will deploy this. To deploy this, we have to go ahead and make use of the command docker stack command. So we're going to type in docker stack deploy -c, and we're going to give the name of our .yaml file. And now we're going to give the name of our stack. So I'm going to call this fun stack. All right, then we're going to press enter. So you will see that it's created the network, the service, and the service WordPress and the service stack, a DB. All right, so if I do a Docker service ls over here, we can see that there are 3 services. We have fun service, fun stack DB, and fun stack WordPress. So the replicas haven't yet been created. While they're being created, we can go ahead and remove a fun service. So to remove a service, we can use the command docker service rm and the name of our service. All right, now if I do a ls again, you can see that my services have now been launched, and I can do a docker service ps to check out where these services have been launched. Okay, so one of them is running on 237, that is this manager node itself. So if I do a docker ps, you will see that my container for WordPress is running over here, and for my DB is also running over here. So both of them are running in the same place. I don't need to check for DB and WordPress. All right, so both of our services are running over here. If we had replicated them, they will be divided accordingly. So right now we have only 2 nodes. One of them is down. All right, so now that we have deployed a service, we have a running WordPress website. So to this WordPress website, we can perform a lot of different operations. One of those operations is scaling. So we can go ahead and scale our service using one of the scale commands. So let me go ahead and show you the scale command. So docker service scale, and I will mention the name of our service. I'm going to paste that service. and I'm going to mention equal to, and I'm going to mention how many replicas of this I want. So if let's say if I want 3, I will write 3 and I'll press enter. So you can see that it's starting to create those replicas for me. It's preparing them. One of them is running already. It's preparing the rest of them. So if I do a Docker service ls now, we can see that we have 3 replicas for my fun stack WordPress. If I do a Docker service ps, I can see that 2 of them are running on my worker node and 1 of them is working on my manager node. All right. Okay. So that is your service scale command. Now let me quickly go ahead and add my other node back again. All right. Now we'll talk about basically rolling updates. So if you wanted to basically, improve, if you wanted to roll back a update, or if you wanted to, basically, perform, if you wanted to update any of your images, let's say we already have MySQL, a certain version. If we do a Docker PS, you guys can see that it's using MySQL 5.7. Now, if I wanted to, change the image of this, I can go ahead and make use of the command Docker service update, and I can use the image flag and I can mention what image I want. So let's say I want MySQL latest. I will update this particular service with the latest image. So let me go ahead and get the name of my service. So this is the syntax you have to follow, guys. And if I press enter, you will see that it will start updating. The only task there is with the latest MySQL image. So we have basically performed a rolling update. Now, if you wanted to drain a specific node, you can go ahead and do that also. Now, what does draining mean? So let me show you. So if we do a Docker node ls, we can see that we have 3 nodes in this swarm. Now, what if I don't want my manager to do anything? I just want my manager to be, it should not do any tasks. It should only be distributing the tasks. So what I can do is I can update this node in such a way that it does not take in any new tasks. So if I do a Docker node update and I give it the availability option, and I perform drain on this particular node. Let me copy the node ID. Let me paste the node ID. So you can see that this node is now drained. So if we do a Docker node ls again, we can see that this particular node has been drained. And I'm pretty sure if we do a Docker PS on this, we will have no containers running on it because we drained it. So this is very useful when you don't want specific nodes to perform any task, or if you want to perform some sort of maintenance. So guys, this is all about Docker Swarm. I hope you guys understood what was taught. Deploying a website on ECS. So guys, now we will go ahead and learn what ECS is and how we can deploy a website using Docker images on ECS. So starting off, we will talk about, basically ECS. ECS is Elastic Container Service. So it is a service that is provided by AWS, Amazon Web Services, that allows you to orchestrate a set of Docker containers using your own Docker image. So it's like Docker Swarm or Kubernetes. It's an orchestration tool that allows you to manage, scale, and do all the tasks the orchestrator can do on a cloud service. Okay. So it has 2 methods of doing so. The one is Fargate and the other is EC2. So we will go ahead and learn how to deploy a very simple website on ECS. So let's start off by going to the terminal. Let me go ahead and increase the size a little bit so that you guys can understand and see. All right, so we're going to change it to 16. All right, so my first task here is basically going to be creating a new folder. Let me go ahead and name this project folder. I will head inside this project folder, and inside of this I'm going to go ahead and make my simple apps. So let me create index.html. Over here, let me quickly write some simple code. All right, so we have our very simple index.html file. I've saved it. Now come out. Okay, now we're going to go ahead and create a Docker file out of it. So basically, we're going to create a Docker file, and let me show you Docker file. So right now our goal is to construct a Docker image. So we will go ahead and create a Docker file. I will use the from instruction. I want my base image to be Nginx Alpine, and I want everything to be copied from the local directory to. So we're going to copy the index.html file onto this container that we will create from this image. So I want it copied to /user /share /nginx /html. Okay, so this is going to be a Docker file. Let me go ahead and save this. So if I do an ls, I can see we have two files, Docker file and index.html. So now I'm going to go ahead and build our Docker file. So I will use the command docker build -t. This is going to be the tag flag. I'm going to name this HTML Nginx website. And let me go ahead and give it a version 1. And I will put the dot over here. So it will start building my image. Okay, so if I do a Docker images over here, I should see two images, Nginx and HTML Nginx website with the tag v1. Okay, so now that we have created our Docker image, we can, basically go ahead and make use of it in ECS. But before that, let's go ahead and test this out if it's working or not. So I'm going to run this docker run -ti -d. I'm going to publish this at the port 80, and we're going to copy this name and :v1. So if I do a docker ps, I can see it's running at this particular port. Let me go ahead and copy the IP address of my instance and paste it over here. All right, so it's working. This is a simple website. This website is beautiful on the inside. So this is what we wanted in our Docker image. So basically, Docker image has, if created or, created as a container, will basically, deploy our website. Okay, so we have now created our simple website. Our next job is to basically upload it onto a registry and reference that registry when we are working with ECS. So first, what we're going to do is we are going to go to AWS. In AWS, I'm going to create a registry, Elastic Container Registry. So you guys remember Docker Hub, right? An alternative to Docker Hub is ECR, that is Elastic Container Registry. So you can go ahead and create your own registry on AWS and store all of your Docker images. So we'll click on Get Started. We are going to name this Docker repo. Okay, so this is my name. Then I'm going to click on Create Repository. All right, so I have created my repository. We'll copy this URI. We'll come back over here. Now our job is to basically authenticate this particular Docker client. To authenticate this particular Docker client, we will first install apt install AWS CLI. All right, so we have installed AWS CLI on this system, and now we need to authenticate this system. To authenticate this system, we need a specific command. To get that specific command, come back to your AWS ECR repository, click on the repository you just created, and click on View Push Commands. So over here, it's going to give you a command that will help you, retrieve an authentication token and authenticate your Docker client to your registry. So we want to make sure that, our client is authenticated for AWS. So I'm going to copy this command and I'm going to go ahead and paste this command over here, and I'm going to press enter. So once you see login succeeded, this means your Docker client on this particular instance is now authorized to push and pull images. So we can finally go ahead and push our images. So before that, what I want to do is I want to tag this image that we have created. So Docker tag the name of our image v1, and we are going to go ahead and name it with the URI of our repository. And I'm going to paste this over here and press enter. Now if I do Docker images, I can see our new image is just the same image with the name changed. Alright, so we will go ahead and push this image using the command docker push and the image name, and then press enter. You can see that this push it's pushing the image onto our repository. So if we click on Docker repository, we can see that we have an image pushed to this repository at this particular time, and this is the image URI. So we can reference this image using this URI. So we have completed the first step, that is, uploading our Docker image. That's the second step, where we have, uploaded our Docker image onto our ECR, that is Elastic Container Registry. Now our next step is going to be basically starting to work with ECS. So you can either click on ECS over here, or if you want, you can go ahead and look it over here. Just type in Elastic Container Registry. So click on this. Sorry, not Elastic Container Registry, Elastic Container Service. Alright, so as I told you guys earlier, ECS is basically a service that Amazon gives us to deploy, manage, and scale Docker containers, running application services and batch processes. Now, Amazon ECS places containers across your cluster based on resources needed, and it's integrated with familiar features like Elastic Load Balancing, EC2 security groups, EBS volumes, and IAM roles. Now, before you move forward, we need to do one more thing. Just open EC2 in another tab, EC2 Management Console. We need to make sure that a proper IAM role is attached to this particular instance. So we will go ahead and edit that in our instance. Okay, so I have one running instance, that is the one that we were working on. All right, so this is the instance. I'm going to click on actions, go to instance settings, and attach and replace IAM role. So over here, make sure that you have a particular role connected to this particular instance. Make sure that this role has access to all EC2 services and all ECS services. And if you don't have a role over here, go ahead and create a new role. Okay, so when you create a new role, click on create role. Over here, choose AWS service, then click on EC2, then click on next permissions. Over here, search for policies and check for ECS, Amazon ECS full access. So it will give all the accesses, and do that with EC2 also, because you'll be using EC2. Amazon EC2 full access, then click on next tags. If you want to add a tag for this, like write email and the email value for this particular role, or any other name, maybe the name and the name of that person who's using this role, then you can click on review, give this role a name, specific name, and then you can go ahead and click on create new role. Now I'm going to close this, and we're going to come back, and once you're done, just choose your role. If it's not there, just click on refresh, then you'll see it. I'll click on apply over here, then we have an IAM role. Operation succeeded. And remember that you have to do this before you do any of the authentication. Okay, that is a necessary step. Before you go ahead and copy the push command from the ECR and apply it over here, then tag it, make sure that you perform the attaching of the IAM role successfully. Okay, so now that we're done with that, we can move on to the next step. That is to basically, work with ECS. So like we said, ECS is an orchestration service. Now you can directly go over here, but I would recommend, click on getting started, because it gives you a very easy way to start. So you can see a diagram over here of how ECS objects relate to each other. You have container definition that defines how a container is going to be. Then you have a task definition that explains all the specifications of how the container, what all resources will it need, and how many, what all containers are going to be there. Then service will define how many containers are going to be, how many replicas are going to be there, and cluster is basically where you store all of your containers. So, and container definition will be basically referencing the image you have, Docker image. So you have a lot of definitions over here. Basically, container definition, you choose an image. So that's your choosing an image, container definition. Now you have many options. You can choose sample app. Now it's a sample app that AWS provides itself. You can use Nginx or Tomcat web server, or what you can do is you can choose a custom one, because we already created an image for this. So we'll go ahead and click on configure. We'll wait for the side panel to open. Go ahead and change this name to something more relevant. HTML Nginx website. That's the name. Now we need to get the image URL. So it was handy that we had stored our URL in basically ECR. That is Elastic Container Registry. So it becomes easy and does not require any specific authorization. No private repository authentication is required, because we have it on ECR, and if it's on ECR, then you don't require this. So let me just wait for this to load up. Then we will copy the image's URI and we'll paste it over there. All right. So I'm going to go inside my Docker repo. Okay. I have my image URI. I'm going to copy that and I'm going to go ahead and paste it over here. Okay. Then I'm going to give it a soft limit of 512 MBs. So this is basically for, how much memory should be reserved for the container. Now ECS recommends 300 to 500 MB as starting point for web applications. So, you go ahead with that. And then it's going to ask us to map the container at the specific port. So let me type in 80 over here. Okay. So basically what we're doing is we're basically exposing the container at the port 80. And by default, any instance on which our container will be launched exposed at port 80. So it will be container exposed at port 80, and whatever it's being launched on, exposed on port 80. So we can view our application. So you can click on update. So you have your container definition over here. Now remember that we are using Fargate. So I'll tell you guys the difference between Fargate and EC2. Let's go ahead and actually use this right now, and then I'll tell you guys what's the difference. So we're gonna go through the task definition. So unlike container definition, which basically defines the image that is used for your container, task definition is a blueprint for your application. Like it describes one or more containers through attributes. Some attributes are configured at task level, but majority of attributes are configured at container. So it's basically, per container. So what network mode are you using? So task execution. So all of this is going to be handled by Fargate. So we don't have to worry about this. We'll move down and we will click on next. When we click on next, it will give us an option to define our service. So in defining our service, right, it will ask us, how many specific tasks do we want for it. If we want it to be 3, then we have to go ahead and configure it ourselves, but we are just getting started using Fargate. So that's why we haven't been given an option over here. Okay. So a service allows you to run and maintain specified number of simultaneous instances of task definition in an ECS cluster. All right. So you can, apply an application load balancer if you want. We will actually go ahead and click on this. We'll click on next. We will give this cluster a name. So we have defined all the 3 layers: container definition, task definition, service. And now we just have to name our cluster. So I'm going to name this HTML Nginx web cluster. Make sure to give it a relevant name, because then you can identify this cluster. Then I'm going to click on next. So when I click on next, it will ask me to review all of the data that I have configured over here. So task definition over here, I want to make sure that this is going to be my task definition, that this is going to be my service definition, my cluster definition, etc. You can edit it over here by clicking on edit. If you think everything's fine, just click on create new. And we'll start creating all of the services, the cluster, all the resources that are going to be used for launching your website. So our resources are completed, everything's completed, cluster is created, task definition, service. Now we're going to click on view service. In our view service, you see the status as active, the task definition over here, the service type as replica, launch type as Fargate. And you guys can see that it's exposed at the port 80. So over here, you can click on target group and open it up in a new tab. And this will take you to the EC2 management console. So let's wait for it to load up. We actually want to get the DNS through which we can access our website. So we need the load balancer right now. So right, so we have target groups over here. So from here, we're going to click on our load balancer. So you guys can see all the details over here. So you guys can see we have the load balance over here. We're going to open it up in a new tab. We already have it over here. So let's just close this. So we have the load balance over here. You can see the basic configurations. We need to copy the DNS name over here and we need to paste it in a new tab. So when we paste it in a new tab and press enter, it will take us to the website that we had created. That is, this is a simple website and this website is beautiful on the inside. So hooray, we have created our website. We have deployed it. Now, the reason we do this is because we'll have multiple replicas. So that means we'll have multiple containers for the same service. So it helps us, if one of them goes down, then the other one is always up. So that way our service is always up. And here the load balancer basically allows us to balance it between the other replicas we have, and we can access it at the port 80. So if we click on tasks over here, you guys can see the different tasks that we're running. If you don't want to access it through the DNS, you can access it directly through the IP. So while we click on this task over here to access it directly, we'll click on clusters. So I'll show you the contents of the cluster. Let's just open this tab and over here. All right, so in clusters, basically it will show us the contents. All right, so this is our cluster. You can see one service, one task running, 0 pending, and 0 container instances. All right, you can see over here all the tasks running task counts like 1 Fargate, 0 EC2. So we're running Fargate. And you can see all the other things like the status is active and the tasks that are running and the EC2 instances, the metrics, schedule tasks, tags. So if you want to schedule tasks based on certain times and tags and capacity providers. So we have the task over here. And if you go down, you can see the IP address of the task. If you copy the IP address, you can access it again using the IP address if you press enter. And it will lead us to the website that we had just deployed. So now that you guys have understood how ECS instances work, ECS works with Fargate, now I will show you guys how to create our own thing without using the getting started option. We'll click on task definitions for that first. So when we were getting started, it automatically created a task definition for us. But what we will do is we will create it for ourselves manually by clicking on create new task definition. So task definition specify the container information for your application. And you guys can see there are 2 types over here. One is the Fargate type and the other one is the EC2 type. So with Fargate, you guys can see there are a lot of differences. Like in Fargate, there's a price based on the task size. And in EC2, you guys can see the price is based on the resource usage. Now the difference is so because in EC2, you can manage EC2 that we launch it on. Whereas Fargate, you don't get to manage any of these things. No Amazon EC2 instances that you can manage. You just have to manage it by yourself. So in EC2, you have its self-managed infrastructure. So if you want a higher amount of manageability, you go for EC2. But otherwise, you go for Fargate where you don't need to do all of this configuration for your infrastructure itself. Now, one of the downside is that you need to use only the AWS VPC that they provide as a networking mode, whereas with EC2 you have multiple network modes that are available for you. But right now we'll just go for Fargate itself. So let me just select that and we'll click on next step. So over here we're gonna enter our name. That will be HTML web task. Actually, just remove that HTML because we already named a lot of things with HTML, so we don't want to confuse ourselves. So it will just be task for us. And then we'll come down and we'll assign the task role. That is, we'll choose ECS task execution. This is the optional IAM role that task used to make API requests to authorize AWS services. So if you want to access any of the other services you want to make sure that, you you have an ECS role that allows you to access all of the other services also with ECS. So we already have a role for this, that is ECS task execution role that we're going to be using. Then you can't change the AWS VPC network mode because the default one, ECS will start your container using Docker's default networking mode, which is bridge on Linux and NAT on Windows. All right, so task execution role, we'll just leave it the same. So this is basically the role required by task to pull container images and publish container logs to Amazon CloudWatch. So task size, we're gonna make it 0.5 GB, and task CPU will make it 0.1 2V CPU. Okay, 0.25 CPU. So now let's go ahead and add a container. So for that, we'll click on add container, which is our innermost layer. So if we click on add container over here, we'll get a lot of different options to enter in. So if you're here, you can see a lot of details that we can answer or enter, like container name over here. So we'll write an HTML Nginx website. So for the image repository, we'll go ahead and copy that from ECR. That's, this one, image URL, I'll copy it and I will go ahead and paste it over here. Then we'll set the memory limit to 5112 and port mapping will be 80. So here, again, you can see that we have only mentioned the container port because, EC2 instances managed by AWS itself because we're using Fargate launch type. So we only have to mention the container port type. If we had chosen EC2 instance type, then we would have to choose for the EC2 instances also at which port it will be exposed. But right now we'll just use container port, that is 80. And we'll leave all of the other details as it is. We don't need to configure them. Just click on add. And we'll come back and we have service integration, proxy, volumes. And if you guys wanted, you can go ahead and configure all of these details using, JSON. You don't have to use the UI. You can just go ahead and type in JSON key value pairs. All right. So now we have configured everything. We can just go ahead and click on create. So once you click on create, we'll create all the new tasks for you. So we'll just view task definition over here. All right. So this is the task for us that we created. Now what we're going to do is we're going to go ahead and create our own clusters. And inside of this cluster, we're going to launch our own service that will, be based on the task definition we just created. So you guys can see there are a lot of cluster templates there. The one that we chose, that was the default one we had chosen earlier. That was created by default. Now here we have a lot of options like EC2 Linux plus networking. We have cluster, VPC subnets, and auto scaling group with Linux AMI. And then you have EC2 Windows plus networking, but we're going to choose EC2 Linux plus networking. Then we're going to click on next step. Now we're going to give this a cluster name. This can be cluster cloud. All right. So we're going to come down. We're going to choose a provisioning model. So we have on demand, which is basically which you pay for the compute capacity by the hour with no long-term commitments or upfront payments. So basically is for how much you use, you pay for it. But on Spot lets you take advantage of unused EC2 capacity in AWS cloud, and Spot instances are available at 90% discount compared to on-demand service prices. So what we don't need on-demand, so we can just select a Spot. If we choose on-demand, we can see we have a lot of different configurations that we can put it, but we can just choose Spot and we can select lowest price and we're going to select the EC2 instance type. We're going to make this T2.micro. But it seems we don't have T2.micro. Let me just check this. All right, so let me just try something. Diversified. All right, so what we're going to do is we're going to choose T2.small since that's all that's available to us over here. So we're going to select T2.small and then we're going to scroll down. Then we have the number of instances that we can choose. So here we're going to select number of instances as 3. So we're going to have 3 machines that are going to be using EC2 EMI, that is the Amazon Linux that that they have provided. And we're going to leave the everything else as normal. Now we don't need to create a new VPC. We'll just use the one that is by default there. So by in subnets, we will choose 2B and we will be choosing 2A. So these are the two subnets we will choose. Use subnetting, no. So here security group, we can just choose the default security group that is available to us. So the EC2S instance role will remain the same. And we'll go ahead and click on create. So this will start creating a new cluster. Okay, now our cluster is created. We can go ahead and click on view cluster. All right. So our first step is here going to be creating a new service because this is a completely new cluster. So we have defined the basically what kind of cluster is going to be, what kind of instances we're going to use. Let's go ahead and create the service. That means the number of tasks, the number of replicas we'll need for a particular task. So I've created, clicked on create over here. All right, so we're going to choose Fargate. So we're going to use task for us, platform latest, cluster clown. We're going to name the service our service. So service type is going to be replica. We want 3 replicas of our service. Rolling updates, yes, we want a deployment option for the service as rolling update. We can go ahead and click on next step now. All right, so cluster VPC, subnets to B and to A. All right. We can choose a application load balancer, but it will not automatically create that for us. We will have to create our own load balancer if we want this. So for right now, I'm going to click on none, because we won't use a load balancer, but it makes sense to use a load balancer. So actually, let's show you guys how to create a load balancer. So I'm going to click on application load balancer over here. So we'll go and create. To create it, we have to go to the EC2 console. So I'll open it up over here. I have an option. And once I open it up, I'll go to the left hand side. There are many options. We need to check our load balancers over here. So let me scroll down and I'll click on load balancers. Now we want an application load balancer. So I'm going to click on application load balancer. This for HTTP and HTTPS. All right, so let me start filling these details. So let me name this our load balancer. We're gonna leave this as internet facing. IPv4, we're gonna leave it as IPv4. And load balancer protocol, load balancer port, we're gonna leave that the same. Now let's scroll down. We want to choose the availability zone over here. So in the availability zone, we have a HTML Nginx web cluster. That is for the previous one. I'm going to click on the default VPC and we're going to choose 2A and 2B over here. All right. So these are the availability zone. So they're going to route the traffic to these availability zones. Now let's scroll down again. We can leave this as it is. We're going to go ahead and configure security groups. So configure security groups. We're going to select an existing one. Actually, we're going to choose the default one. Then we're going to configure routing over here. And in configuring routing, we have to choose. We have to give this a name. So new target one. Target type is going to be instance itself. This is going to be HTTP and this is going to be AT. Now we're going to click on register target. So we can review all of our details. And we're going to click on review and then create. All right. So we have created our load balancer over here. Let me close this. load balancer. This was created by default, if you guys remember. I'll click on listeners over here. And here in listeners, make sure you have this listener ID. Okay, so once you made sure, you'll go back and in load balancer name, you should see this option. If not, just click on refresh and you should see the load balancer you had just created. So once you see the load balancer over here, come down to container to load balance. Then just click over here, add to load balancer. Over here, we're gonna type in 80. And once we are done, we can move down and click on next step. So if you want, we can configure auto scaling. So it will adjust our service desired count up and down, within a specified range in response to CloudWatch alarms. So we don't have to go in such detail. So we can just click on do not adjust services desired count, then click on next step. You can review your services configurations, then click on create service and we'll start creating a service. All right, now it's created. We can go ahead and view our service. Also, if you're not able to basically, add the load balancer to the container, what you can do is go to the load balancer in the one that we created in the load balancer dashboard and go to listeners and remove the http:/80 over here. Then refresh your page and then add container to load balancer. So let me just wait for this to refresh and I'll show you guys how that works out. So this is the one that we created. Click on it, go to listeners and just remove this. Not after you've done it, not after you created the service, but before you created the service. When you're loading your load balancer, when you're configuring your load balancer and you have to add the container, right? When you have to add the container to the load balancer, at that time, come back over here, remove this http:/80 and then refresh the page and then, add the 80 that the process we went through. And once you've done that, you will come over here. So we can see that these are the different tasks. We have 3 of them. The last status is provisioning right now. Desired status is running. So let's just wait. Let's refresh a little bit. All right, so we have the status of them, all of them running. All right, so what we can do is we can come back over here and go to description and copy the DNS of our load balancer and then go ahead and paste it. And voila, we have our simple website now running. So guys, this is how you would deploy it manually. And we can see that there are 3 tasks running. That means, we have 3 replicas of each of our tasks. Alright guys, I hope you guys understood what was taught. And one more thing before we end, if you guys want to update any of your images, any of your services, any tasks, you would first go ahead and update your task definition, in which you would update your container image. Then you would, basically use the revision of the new task definition in your service when you update your service over here. And then, you would force a redeployment and then you wait for it and then it'll start redeploying. Okay. AWS ECR. So guys, we are now going to go ahead and learn how to utilize our Docker tool and make use of it with AWS services such as AWS ECR and AWS ECS. Now, we will be using these 2 similar technologies to basically orchestrate and store our Docker images on the AWS cloud platform. Because whenever you're working with software, right, it's much easier to work with the cloud platform because, they provide all of the infrastructure and you just have to manage the services instead of managing the server. And that's where a lot of companies these days have migrated on to these different cloud providers like AWS, Azure, and Google Cloud. And they made use of the services that these cloud providers have given to implement all of the things that they want to basically deploy the software. So when it comes to deploying software using Docker technology, you have 2 similar services on AWS cloud. You have AWS ECR and AWS ECS. So let's study these 2 and then let's see how we can go ahead and implement the our software using these 2 services. So we'll start off by discussing AWS ECR. So AWS ECR, or Elastic Container Registry is an AWS service, that is Amazon Web Services service, that acts as a dedicated location for storing Docker images. So you guys know what Docker images are, and those images have to be shared among team members, or if you want to collaborate with other teams or even other people, you use Docker registries for that purpose. For example, we pulled and pushed images from and to Docker Hub. Now, Docker Hub is the official Docker registry that Docker itself hosts. So it has its own cloud where it hosts its own registry, and it's the one that we make use of. Now, it's very easy to use because it's Docker's own thing. Whereas AWS ECR, or Elastic Container Registry, is AWS's service. So if you wanted to upload an image onto AWS's service registry, then you would use ECR. Now, and big advantage of using AWS ECR is that it's very well implemented with a lot of services within AWS like ECS and EKS. So instead of authorizing your Docker Hub to be able to pull images from your Docker Hub onto your services such as ECS and EKS, you just use Amazon's own registry. And if your company or organization makes use of a lot of Amazon services, then it makes sense to go ahead and use their registry. Now, once a Docker client has been authorized, it can pull and push to and from the ECR registry. Now, normally when we pull and push images with Docker, we don't have to authorize anything. It's already done by itself, especially for Docker Hub, because it's Docker's own thing. Whereas with ECR, we have to authorize the Docker client because AWS is a separate service. And to make sure that you can pull and push images from the ECR registry, you have to make sure that the AWS cloud recognizes the Docker client you're using on your system as a proper system, proper client. So it has to authorize it, not someone random. So that's why you need to authorize the Docker client with which you'll be pushing and pulling the images. Now, it is useful in a scenario when you don't want to manage a dedicated storage for images and want to use other AWS services that make use of it. So if your organization is hosting its own, a server where it has a Docker registry where you're storing images over there, so that's a lot of hassle because you have to maintain the server, you have to upkeep it, you have to make sure it's available at all times. This basically eats up a lot of resources. Now, AWS provides servers on a very large scale, so they're able to do it for cheaper for us. So that's why, it's more fiscally responsible or, fiscally feasible to use ECR instead of keeping your own server. And again, if you have a lot of AWS services that you're already making use of, then there is no harm in using their own registry because, then you don't have to manage any extra secrets that have, your username and password. There's always, another layer being added over here if you're using third-party registries for AWS services. So that's why a lot of people use AWS ECR. So again, AWS ECR or the Elastic Container Registry is a dedicated location for storing Docker images. Just like your Docker Hub, it can, store different versions of the image. You can store different images, and anyone who has access to the ECR, the specific repository, then they can access all of the images on that specific repository. So it's a good way to share your image with other people as well as, other team members. All right. Now let's talk about AWS ECS. Now, AWS ECS is another major AWS service that we utilize for orchestration purposes. So ECS or Elastic Container Service is an AWS service that allows us to orchestrate our software deployment. So just like our Docker Swarm that helped us to orchestrate multiple containers on a local server, ECS, helps us to orchestrate a bunch of multiple containers on the AWS cloud. Now, you could do it manually also. You could go ahead and launch multiple EC2 instances by yourself, and then, you can go ahead and launch multiple containers on those multiple EC2 services. But then it takes a lot of effort to set up the whole thing. Now, AWS is going to be doing the same thing with ECS, where the difference is that it basically automates everything. It's already in place. It just asks you for specific definitions so that your cluster is formed, so that your EC2 instances are formed, so that your particular service is formed, your containers deployed, etc., etc. So it you basically already creates the service, so we don't have to do anything manually, and that's why ECS is such an amazing orchestration tool. And it's again on cloud, so there is the advantage over there also. It acts like any other orchestration tool like Kubernetes or Docker Swarm. It allows you to deploy, update, rollback, scale up a software development, based on our requirements. You can deploy your software based on specific images of, containers you have. You can update them. You can, perform rollbacks. If you don't like the new updates, then you can scale up your software based on, what kind of requirements there are, etc., etc. So ECS is basically like Docker Swarm, but on cloud. Now, when you go ahead and, you create your ECS platform where you use the service, there are 4 things to keep in mind. So there are 4 layers of definition that you have to create within ECS. First, you have the container definition, in which you inform ECS what is going to be the image, where you can, provide your own custom image, or, you can use some sample image that there is on ECS. Is basically giving what kind of image will be used to create the container in the container definition layer. Then you have the task definition layer. So task definition layer basically informs ECS how much resources or how many resources will your containers will be making use of. And then we have service definition, which basically tells ECS what kind of load balancing is going to be happening, and if there's going to be load balancing at all, and how many number of tasks are going to be there. So, are you going to have multiple tasks? Are you going to have only one task? Or are you going to have more, how many replicas of the specific task are you going to have? So that is again defined in service definition. And then you have cluster definition, which basically tells you how the cluster is going to be. So like how we had Docker Swarm, which was a cluster on a local server, cluster definition will help you, create the platform or the infrastructure over which all of your EC2 instances will run, and through which you will be able to manage the whole thing. So these are the 4 different layers of definition you have to create when you're talking about Amazon's AWS ECS. Now there are 2 types of launch type when you have to consider ECS. So let's see how the life cycle works when you're working with ECS. So you take ECR. ECR is the container registry. So you basically create your image, you push it to ECR. ECR basically stores the image. And then you go to ECS, you start defining all the layers, and in your container definition layer, it will ask you for the repository of the image it has to reference. So you will reference the ECR image that you have uploaded to ECR. And once you've defined all of the image container definition, you go with task definition. There you have to choose what kind of launch type are you going to be using. Are you going to make use of a Fargate type of launch instance or EC2? So the difference between Fargate and EC2 over here is that Fargate is completely managed by AWS, whereas if you're choosing EC2, you are saying that you want to manage some aspects of the EC2 instances or the virtual machines that are going to be launched. So let's say you want to SSH into these EC2 instances to add few more configurations that you might want to add. So you can, if you want that kind of option, then you will go ahead and choose EC2 launch type. If you don't want that kind of option, where you just want, to manage Fargate by itself, then you would, if you just want to manage how the orchestration is going to be and not worry about any kind of infrastructure, even the virtual machine, then you go ahead and make use of Fargate. And once your EC2 instances or your instances at all have been launched, they all will be connected by a load balancer, which will direct you to your app or your website. So this is the life cycle of how you would go ahead and deploy any software on ECS. Introduction to Jenkins. So guys, now we will go ahead and learn about Jenkins, which is a continuous integration tool, and it forms an integral part of DevOps, that is the continuous integration phase. All right, so let's go ahead and go through all of these topics, like why continuous integration, what is Jenkins features, Jenkins architecture, Jenkins installation and setup, and setting up a CI/CD pipeline, and many more. So first, let's start off by discussing why continuous integration at all. To understand this, let's look at this standard delivery pipeline. We have a lot of developers writing pieces of codes, and these codes go ahead and get stored in source code managers, which then go ahead for testing, and once they're approved, they go ahead for deployment. So there are a lot of different intricate moving parts of a software development process. You have many phases in which you build a software, and you have many different methodologies in which you utilize to build software. There's so many different things when you have to take in consideration when you're actually building software. And all of those different parts, the most optimized of them, when they are connected together, you greatly improve the efficiency as well as the productivity of a software development pipeline. And we make use of continuous integration for that purpose. Now, DevOps has many phases like continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring. All of these different phases have different technologies being used in them, and different methodologies being used in them, and different automation parts being used in them. So the continuation integration phase basically tries to connect all of these different parts together. It connects them together so that we can easily manage all of those processes. What is our end goal over here in software development? It is to make the best software that is possible, and to make it as fast as possible, because we have a very hungry market and we need to provide them with products or services as much as possible, so we can generate higher and higher revenue. To do this kind of thing, we need the most efficient way to develop software. And to create the most efficient way of developing software, we come up with this idea of continuous integration, where we integrate all the different parts of software development, be it the development itself, be it the source code management, be it the building process, be it the testing process, be it the load balancing process, be it the staging process, or be it the deployment process, or even be it the monitoring process. All of them different parts of software development are connected together using continuous integration tools, and that's why we make use of continuous integration itself. All right. So continuous integration is something that Jenkins does. So let's go ahead and directly discuss what is Jenkins and why is it so popular? Why do so many people even talk about Jenkins in DevOps? So Jenkins is an open source continuous integration tool written in Java that allows us to automate software development process, making sure that there is minimum involvement from us, and it also integrates all the different parts of development. So let's say we have a lot of different tools being used. The developers make use of a source code management tool such as GitHub, and they make use of containerization and orchestration tools like Docker and Kubernetes respectively, and they make use of monitoring tools like ELK and Prometheus and Grafana. They make use of configuration tools like Puppet and Ansible to write configuration scripts that have to be passed on several servers. And they make use of cloud services like AWS and Azure. And they make use of build tools like Maven, MS Build, Gradle, etc. And they make use of artifact repositories like JFrog Artifactory or Sonatype Nexus. So you have so many different tools participating in this process of software development and contributing their own specific parts. And Jenkins basically helps us to integrate all of them. Now, Jenkins is an open source tool, which means that it's available to everyone as a completely free software. Now, it is a very, very, very popular tool that a lot of different people use. Now, even if you're not implementing the whole DevOps ideology, taking in the principles and values also, and just thinking about the tools, even then a lot of different companies make use of Jenkins, even if they're not making use of DevOps ideology, because it's such an amazing tool that it gives you such flexibility and such adaptability. If you want your company to grow, or if you predict that there is going to be a good growth rate in your expanding company, then it helps you to have Jenkins implemented as the managing software, although overall boss of everything, because you can easily scale up your production value, or you can easily scale up your servers, and easily scale up your whole operation and services that you're making use of, make by implementing Jenkins itself. Now Jenkins is written in Java, so you need to have Java when you're working with Jenkins. Also, you have other tools that compete against Jenkins. You have tools like TeamCity, you have Bamboo, and you have Circle CI, you have GitLab, but most of these are paid softwares. The differences are pretty apparent when you look at them, when you compare them side by side. Now Jenkins has a big advantage over all of the other paid softwares, where Jenkins is completely free. That's one advantage. And another thing about Jenkins is, since it's an open source tool, a lot of people contribute to this tool. And since a lot of people contribute to this tool, we have a very big community where you can search for answers, contribute new things. And that's why it's a very large community where a lot of people discuss a lot of different things. And this way you have a lot of support from a group of people without having to pay for anything. That's why many startups that don't have any resources to get all these expensive tools make use of Jenkins. Now Jenkins is not necessarily very appealing to look at or very appealing to use. It's not that intuitive, but it is the developers or the god hand, where you can use it, you can configure it as much as you want, and make use of it so that it benefits you personally. It has supportability for such a wide range of plugins. Then even if you make use of the most obscure tools that no one has heard of, there is a high chance that Jenkins has supportability for those plugins versus any other continuous integration tool. Let's take example of TeamCity and Bamboo. These tools have around support for like 1,000 plugins or even lesser. Even like 600 and all. It's very less compared to Jenkins. The thing is that they are specifically designed for certain purposes. Let's say TeamCity. TeamCity has supportability for certain plugins that a lot of people use commonly, and it has a very good connection to those tools. It has very good interoperability between those tools because it's been specifically designed by companies that have funding behind them, whereas Jenkins is something that a lot of people contribute to openly. And because of this reason, Jenkins may not have such robust plugins, but it has a set of thousands of options to choose from, and that's one of the things that makes Jenkins so great. So here is a standard pipeline, but instead of just having the standard pipeline, you're introducing Jenkins as a concept over here, where the developers write their code and they push it to a source code manager. And once it's been stored in source code manager, Jenkins automatically detects any new pushes to the certain repository if it has been configured so inside of Jenkins. And once it scans those repositories, and once it detects a new change has happened, a build is triggered usually, if it is configured so by the DevOps engineer. And once the build is triggered, all the processes start happening. The whole phases of DevOps start happening. All the software development start happening, where the code is then gone ahead to the testing environment so that the tester can run various test scripts. Before that, it is built, and the build artifact is stored on a artifact repository, and from there it goes for testing. And once it's been tested, if there are any issues, then the notification automatically goes to the developers, where the developers know what's going on, what's wrong. And then it goes to the staging environment, and from there, when the release cycle starts, the particular code is then shifted onto deployment. And this is all part of the Jenkins build that we can specify, where we tell it where to, scan the which repository, where we tell it to use this particular build tool to build the exact code into an artifact, and where we tell it to store this artifact in an artifact repository. And then, we ask it to trigger another job where the artifact then is pulled onto a testing environment where all the test scripts are run, the whole test coverage happens. And then, if there are any issues, then the developers are informed. And then, it basically contains the knowledge of how to deploy. Once it's certain that the code is fine to run, it will put it on the staging environment. And during a release schedule, it will go ahead and deploy that code. And once it's deployed, even after the deployment process, there is monitoring aspect that can also be controlled by Jenkins. So you can see how useful it is when you're talking about the whole software development pipeline over here. So Jenkins history. So Jenkins was originally developed in 2004 by Sun Microsystems company under the name Hudson. It had slowly gained popularity and had become one of the best developing tools out there. The project was later named Jenkins when Oracle bought Microsystems and decided to keep Hudson and Jenkins as separate entities. So what they decided to do was, when they bought Sun Microsystems, they basically, divided the concept of Hudson and Jenkins. So it's like what happened with the RHEL and CentOS. So CentOS is the open source version and RHEL is the enterprise version. Similarly, Hudson is the one, that they aim to use it for enterprise purposes, and Jenkins for, a community purposes. But the thing what happened was that if you look at the diagram of how both of these tools evolved side by side, you will notice a trend where Jenkins became much more popular compared to Hudson. Now, if you see the supportability of any number of plugins, you would see Jenkins is much better at it and has a larger community support than Hudson. So this is because Jenkins was just way more popular than Hudson, even though they were similar in the start, but now the whole case is different. Now it is one of the most popular CI/CD tools out there. A lot of different companies make use of it. Name a company and they probably use it. Google, Netflix, Facebook, all of these big enterprises like Amazon, every company makes use of Jenkins one way or the other. Now, if you throw a name out in the air, and if it's a software technology company, then they definitely make use of Jenkins as a CI/CD tool. If they don't make use of that, and then they make use of other CI/CD tools like TeamCity and Bamboo. But Jenkins is definitely something that a lot of people use to make sure that their software development process is as automated and as efficient as possible. So benefits of Jenkins. So Jenkins is a community tool. It is open source and has a very large community that contributes to it very regularly. So if you open up the Jenkins community, you will see people regularly posting new things and adding more to the supportability of Jenkins. If there is a new tool out there, then you'll be sure that the new tool gets supportability with Jenkins within a few months or so. It is free, so you don't have to accrue any more subscription costs. This is especially true for all those hobbyists and all those amateur developers and all those startups that can't afford to pay for those expensive continuous integration, continuous development tools out there. They don't cost less, like they don't cost something that one person can individually afford, or even smaller companies of 5 to 10 workers can afford. So in that case, they make use of Jenkins, which is open source and it's completely free. So this way they reduce the amount of money they're spending, and also increasing the efficiency as well as productivity of their software pipeline. So this is a win-win scenario. That's why Jenkins is so popular. It is highly modifiable, adaptable, and has support for very large number of plugins. So it has like more than 1,000 plugins that you can use for it. You have so many different options for so many different purposes. Then it can run on any major platform without any compatibility issues. So that's how it's been developed. It's been developed with the mindset that you can make use of Jenkins in different kinds of environments, be it Linux, Windows, or Mac. So these are the different benefits of Jenkins, and these benefits are very loud compared to its competitors, and people generally prefer Jenkins because of these benefits. All right, so I hope you guys understood what Jenkins is. Now let's look at the Jenkins pipeline, like a proper pipeline, how it would be. You have a developer who writes the code gets stored in some kind of source code manager that can be Git. And this source code manager, is web hooked onto Jenkins, where Jenkins can automatically detect if there are any new changes or if there have been any new pull requests made where new code has been added to the master code. And once it detects certain changes based on triggers that have been scheduled onto it, or configured onto it, it will perform tasks based on those conditions that have been configured to it. So if, let's say, that it detects a new pull request happening, it will automatically scan through that repository and it will replicate that repository very quickly, either on its main agent or any other agent that is idle. And in that agent, then the build process will start happening. Now this will be part of a build job, so you can create multiple build jobs in Jenkins that allow you to basically specifically run different types of jobs. So one of these jobs can be building. So you basically take your code, all of its dependencies, these dependencies can be its libraries or functionalities, and all of it's taken together and made into a single executable unit. So with Windows, you have a lot of applications that have .exe in the end. Similarly, you have a lot of software that are basically executables. In the end, you want an application to run, so you create an executable of it. Once you create an executable of it, it either can be stored in an artifact repository where it can be pulled on or stored for posterity purposes. And once it's stored there, it will go ahead for testing, where the testing scripts will run on it, and then it can go to staging, and from there it will go to production. Now if there are any issues, then feedback will be given to the developers and people will know about it. Now you can even attach tools like email notifiers or Slacks to Jenkins to notify people who are responsible for handling this whole pipeline if there are any issues that happen. So let's say something goes wrong between the process of testing and staging, and we didn't know about that. So there's a chokehold that has been formed in the pipeline. To be informed about such, Jenkins sends an email to the people who are responsible. Can be the system administrator, can be the team lead developer, and can be the DevOps engineer, and they will come back and try to rectify it, write some automation scripts or write some bypass scripts that will allow us to come around that problem. And you can even use static testing tools throughout the whole process where the developers are writing. So this is part of the continuous development that is connected to Jenkins. We're using tools like SonarQube that basically make sure that the developers write the code of the code that is of the best possible quality possible. They make sure that there are no code smells, there are no security vulnerabilities, that the best practice standards of a particular languages are being followed, of a particular project are being followed, etc., etc. So this is how a Jenkins pipeline acts. All right, so let's talk about a Jenkins case study. Now, if you don't know what T-Mobile is a very, very large enterprise. So this large enterprise is basically a service provider. They provide different services like internet and telephone. Now they have a very large, international presence, and they're very big in America or United States of America. They have many different products. We can talk about, not just telephone services and not just internet services. They have like TV services, they have banking services, and they have road services also. They have, it's a very big enterprise with a lot of different ventures that they expand into. Now, the thing about them that we want to concentrate over here is that, technology wise, T-Mobile tries to say that they're way ahead their competitors, because they try to implement the best and the newest technologies as much as possible. They say that they have thousands and thousands of repositories on GitHub available, that they keep on contributing over there. And they have a very an example of it is like something called a pipeline framework automation library. It basically helps support all of their customers by using very strong and intelligent practices of software development lifecycle. Now, the thing about them is that they made use of Jenkins in a very, very intelligent way. They built a very optimized software development pipeline, which was basically centrally managed. Now, the great thing about it was that it was easily adaptable to the different techniques and different methodologies that they try to implement. And this gave a lot of free space for the developers to work on what they're solely supposed to do. They developed code. They didn't have to sit down and try to maintain any of the Jenkins environment itself. Now, they also went ahead and optimized how they were making use of the different plugins. Now, Jenkins you can use many different plugins, right? But then there is a certain limit where once you start using way too many plugins, you might be conflicting, you might have conflicting compatibilities between these kind of plugins. So they try to reduce the number of plugins they had, from around 200 plugins to they shifted to just 4 plugins. They use those add-ons a lot, but they try to reduce them because having so many add-ons or plugins would cause a lot of conflicts, and they didn't want that. They wanted an as much as a optimized pipeline as possible. They even basically shifted from model of having a single master Jenkins to having multiple Jenkins master. And in their company they have around like 50 to they have 30 very, very well optimized pipeline engines between tens of teams, development teams out there. And this has basically improved their overall development process and reduce the amount of resources that they were making use of, such as CPU usage. This has saved them a lot of time and a lot of money in development of software. And this is directly benefited them because they're increasing through their horizontal scaling of the operations they have instead of just vertical scaling. So you can see that it's benefited T-Mobile in a very good way, and people who use Jenkins hope to achieve the same. All right, so we have understood a lot of different things about Jenkins. I also want to talk about some other features, like how it is very easy to use. Like once you get through the learning curve of it, you can easily use it. And it has a very, very, very fast speed, software development process. You can deploy in a matter of seconds, and it has a very high quality documentation, and that's a very significant thing in open source tools, because having a good documentation basically allows you to implement the tool in a much better way than you could before you had a documentation. And you have a lot of support because it's an open source and widely used tool. And if you have any issues, then you can resolve them right away by making use of Jenkins, because you get alerted very quickly about those issues that might happen in the pipeline, and you can basically resolve them very quickly. And almost everything that you do in Jenkins, that is your continuous integration and deployment, all of it is automated. Once you configure it according to your requirements, it just keeps on happening. With smaller changes here and there you would have to make over time based on the feedback you get from the team itself, and of what kind of issues that you detect from itself. So in general, Jenkins is a continuous integration and continuous deployment tool that connects all the different parts of software development and helps us to save both time as well as money, and improves and increases the lifespan of any software. So now let's go ahead and learn how we can install Jenkins and set it up. So let me bring up my terminal. Okay, here we have our terminal. I'm going to do the first thing that we always need to do, that is update our terminal. Now I don't need to type in sudo because I already have root access, but this is for all of you guys who forget to add sudo all the time. Okay, so we'll update our instance. We have to update our instance. Now let's look at the different set of commands we need to install Jenkins. So these are the different commands. First, we need to install Java OpenJDK in our system, because Jenkins is written in Java, so it needs OpenJDK to run. Then we will go ahead and get the key for getting the Jenkins repository, to getting access to Jenkins repository. Then we'll update our instance, and then we'll install Jenkins again. So this process is kind of similar to how Docker's installed, where you get the key, you get the repository, then you update the repository on your system, and you install the tool. Except installing Java over here also. So let's go ahead and install Java. So sudo apt install open JDK 8 and JDK. Yes. Okay, so we've installed Java. Now to check what version, we can just type in Java -- version. Okay, let's just have one hyphen. Okay, let me just show you. I just added one extra hyphen, that's why I gave us the error. So you can see the OpenJDK version 1.8.0. Alright, so the OpenJDK runtime environment and OpenJDK 64-bit server virtual machine. Alright, so we have the adequate prerequisite tools, that is Java. Now we will go ahead and get the key for installing Jenkins. So this is the command for it: wget -q-o -https package.jenkins.io debian stable jenkins.io.key grep sudo apt key add hyphen. So we got the key now. Now let me go ahead and get Jenkins itself. So this is the repository. All right. Okay, so now let's go ahead and update apt update, and then we're gonna go ahead and install Jenkins. We'll apt get update actually. Let's go ahead and apt get update. And then apt get Jenkins. Now we're going to go ahead and add the repository. Let me press enter. So this is the command for that: sudo sh-c echo deb https package.jenkins.io /debian stable binary /etc/apt sources list.d jenkins.list. Okay, so this is the long-term support version. You can go ahead and get the latest version also, but it might not be as stable as the long-term support version. And most people use the long-term support version because they're the most stable ones, and organizations tend to use stable tools. All right, so now that we have done this, we can go ahead and update our instance once more. All right, so we should be seeing this as part of the repositories. All right, so we have the key and we have the repository. Now we can go ahead and install Jenkins without any hitches. So yes, I want to install Jenkins. Do I want to continue? Yes, please continue. All right, now we have successfully installed Jenkins on our system. So that was the process. All we had to do was update the instance, then install OpenJDK 8, and then check its version, then move ahead and get the key for Jenkins, and then get the stable repository for the long-term support version, and then update the instance once more, and then install Jenkins properly. So those are the different steps. All right, and keep in mind when you're updating, use the apt update and not apt get update. All right, now to access Jenkins, just head to your browser, copy the IP address of the instance you are in, type in the IP address, then go to 8080. Once you do this, it will start the installation process or the setup process for Jenkins. So as you can see, it's telling me to ensure Jenkins is securely set up by administrator, a password has been written to the log. Find this and this file on the server. So we have to head to this location. So it's basically the initial admin password, and we have to go ahead and copy and paste this. So cd. Let me copy this. All right, if I do an ls, I see the initial admin password. I'll just cat it. So this is the initial admin password. Let me copy this. We'll paste it over here, then click on continue. So once you've done that, just click on install suggested plugins. And we'll start installing all the default plugins that you will need to work with Jenkins. Now, if you've done it successfully, these should be installed without any problem. So we'll just wait for it to finish the process, and then we'll set up our admin password and we will log in into Jenkins. All right, so with that process done, we can go ahead and give it the username. I'm going to give it the username admin, and I'm going to give it a password, but I'm not going to tell you guys. Actually, it's just admin123, and we can give the full name. Let's just give this Remy, and this can be johnbowie1990@gmail.com, and let's save and continue. If you don't want to do this, you can skip and continue as admin, so that's a good option, but we'll save and continue this. You can go ahead and change the username later. All right, so this is our Jenkins URL. So just basically go to this place. The URL is provided to the Jenkins URL is used to provide the root URL for absolute links to various Jenkins resources. That means that value is required for proper operation of many Jenkins features, including email, notifications, and etc. So let's go ahead and click on save and finish to complete the setup process. And you can see that it tells us that Jenkins is now ready. So our Jenkins is completely set up. So we can click on start using Jenkins to view the dashboard quickly. All right, guys. So this is our dashboard. You can see there are a lot of different options over here. Let me just go through them one by one. So we have Jenkins. This is, if you click on it, you go to the home page, and this is to create a new item. If you want to configure authorization for different people, and build history if you want to manage Jenkins settings, views, lockable resources, new view, the build queue. If you have any build jobs that are queued, you will see them over here. Then the build executor status, what's happened to the builds, and welcome to Jenkins. So this is the main dashboard. You can create an agent and configure a cloud, or you can create a job to start building a software project. All right. So there are a lot of different options over here. What we want to do is we want to set up a Jenkins master slave architecture. Now you ask, what is the master slave architecture of Jenkins? So let me explain that to you. So now that we've finished installation and setup, let's talk about the Jenkins architecture. So in the Jenkins architecture, you can see that the source code manager connects to the Jenkins master node, and that Jenkins master node is connected to a Jenkins slave node and another Jenkins slave node. So what is happening here is basically whenever a specific task is given to the master, it's requested to the master will divide that task based on resources available onto its slave nodes. So why do we have slave nodes over here? So let's take an example of a very big company. There's an organization with thousands of employees, and there are tens of developer teams or hundreds of developer teams, and each of them needs to make use of Jenkins. So will them all make use of Jenkins is in this single server? Well, that's not possible. You might have one master Jenkins, or you might have multiple master Jenkins, like with T-Mobile. And those multiple master Jenkins will be connected to their own slave nodes. So what happens is, like, a set of teams, maybe two teams will use one Jenkins master, a set of another two teams uses another set of Jenkins master, and maybe 5 teams use one Jenkins master, and their task gets divided into multiple Jenkins slave nodes. So basically what happens is, when build job requests come to Jenkins master, it has the ability or the option to divide that task to its slaves. So they are just agents. So when we talk about over here creating an agent, we talk about basically the slave node. So you can go ahead and create an agent or create multiple agents and connect them to the master, so that when you want to execute a specific build job, you can specify to to make sure that it gets executed in an agent or in the main master itself. Okay, this is the Jenkins architecture. All right, so now let's go ahead and add our own agents for this. For this purpose, what I'm going to do is I'm going to go ahead and launch 2 more instances over here. Alright, so I'm gonna go ahead and launch Ubuntu instances, 2 more Ubuntu instances, because I want to launch 2 slaves on those 2 Ubuntu instances. I'll change number of instances to 2, add storage, add tags, security groups. We'll use an existing one that has all traffic and all, any source enabled. Then we can launch it, launch instances. Now we will wait for this to get launched. While this is getting launched, we can come back over here, click on Manage Jenkins. And when we click on Manage Jenkins, we're going to go ahead and configure our global security settings. So for that, we're going to click on Configure Global Security. This is to define who is allowed to access and use the system. We're going to look for the agents option over here. So under agents, we need to, okay, so enable agent master access. All right, so we'll leave this be. Come back to Jenkins. And we'll head to, again, manage Jenkins. We need to head to manage nodes, and once we manage nodes, this is to basically add new nodes. We're gonna basically click on new node over here. I'm gonna say agent 1 as the node name, and I want it as a permanent agent. Then I'm gonna click on OK. All right, so this is my slave 1 or agent 1. So we're going to give it the remote root directory. Over here, I'm going to mention it as home/Ubuntu and again Jenkins. Now let me go ahead and copy these and paste it in the custom work directory path also. Now once you click on save, you get agent 1. So let me do this for agent 2 also. Now I'm going to mention agent 2 over here, and I'm just going to click on copy from existing, and I'll ask you to copy it from agent 1. So it's capitalized agent. Click on OK. Yeah. 2. Okay. Then I'm going to click on save. So it's asking us to go to global security configurations. So let's just go there again. We have to make one small change that we had missed out earlier. Let's let it load first. Let's just keep scrolling down. And when you see agents over here, right, you should see the TCP port for inbound agents. It has to be random. If you want to make it fixed, you can do it, but just keep it as random. Then click apply and then save. Once you save this, you can go back to manage nodes and clouds. And you will have agent 1 and agent 2. So now that you have agent 1 and agent 2 configured as nodes, you just have to go ahead and add your agent 1 and agent 2 as nodes. Now to do this, we need to basically run this command on our instance. We have our 2 instances over here, but we don't have these files on them. So to get these files on them, let me just go ahead and copy this command. And what we will do is we will download the agent.jar onto our system. Keep. Okay. So let me open this up. Show in folder. So I have it in my downloads folder. So this is my agent.jar. So I have copied this file. Now all I have to do is I have to transfer this file onto my instances that I have created over here. So let me just name these appropriately. Agent 1, agent 2, and we're gonna name this Jenkins. Master. Okay, so let me take agent 1. Let's copy its IP address and we'll SSH into it. Yes, Ubuntu. Now the only thing we need to do on these agents is we need to just update the instances, and we need to install OpenJDK on them. We don't need to install Jenkins on them. While this is happening, I'm going to go ahead and open my agent 2. Let me load this. So I'm going to update this instance also, and I'm going to install OpenJDK 8 on this also. Alright, so that is done on our agent 1, and that is done on agent 2. Okay, so now that is done on our agent 1, we just need to copy our agent.jar file. So if you come back over here, this is my agent.jar file. Now I need to get one of my keys. So I'm getting my key out over here because I need to transfer this over to my instance, and the key that is used to access this instance is this key. So make sure that you have your .pem file and your agent.jar in the same folder, and if you do, open git bash, and we're gonna type a command that will help us to transfer this file. So let me type in the command. The command is scp -i, then /, then we need to mention the name of the key, live sessions.pem, and then agent.jar, and then space ubuntu at, then the IP address of our agent 1. We'll go ahead and paste this, and then colon, and where we want it to store, home/ubuntu. All right, so let me press enter. Yes. So we'll start transferring the file in a moment, the agent.jar file. Alright, so the agent.jar file has been transferred. So if I do an ls over here, I can see the agent.jar file over here. Alright, so let me go ahead and run that command that we wanted to run. That is this command. Alright, so it is virtually connected. So if I come back over here and back to the list, I can see agent 1 is now connected. So it has this much space, it has this much free swap space and free term space. So it has this much response time. So at least we can see that this agent 1 is now connected. Let's go ahead and connect agent 2 also. So let me download this agent.jar file again. Keep. I'm going to use the same command. All I'm going to do is just all right, then I just need to change the IP address over here. I need to get agent 2's IP address. And we are going to paste this. And then I'm going to press enter. Let's go ahead and just transfer the agent.jar file itself. And yes. So we'll start transferring the agent.jar file. And once it does that, we will copy the command over here. So it's transferred the file. So if we go ahead and open our second instance, and if I do an ls, I can see the agent.jar file over here. I just need to paste in the command, press enter. And this one is also connected. So we have both our agents connected. Now all I have to do is just go back to the list. And I have my agents configured. Now if I want to divide any build jobs between these agents, I can easily do that. You can even see in the build executor status, there's master, there's one idle and there's two idle. One idle is the agent 1 and one idle is the agent 2. All right. So I hope you guys understood how we can create a Jenkins master slave connection or architecture. All right, guys. So we have done all the initial formalities. We have downloaded and installed Jenkins on our system. We had set up the master slave architecture where we have one master and multiple slaves or agents. Now we can start using Jenkins proper. So guys, we have logged into Jenkins and you can see that there are a lot of different options for us over here. So let's familiarize ourselves with all of the different parts of Jenkins. So that's how I'll start off. So first we have the new item. So if I click on new item over here, let me open it up in a new tab. And you guys will see that new item is basically where you create all the objects in Jenkins. So we have multiple different types of projects that we may want to create. And Jenkins gives us the opportunity to do so. So let's discuss them. So let's say we want to create a new project. So to give it a name, we have to give it a name over here. So let's say I want to give this a name, sample web project. So this is going to be the name of my project. And now I can choose what kind of project this is going to be. So one of the most common types is freestyle projects. So the thing with freestyle projects is that, they're very configurable and you can, use them in many different ways. So as it states over here, this is the central feature of Jenkins. You will be using this a lot. So Jenkins will build your project combining any SCM, that is your source code management systems like Git, with any build system like Maven and etc. So those kind of tools. And you can configure this to have something other than software build also. So if you wanted to do some kind of automated process where you're not building your software, you can go ahead and do that in your freestyle project also. Basically gives you a lot of freedom and flexibility in what you want to do with your project. So these can be like independent jobs. You might think of them like that. Then come the pipelines. Now, we've heard about pipelines a lot. When we talk about Jenkins or DevOps especially, pipelines are important over here because that's how we create our software. We create a software through a pipeline. Now, almost all processes have pipeline and software has its own thing too. So if you want to create a pipeline in Jenkins, you need to select the pipeline options. So basically you'll be, orchestrating long running activities. So in a pipeline, you'll definitely have like more than one stage in which you'll have more than one steps. So if you want to configure all of those things, then you would go ahead and select the pipeline option for your project. All right, so this is for for software where you have to perform a lot of multiple actions, like where you have building stage, you have the developing stage, and you have the testing stage, staging and deployment. All of that can be included over here. Then we have the multi-configuration project. So this is suitable for projects that have a large number of different configurations. So when you have a large number of configuration fine tuning that you need to do, and you need to perform tasks such as testing on multiple environments, platform specific builds, etc., that's when you go ahead and choose multi-configuration project. Then there's a folder option. So this basically creates a folder in which you can go ahead and nest all of your different types of projects that you may create. All right, so similar projects might be in similar folders. And then you have more options over here, like GitHub organization. So these are the two same things, where you scan GitHub organization and it will go through all the repositories that are there on your organization's account. And basically you can start using them. And then you have the multi-branch pipeline. So as the name suggests, it basically helps us create multiple branches of multiple branches from a pipeline. So let's say you have multiple projects interacting with each other in different ways, and you want to deploy all of them. Then you will go ahead and use multi-branch pipeline. So as it states over here, it creates a set of pipeline projects according to the detected branch is one SCM repository. So these are all the different options you have to choose when you're creating a new item. So we will learn what happens when we try out freestyle and pipeline. But for now, I just wanted to show you guys all the different types of projects you can create by clicking on new item. So that's what happens when you click on new item. You create new objects. Okay, so now we can look at the other parts. Like we have people over here, build history, manage Jenkins, my views, loggable resources, and new view. So we don't really need to look at these. They won't really be relevant to you guys right now. We'll just look at new item that we already looked. We'll look at people. So people basically tells you, all the known users there are for your system, and allows you to look at what kind of activity they've done. Maybe they've done any commit activity, right? So those kind of details. This is just for a quick look. Now we can close this and we can see the build history. So in the build history, you can see a more detailed build history. And when I talk about build history, what I try to say is basically, all the jobs that you create. So in every item you create, you try to basically create a new job. And when you execute or run those jobs, right, they become builds. So to see what kind of build happened at what time, when, who executed it, you can go ahead and check out the build history over here. Okay, so now let's check out manage Jenkins, which is one of the bigger parts over here, where you can manage the Jenkins completely. Now Jenkins is very flexible, and it has many different parts that you can configure, like system configuration. As the name suggests, you basically configuring all the Jenkins systems details, like general details. You have global tool configuration, basically what kind of tools are being installed. So let's say you installed Maven and Ant, and you want to configure what versions of them have to be used with Jenkins. Let me show you guys. So first I'll show you the configure system. And in configure system, you can see the home directory over here. You can put in the system message, number of executors, what kind of labels being used, usage, SCM checkout retry count, and then Jenkins location if you want to go ahead and change this, system admin email address, and a lot of different other settings. Okay, so this is basically your global settings, where you can go ahead and change any of the global settings you may have for all the Jenkins systems running with this master. And that's your global configurations. Now these are the global tool configurations, basically say what kind of tools are going to be run on what kind, like which system. And basically if you have Java development kit and you want to change the version of the toolkit you're using, then you can go ahead and do that. With Git also similarly, you can go ahead and make similar changes, path to Git executable. Then you have build tools like Gradle and Maven. If you wanted to add Maven, you can go ahead and give it the name, the install location, and the version you want to use. Now there are a lot of different versions that you can use, and a lot of people just go for the default one. All right, and you can save it, and you can start making use of it. All right, so let me close this. Let me show you manage Jenkins again. And we'll talk about manage plugins. So when we talk about manage plugins, again, there are a lot of different options for you. So basically all the different tools that you might be using, right? Other than the common tools, you have a lot of different plugins for those tools. So if you want to install them, then you can go to available, and in available, you can go ahead and type in what kind of tool you want. So let's say you wanted something that is related to Amazon Web Services. So you would go ahead and type in Amazon in the search bar. As you guys can see, as I type Amazon, I start to get a plugin list for a lot of different Amazon Web Services. So first you have the Amazon Web Services SDK, that is the software development kit. Then you have CloudBees, AWS credentials, then EC2, S3 Publisher, ECR, ECS, S3 bucket credentials, Artifact Manager on S3. So you have a lot of different plugins for a lot of different AWS tools that already exist, right? So that's how you can go ahead and get your plugins. Now, if you wanted some other kind of plugins, now it even has Azure plugins. See? So you have a lot of different options, not just your cloud providers. Even if you go for tools, like Git, Maven, you'll find tools for you'll find plugins for things like Mercurial or Kubernetes or even Docker, right? So that's how you manage your plugins. Basically, you download them through the available section. You just click on them and then install without restart, or you want to download now and restart them. Or if you want to check out any of the updates for any of your already existing plugins, you can just go to updates and it will show you what all updates you need. Right now, there are no updates to any of my plugins. Now, if I go to installed, it will show me the list of all my plugins that have already been installed over here. So these are the list of all the plugins that are installed on my system. And there are again advanced options. Okay. So that's your basically manage plugins. Now, manage nodes in clouds is basically how you configure your cloud installation of Jenkins and how you can, add more nodes. That we've already discussed to detail when we were adding our agents 1 and 2, right? So again, you can add new nodes over here. These will be your slaves or agents. You can configure cloud over here. You can check out your node monitoring, see how well your nodes are doing. All right. So now let's move back. Let me show you the rest. So in security, you have configuring global security. Then you have manage credentials where you can configure credentials, and you have configure credential providers. So if you have any other credential providers, you can configure them. And this is the manage users. So here you provide authorization, create and manage user accounts, roles. Okay. So now let's move back, and last but certainly not the least, you have a lot of status information where you want to check out how your Jenkins system itself is doing. You can go ahead and check out load statistics, system logs, system information about Jenkins, what kind of version you're using, what kind of license you're making use of, and if you want to troubleshoot any of the old data, or again, if you want to prepare for a shutdown, reload configurations from disk, use Jenkins CLI, script console, you have options for everything. So guys, this is basically the Jenkins environment. Now you can always click on your username. Basically, this is my admin username. I can quickly check out builds, configure, and my views and credentials from here itself, and I can log out of the system. And if I want to search something, I can always do it over here. So if I type in my agent name, it will show me my agent name itself, right? So that's our Jenkins environment. Okay guys, now let's go ahead and create a job. When you click on create a job, you can, go to the new item screen. And here we're first going to create a freestyle project. All right. So let me go ahead and give this a name. I'm going to give this sample web project. And we're going to select freestyle project because that's what we're going to try first. Then we'll move on to the pipeline project. Okay. So I'm going to go ahead and click on OK over here. Once I've clicked on OK, I get a lot of different options like description, where I can give in my description. This is my sample web project build job. Alright guys, so to make it clear, whenever you create a project using new items, you're basically creating a build job. A job that will be built upon certain conditions that you have set. Now we will go ahead and set these certain conditions. So let's go through these different options and see what happens when we select a few of them. So here I have a discard old builds option. So if you have older projects with, or maybe if you have projects with older builds and you want to discard them, or if this project itself has an older build, you can go ahead and select discard old build. And inside of this option, you will basically get different kinds of configurations, like how many days you want to keep your build or how many number of builds you want to keep at max. So that's discard old build. Then you have GitHub project, in which you can define the project that you're going to be using with your GitHub. So let's go ahead and get our GitHub project. I'm going to go ahead and open up my account over here. And I'm going to select simple web app because this is the one I like to use. So you can see there are 3 files over here: Jenkins file, Docker file, and index.html. I will talk about Jenkins file in a while. First, let me discuss Docker file and index.html. So with this build job, right? So what I will try to do is, let me go ahead and correct the spelling. All right. So what I will try to do is, I will try to launch my index.html in a Docker container. So I will be containerizing an app and I will be launching it using this freestyle job. So this is my index.html. You can see this is like a very simple code. And if we come outside, you can see the Docker file. And the Docker file basically contains all the information required to launch a container or to create an image and to launch a container out of that image. So we'll be using Nginx Alpine image to basically launch our index.html. So you can see the 2 instructions. First is to getting the image, and second is to copying the index.html file into the container. All right. So this is our simple web app. Now let me go ahead and copy the URL of this, and I'm going to paste the URL over here. Okay. So this is our GitHub project. So we have referenced it over here. Now let's look at the other options. This build requires lockable resources. No, we don't want to lock the amount of resources this build is going to use. This project is parameterized. No, it's not. So I'm going to leave this empty. Throttle builds. So when you select throttle builds, you're basically trying to say that, you want this, these many minutes between every build. So if you don't want one build to be executed just after the other one simultaneously, then you can go ahead and set this kind of time period between each builds. Then you have disable this project. If you just want to disable the project, you can go ahead and select this. But if you don't want to delete it, then execute concurrent builds if necessary. If you want to execute builds concurrently, then this is the option for you. And then an option here is restrict where this project can be run. Now we're going to be selecting this because I want to show you guys how you can, divide the builds upon different slaves. So we have agent 1 and agent 2. So let's go ahead and run this on agent 1. So it says no agent cloud matches this label expression, even though we just selected it. That's all right. It's not a big problem. It's counting the space also in the name or the label of the, the image. So we'll just try this again. Yeah, let's try this again. All right. Now, if you keep on getting this error, it's all right. What you need to do is you just need to add double quotes around it. And we'll identify this as a label itself. Okay, so label agent 1 matches 1 node. All right, so now we have restricted this project to be run only on agent 1. We can make it to agent 2 also if you want it. Now we'll come down and we want to configure the source code management. So I'm going to click on Git over here and I'm going to paste the URL, repository URL again. So let me just copy that. I'll paste it over here. Okay, so as you can see, there are no credentials required because I made this public. So if you guys want, you guys can go ahead and use this simple web app also if you want. This is just simple-web-app. And that's all you need to configure. If you want to change the branch you're using, you can go ahead and do that. But there's no need for us right now. Everything is on the master branch. So we're going to leave this as it is. And we're going to come down and that's it. That's all done. So we basically configured our build job to take in or clone our GitHub repository. So whenever you select this, right, it's going to go ahead and clone your repository. Now we want this build to be triggered on certain condition. So that certain condition is going to be GitHub hook trigger for Git SCM polling. So what this basically means is that whenever you push anything onto this repository, your Jenkins will automatically identify, given that your Jenkins is up and running, and it will trigger this build. only if you tick mark this, or only if you check mark this. That's because we are, basically configuring it so that it gets triggered on this condition. Now, for this to actually happen, what you need to do is you need to go to your whatever repository it is and go to settings, and you need to configure a webhook, because that's how Jenkins does it. It basically uses the webhook to get the code and see if there are any new pushes. So even if you change a code, even if you change like a little bit of the code and you push the new changes onto this online URL, then there is going to be a change detected and your Jenkins build is going to be triggered. Now I've already configured one over here. Let me go ahead and delete this, but before that we'll copy. All right, so we'll basically be writing this address. Now I'm deleting it so that I can show you guys again. So I'm going to click on add webhook, and I'm going to come down over here and I'm going to change payload URL from this to the address that we have over here. Let me go ahead and copy this. We'll paste this, and it will be GitHub web hook / All right, so that's the payload URL. So basically, when we put in the payload URL, this is the URL in which it's going to, access Jenkins through. So here you can go ahead and configure which event you want to trigger this webhook. So we just want the push event. That is basically anything gets pushed onto this repository. Or if you want, you can select individual events over here. You have a lot of options to choose from, a lot of different options. You can see pushes is one of them. Now we'll just leave it to just push event, and we'll add the webhook. Okay, so whenever you go ahead and add your webhook, right, you need to make sure that the last delivery over here was successful. Basically, it should not be gray or red. It should have the green tick mark. So that will only happen if your address is right. So you need to copy this from your Jenkins address and add the GitHub hyphen webhook. And if it's able to connect, then your webhook is ready, and basically it will be triggered. This build will be triggered whenever there's a push onto this system. So there are other build triggers also. If you want to trigger it, build remotely, if you want to add a script, if you want to use a script to trigger this build, you can go ahead and do that. Now you can build after other projects are built, so you can specify which project it needs to be built after if you have other projects, and build periodically, set a specific schedule in which it needs to be built. A lot of people will go ahead for that, and GitHub trigger for Git SCM, and this is poll SCM. So again, no schedule, so will only run due to SCM changes if triggered by a post commit hook. All right, so that was your build triggers. Now you can go ahead and configure your build environment. Basically, what's going to happen inside. Now it's pull the code based on a specific condition. Now, what will happen in the build? So in the build environment, what will happen first? So basically, we will select delete workspace before the build starts. This is important if you want to clear off the workspace in your Jenkins slave where all the processing will happen. Like if it needs to download some extra content, it will do it on the slave, and that location should be cleared off. You want a clean location or clean workspace before you start working. So I'm going to go ahead and select delete workspace. And if you want to use secret text or files, you can go ahead and select this. Abort the build if it's stuck. You don't want to use more resources than necessary. And there are a lot of other options like add timestamps. So we're going to go ahead and select this. We want to see the timestamp every time a particular log is created in our console output. And you can go ahead and use it with ant or inspect build log publish for Gradle build scans. So these are the only two things we want configured in the build environment. Now we will come to the actual build itself. So in actual build itself, what I'm going to do is I'm going to select our build steps. You'll see that we have a lot of different options. We're going to choose execute shell. So basically you can, if you select that option, you can go ahead and type in all the shell commands that you may want to. So for example, I will type in over here, echo this job is being built. All right, so that's going to be my first command. Then I can go ahead and add more commands. Now I'm going to add all the commands that are necessary for me to run my app, that is simple web app. So I don't need to clone my repository because it will automatically do that onto the workspace. So what I do need to do is I need to install Docker on my slave. So instead of doing it directly, I can do it directly, but I'll do it over here. So I'm going to start writing commands for that. Sudo apt update. So we want to update the slave. Then we will go ahead and install Docker using this command. Then we will go ahead and build our Docker image. So I will do sudo docker build -t, and I'm going to give this name my image and then dot. Then we're going to run this image as a container. Sudo docker run -it -d -p. We want it to be published at the default port, and we will give this a name. I'm going to give this a name my container, and we're going to reference our created image, that is my image. Okay, so far we are doing fine. So these are all the steps we want. And now if you want to add any post build actions, you can go ahead, basically add any email notifications or build other projects or archive artifacts, right? So we're going to go ahead and click on save because that's what we want to do. And we're quickly going to basically build our project or our job. So I'll click on build now. So this is manual building. If you don't schedule it or if you don't put in a trigger, it will manually build. And you can see under build history that it's building. This gray circle basically tells us that it's in progress. This tells you how many builds there are. There's only one build, and this shows you the process. And above it, you can see the time where it's taking place. So you can click on the console output and it will show you all the logs being created while your build is happening. So you guys can see over here, we can see all the details running as system, building remotely on agent 1, and this is going to be our workspace. And within it, you guys can see that it's cloning our Git repository, no credentials required. Then it basically updated the system. It installed Docker and it built our image. So you guys can see it's taking the Docker file and it's building an image out of the Docker file. And after building the Docker file, it's basically creating our container. And after it's done creating a container, it tells us that the build is finished. So when your build is finished, if you scroll up, you can see that your circle or your blob or whatever sphere you want to call it, it's become blue now. So that means your build has been successfully finished. So unless there are any logical errors that you see, your build is running totally fine. So this means that if we go to our port 80 of this particular or of our slave 1 or agent 1, that's where we ran it. So let me go ahead and get my agent 1's IP address. And we will go directly to the agent 1 IP address because that's the default port. And you guys can see my simple web app has been published. You can see that it's running totally fine. Okay, so that's our build job. Now let's see what happens when we trigger it, right? So that's what we wanted to see. We want to see an automatic triggering of this build job. So what I will do is I will open up a folder over here. Okay, so this is the location where my code is. As you can see, Docker file, index and Jenkins file. I'm going to git bash over here. And over here, I am going to make some changes in my index.html. I will go ahead and instead of hello, I will say I am the best. I will say I'm just the best. I'm going to go ahead and save this, and I will stage all the files. I will go ahead and commit this. I will go ahead and push this, git push origin master. Alright, so I've pushed the new code and we should be seeing a new, yes, as you guys can see, the build is being triggered because it detected a new change happening in my code, and you guys can see it's pending and it's finished waiting. So you can see it's building now. All right, so it tells us there is an error. Now I'm going to assume this error is because we already have this Docker container running and it's a conflict issue. And true. Yep. So error from response. There's already a container named my container. Okay, so let me go ahead and remove that container. All right, so now let's build it. Build now. Now it's not exactly the same effect, but you guys can see that it works. So if I just refresh this, you guys can see that the new changes happen. Okay, so this is how you would go ahead and configure your build. A very simple web project build. Okay, so now we've seen freestyle build project. Now let's go ahead and see how we can do a pipeline. So first, I want to go into some theory. I want to explain the whole pipeline thing. So we'll come back and we'll learn about setting up a CICD pipeline or a continuous integration and continuous development pipeline. So when we talk about pipeline, we talk about how a software is going to be produced. What are the stages? What are the steps within those stages? So that's how a pipeline basically is structured. Steps and stages. So you'll have stage 1 with lots of steps within it, stage 2 with lots of steps within it, stage 3 with lots of steps within it, and n stages. Let's say you're doing n stages and you'll have n number of steps within all of these stages. So each of these stages and steps are important for your pipeline because each stage basically represents a particular phase of development. So let's say you have development, testing, building, staging, deploying. All of these are different stages of your software development process. So that's what a stage is. It's a bigger block of unit that represents a stage of software development process. It contains a set of steps to be executed. So in each stage, you'll have a certain set of steps. And these steps will be executed in that stage. And a step is basically a defined task that gets executed in a specific stage. So let's say in the building stage, you have a lot of things you want to do. You want to clone the repository. You want to use a specific tool. You want to build your software and you want to archive your software. So all of those are different steps that are happening in your building stage. So this is your basic CI/CD pipeline where you have stages and you have multiple steps within them. Okay, so with Jenkins, right? So when you want to create a pipeline in Jenkins, you have to make use of something called a Jenkins file. Now, a Jenkins file is basically a text file in which you write all the configurations that are necessary to configure the stages and steps of a pipeline. It's basically a pipeline script. So if you guys remember about Docker file, where we wrote all the configurations to create our image, Jenkins file is similar where you write down all the configurations that will be required to create your pipeline. So with Jenkins file, right, you can basically, either write it in Jenkins itself using the UI, or you can, create a text file in your system and push it onto your repository like how I did. So if I'll show you guys an example. So here's an example of a Jenkins file where you have pipeline as the starting thing, and then you have the other keywords like stages, in which you have stage build, stage test, stage deploy. This is an example. Then you have steps within those stages, like echo this particular statement in this particular stage. So this is how your Jenkins file would look like. Now we write this in a groovy language. Okay, so now let's go ahead and try this out. So I will come back to Jenkins and I will go back to the dashboard. And I want to show you guys one more thing. You guys can see that, all my builds are over here. So right now there's only one build. It was successful, highly successful, because only 1 out of the 3 builds failed. So it shows me this particular sun with a few clouds. If there were a lot of failures, then it will show me a darker cloud and rest of the details. Now let's go ahead and click on new item again. And this time we'll select pipeline as our item. So I'll select on pipeline and I will write over here software pipeline. That's going to be the name of our project. I'm going to click OK over here. All right, so I'm going to give it a description over here. This is my software development pipeline. All right, so that's our description. Now we can go ahead and put in our GitHub project URL. Now let me just open up my GitHub account again. And while that's happening, we can see all the other options. We have extra options. So most options are similar, but you have extra options like pipeline speed and durability override. So if you select over here, you have a lot of different options to choose from. Do you want maximum durability but slowest speed? This means your pipeline is going to be less crashful and it will run slower. But if you want performance optimization, it will be much faster, and it requires a clean shutdown to run any save any running pipelines. Or if you want less durability but a bit faster, then you can go ahead and select this. But we're going to leave it to default with maximum durability, and I'm going to uncheck this because we don't want to right now configure any of this. Okay, let me get my app. So again, parameterized project, if you want that, you can go ahead and add any parameter you want, or if you want to throttle any build, like this particular build, if you want it to be wait for certain time before it starts, then you can throttle it. Now let me get the URL. We will paste it over here. All right, now we will scroll down again with build triggers. We are going to basically select GitHub hook trigger for Git SCM polling. Now since our project, our URL has a webhook configured to this particular address and non-general and non-specific, basically it can any project from our Jenkins server pulls on this particular repository, or checks this repository and sees a new pull, it can basically trigger the build. So we don't need to configure it again. That's what I'm trying to say. If you want to disable the project, you have an extra option. You want a quiet period, so you can go ahead and select that, and you can basically see how much time you want it to be quiet. Then trigger builds remotely, again from scripts if you want. We're not gonna configure that. We're gonna come down some advanced project options. We're gonna go to pipeline directly, and over here you guys can see the script. And we can type in our Jenkins file pipeline over here itself if you want. Now you can select any of the sample pipelines they give. If you select hello world, you guys can see pipeline agent any stages. It will give you the stage and the steps. So this is a very basic pipeline. Now let me go ahead and put in our pipeline. So I will go ahead and copy this, come back and paste it, and I'll explain to you what this basically does. Now we're not doing anything fancy, but we do want to emulate how everything works out. So I have a few stages like building stage, artifact archiving stage. Now I've just put this for fun's sakes because you can do it in post actions of your build stage. This is just to explain to you guys. Then I have testing phase, staging phase, and I have the deploy phase. All right. And in each of them, I have echo statements that will print out these statements explaining what's happening in the stage, and it will run on any agent, right? So this is a pipeline. And now let's go ahead and save this. All right. So we have saved it. Now what we can do is we can click on build now. So again, you guys will see the stage view. There is no data available because the pipeline has not run yet, but it's running. And once it's completed, we can see the output over here. And you guys can see the pipeline over here. So you can see all the stages: building stage, artifact archiving stage, the testing phase staging stage, and the deploying stage. So you guys can see the stages over here. That's the stage view. You can see the average stage times around 7 seconds. You can see the time, how much they spent over here. And you guys can see whether it was successful or not. And if it was successful, you want to see the logs. You can see the logs over here. You guys can see the log. Close it. And if I see this log for artifact archiving, it's going to give me the message. So most stages were successful. There were no issues because we, had very simple statements. Now, again, if you want to view the console, you can view the console, even the pipeline. It will show you one by one what's happened, like running on agent 1. This is our first outcome, that is echo this statement, echo this statement, echo this statement, and it was finally finished successfully. So this is how your basically pipeline would look like. Now you would obviously configure it to have much more complicated things where you pull the code, you build it using a tool maybe called Maven or MS Build or whatever build tool you're using. Then you want to you want to put it onto an artifact repository like JFrog Artifactory. You can configure that to be connected to it. Then you can run a bunch of Selenium tests if you want, and then you put it onto a staging server. And once it's scheduled, you can go ahead and deploy it on your production environment. So this is how you would create a pipeline. Now you can click on pipeline steps over here, and it will show you the pipeline steps in a better way. So you can see each pipeline, each stage, it has different things. Start of pipeline, allocate node body start, and stage start, building, the print message. All right. Okay, fine. Now let's come back over here. I want to show you guys one more thing. What happens when we push the code? Because we have configured it. So let's see our pipeline being run automatically. So if I open up my Git bash, and let's go ahead and make a change in our index.html. We're going to go add a hello statement over here. Let me save this, stage this, and commit this. And then we will push this. All right, so we pushed it. Now let's come back, and we should start seeing soon the new build happening over here. All right, so it automatically did it. You guys can see the new stage view over here, and after we refresh it, you guys can see it. So again, build number 2, and it gave us the time it took for everything. Okay, so this is our pipeline, and we saw that it gets automatically run. So we will click on configure again. Now we want to configure one more thing, that is, if you scroll down, we want to change this to pipeline script to a pipeline script from SCM. So what this will do is it will basically take our Jenkins file from our repository itself. So it's the same pipeline file. Now we have to mention the SCM we're using. We're using Git, and the script we are going to put in the repository URL. I'm going to paste this over here. All right. Now we can click on save. And if we build now, we can see that the third pipeline is being built. Basically, the third job is happening. And you can see that there's another stage over here. That is the declarative stage. So this is basically checking out the SCM for the Jenkins file. It basically takes the Jenkins file from the URL and it starts building it, right? And that's why you can see all the rest of the steps, even though we did not include it in the UI. We included it as a Jenkins file in the repository. So guys, that's it for Jenkins. I hope you guys learned a lot here. Learn about what Jenkins is, Jenkins features, how to create a job in it, freestyle job, and how to create a pipeline. Continuous monitoring with ELK, Prometheus, and Grafana. So guys, now we will talk about another phase of DevOps that is called continuous monitoring phase. Now, in this phase, we generally like to talk about monitoring our servers or our applications or our software or our systems. So there are a lot of different things that we can monitor. So in this module, when you think about continuous monitoring, a lot of questions might appear in your mind, like why do we need to continuously monitor? What is it? What are these tools you're talking about? And what are the different types of monitoring? So guys, in this module, we will answer all those questions and even beyond. So guys, let's go ahead and get started by asking the question to ourselves, why continuous monitoring? So why do we need to continuously monitor anything at all? Why do we need to continuously monitor the applications or the system performance or the server performance? Any of these things, why are they monitored? So monitoring is a very essential part of software development process. You might think that your part gets over once the software has been deployed to the end user, but no, it's not. It does not end over there. You have to maintain the software, or you have to monitor the software. You have to monitor how the software is doing. Is it working according to the assumptions that we had picked out earlier? If is it working better than those assumptions, or is it working worse than those assumptions? So based on these kind of insights that we get when we monitor our software or our application or our server, we take in the feedback and we apply the improvements. Every time you get a new insight, there is a chance that you can improve upon the problem that might have caused a issue. And how will you get to know that there has been an issue? So that is another reason why you take up continuous monitoring, because you have your software up and running, the client is using it and everything, but you see that there's a spike in the amount of resources it starts to use, and you can't tell why. But then on the client's end or the customer's end, becomes very buggy and very slow, and you just don't know what's happening. So it's a good thing, or it's a good measure to have continuous monitoring where you're monitoring everything. You should have been alerted when there was a spike in that resource being used, or you should have been alerted when there was a crash, or there was bugginess, or there was slowness in your software. So for these kind of reasons, where we need to monitor our software's health continuously, we have to make sure that our software is running as efficiently as possible, that it's not using more resources than are necessary, because resources come they come expensive. So you need to make sure that things are using only the amount of resources that they need, not more than that, because anywhere you can save money helps you in longer run over there. All right. So those are some of the reasons why we continuously monitor. Now, if we go into it, continuous monitoring is an important part of software development process. It is something we take up as a measure to maintain the health of a software and to improve the quality of the software. And this is based on the feedback that we get from the insights gained from the monitoring. So everyone monitors, your big companies, your small companies, even e-learning education institutes like Great Learning also monitor their activity, and they can monitor a lot of different types of activity also. So you can have companies like Spotify, Windows, Adobe, Amazon, Netflix, Google, Slack, Bose, IBM, Adidas. These companies are a few to list. If I had to list all the companies that monitor, I would almost have to list all the companies in the world, because almost all companies in the world monitor their services or the products that they provide. Now companies like Google and Microsoft and Amazon, you guys might have already know about their monitoring services, where you can use the services that they provide from the cloud providers. But you might not know that these companies themselves track everything that you do. They track what you're saying. They might even be listening to what you're talking about right now, or they might even be listening to me talking right now. And they take in all of this data and they feed it to the algorithms that work on us. And when they create this perfect algorithm that knows everything that we like and everything that we may prefer, they run targeted ads on us. So that's how they monitor us. So you can see the deep level of monitoring that is being done with these larger multinational corporations like Google, Microsoft, and Amazon. And who's not to say that even the smaller companies, relatively smaller companies like Netflix or Spotify or Adidas or IBM or both, are not monitoring or buying data about us. Data is very important to study, and that's why we need to continuously monitor everything. And these companies and even smaller companies always monitor their data. So they produce a lot of different types of data. You have system performance data, you have memory performance, memory usage, then you have the logs that are being generated from your software and your processes that are running and your system itself or your server. Then you also have a lot of server performance data, and there are a lot of different types of data basically that you will be collecting, or these companies are going to be collecting. So why do they collect these different types of data? Now, these companies collect these different types of data so that they can ensure that all the different parts of their services are running totally fine. So once they collect all of this data, what they do with this data is they basically visualize it. So when they visualize it, we can see what the real scenario is. What's better, looking at a sheet or Excel sheet where you have a lot of numbers versus a pie chart that gives you precise information about certain specifications? Obviously the pie chart, because for human eyes colors are more appealing, they make us understand more, they make us like these things more, and we are hence able to take out insights that we earlier could not have taken out just by looking at numbers. So that's why visualizations are important. So this data is taken and is converted into beautiful visualizations on which which happen only after the data has been processed and analyzed. So now when is where the human part comes in. We look at these visualizations and we try to come up with ideas, or we look at patterns, we try to find patterns and we understand them, and once we understand them we apply the feedback. And these companies also do this. They look at these patterns and they apply the feedback that they get from these patterns, and once they apply them, they can see eventual rise in the quality of the product that they're providing, because they're providing the best product as possible, because they're studying the data so well, and they're making sure that every part of the software development process or any service process is working totally fine. And because of that, they're retaining more customers and getting even more customers. So this way their revenue increases and they become the top dogs of their market. And one more benefit that these companies see is high scalability, because if you are able to monitor your IT environment and your software development pipeline, you understand every small intricacy of these pipelines. So once you understand these intricacies, you're able to replicate them on a larger scale. Now, when we talk about scalability, we're talking about increasing the number of services that we are providing to our customers, or the scale on which we're providing the product. So to do that, we need to make sure that we can do this without having any issues anywhere. So that's why we need to continuously monitor. So you can see that the companies get so many benefits when they continuously monitor. So guys, now let's talk about the types of monitoring over here. So you can see there are a lot of different types, like system performance, process monitoring, integration, application performance, business monitoring. So all these different types of monitoring basically help us to get better insights into a lot of different things. So if we talk about system performance, we're checking how much CPU usage there is, how much memory is being used from that system, how much that system is using. And if we identify that it's using more than necessary, then we try to rectify that mistake, because in future we want to reduce as much resource as we are providing it. And then we come to process monitoring. So process monitoring is again similar to system performance, where you're checking the performance, but you're checking it for a singular process. You might if I had to give you guys an example, if you're playing a game on your Windows system and you see that the game crashes and it makes your whole computer slow, so you do Control Alt Delete and you bring up the task manager and you check what is causing this slugginess or this slowness. So you see that your old game hasn't exited properly and you go ahead and delete it. Now it hadn't exited properly, so it was using a lot of memory, and because it was using a lot of memory, it was causing strain on the other processes that were running in the system. So you can see how this can be a big issue when you're talking about software development. These processes are very delicate. If any one thing goes wrong, it can cause a chain reaction which can cause the whole pipeline to crash, or the whole software to crash. So it's again very important to monitor. Now we talk about integration. Now in software development, you have a lot of different parts, like your database, your networks, your software itself, and your tools that you use to deploy the software. All of them, if you put them together, then they should be able to work properly. So you need to monitor that each part of the software and all the other parts that it's connected to are integrated very well. You need to be able to check if they are working or not, if they're up or not. You continuously monitor their heartbeats. Then we have application monitoring or application performance, where you monitor the application's performance. So you see how well the application is doing. Is it doing better than our expectations? If it is, then you see why that's happening, because you can use it later for more projects. And if it's doing worse, then you try to find out what the issue is. And then comes the business monitoring part, where you're monitoring the business. So as I told you guys about how Google, Amazon, and Microsoft collect all of your data, that's basically a part of business monitoring. Now business monitoring does not necessarily be that only. Business monitoring can be see how your business is working, what kind of inventory you might be keeping, what are you buying, what are you selling, what are the trends that are being created in this kind of environment, what are the patterns there are. So that is business monitoring. So you use specific tools like Tableau or Power BI or any kind of business intelligence tools over there. So there are a lot of different monitoring tools. There are a lot of different classifications also. You have logging tools, you have monitoring tools, you have business analytics tools, and you have open source tools, and you have paid tools. So the list of tools given here are some of the tools that are free, like your ELK or Elastic Stack is a set of open source tools that is completely free for you to use. And similarly, you have Prometheus and Grafana, which are also completely free to use. And then you have Nagios, which is also free. But then you have Splunk and you have Amazon CloudWatch. So these are paid. So again, you guys can see there's a lot of variety in different types of tools. Like you have your Elastic Stack, which only, it's majorly a logging tool where you basically collect logs. Whereas your Prometheus is basically used for collecting metric data. So these are the different types of monitoring tools. You can choose a monitoring tool based on your requirement. You may not even go for the tools listed over here. You may even go for some other tool that you think that suits your needs much better. You have ELK Stack or Elastic Stack for logging purposes, and you have Prometheus and Grafana for metrics purposes. Now, the difference between logging and metrics is that logging is used to identify what kind of issue is there. And metrics basically allows us to see if there is an issue at all or not. So let's say that you have a software and you are monitoring the metrics of that software, and you see that the metrics start to go haywire. So now you identified that there is an issue. So you did that by watching the metrics. Now you want to go into depth. You want to see what the issue is. Why did it occur? So that's when you bring up the logs. You see what is the thread dump. You see why the software acted the way it acted. So that's where you bring in logging. So these are the two different things that we will be covering. That is logging with ELK Stack or Elastic Stack, and metrics with Prometheus and Grafana. So let's start with ELK Stack. What is ELK Stack? So guys, ELK Stack can also be called Elastic Stack. Now there is a reason behind this, because let's first define ELK Stack. So ELK Stack is basically a set of open source tools that allow us to monitor, collect, process, analyze, and visualize data. This data can be of many different types and formats and almost any different source. It was developed by the Elastic company iteratively. So that means that you guys see the ELK, right? So each of these letters stands for the tools that are part of the stack. You have Elasticsearch, Logstash, and Kibana that form the ELK of the stack. But the thing is that, they started coming up with more tools, like not just ELK. They came up with something called Beats. They came up with more XPack tools. So instead of, keeping on adding, those letters to the name, like ELK, B, X and all. So they decided to make it Elastic Stack so that they don't have to add any more letters. So that's how, the Elastic Stack name came. But you can call it ELK Stack or Elastic Stack, whatever you're comfortable with. So they started with Elasticsearch. That's the first tool that they made, and they kept on adding more tools to the stack. So the primary purpose of ELK Stack is for log management. So basically, any log that you have is collected with the help of ELK, and it is converted into a set of visualizations that help us to understand these logs. Right, so it does what any other good monitoring tool does. It basically takes in the data and it helps us to understand that data by creating really beautiful visualizations out of it. All right. Now there are a lot of competitors to ELK. One of the most prevalent competitors to ELK is Splunk. But the thing with Splunk is that it's a very expensive software. A lot of companies make use of it, but it's on the very high end and very high payment spectrum. Whereas ELK is a completely free tool. It's completely open source. But even though it's completely open source, there are some paid features that we will talk about. All right, so what are the features of ELK? So let's go through these features one by one. So we have system and application performance, where it basically gives you the performance of the system and application also while logging about them. Then logging, that's its major thing. Then stack security and alerting. So it creates a layer of security because you're monitoring the networking and you're monitoring the whole system. So you understand that that there can be some kind of breaches. So you keep monitoring for them. And you can schedule alerts by using ELK, where for specific conditions that you said that alerts are created. Then you have to talk about scalability and resiliency. So ELK helps you to increase your scaling prowess and allows you to scale much better. And you have dashboards and visualizations. Now this is something very obvious, but ELK allows you to create very dynamic and real-time dashboards with really beautiful visualizations that get you the whole idea of what's going on with your software or with your system or your application. So these are the features of ELK. Now let's talk about the ELK stack itself. What are the different tools that are used inside of ELK? So we will start off by talking about Logstash. So Logstash forms the L of the ELK. So it's basically a collection agent. It is used to collect data. It finds data and it collects the data. So that's what Logstash does. Now that's not its only responsibility. It has another job, that is of filtering and pre-processing. So any data that is being collected is raw data. Now, if you want to filter it or process it, then you would go ahead and again make use of Logstash. Then you have FileBeat, which is a part of set of tools called beats. So beats are basically lightweight data collectors. So they are an alternative to Logstash. So when Logstash was pretty prevalent, being used by a lot of different people, they complained that it was very, very, resource intensive, and it kind of affected the performance of the server that was monitoring. So that's not a really good thing, right? So they came up with these lightweight data collectors called beats. And each of these beats collect different kinds of data. You have FileBeat that allows you to collect, logs. Then you have metric beats that allows you to collect metrics. Then you have audit beat that helps you to collect audit events. Then you have winlog beat, heartbeat, network beat, packet beat, and a lot of different types of beats that collect different types of data. So these are individual components that allow you to selectively choose the type of data that you want to collect. So just for the sake of it, we'll call FileBeat as the tool that we're going to be, thinking about when we talk about ELK Stack. All right. So then we have Elasticsearch. So this was one of the first tools that was ever developed by Elastic. And this tool is basically a database. So it allows you to basically store and index data. So it was created based on the Lucene search engine. So that's your storage mechanism. So once your data has been collected, it will be stored within the Elasticsearch. And then you have the visualization medium that basically allows you to create visualizations, dashboards, and Kibana basically acts as the general graphical user interface for the whole system. Also, if you want to check out what all objects are being stored or what all data is being stored, you can check it through Kibana also. So that's Kibana's role. It acts like a general GUI as well as, your visualization medium that allows you to visualize and, create dynamic dashboards. Then you have the infrastructure. Now I've given here Elastic Cloud / infrastructure. Now I say this because Elastic Cloud is a service that you can choose to have. You don't necessarily need to have Elastic Cloud. So what Elastic Cloud says is that, you don't have to set up any of these tools. You don't have to manually set up any of these tools. Elastic company will do it for you on a cloud service, and they will provide you the service. So you don't have to maintain any of these tools. You just have to pay them a fee, and they will provide you the service as well as the tools. So this is how they make money. Instead of, making the tools paid, they just give you the cloud service, and they say that this cloud service is a paid service. Now, it's not necessary to take the Elastic Cloud. You can go ahead and use your own infrastructure, or make use of your other cloud services infrastructure like AWS, Azure, or GCP. So you have a lot of different options. Then you have something called XPack. So XPack is a set of extra tools that don't generally count as the main set of tools, but definitely are counted as they provide a lot of different functionalities like, security, reporting, alerting, and machine learning. So that set of all these different set of tools. And you even have APMs like application performance monitoring tools. So you have all of these different tools that basically come together to form the ELK stack. Alright, so now let's move on and discuss the architecture or the layout in which all of these tools are laid down and how data flows through them. So let's imagine that we are taking data from a server. So this is our data source, and data is collected by a file beat. So we are collecting logs, server logs. So we are making use of file beat, and we're collecting data using the file beat. Now, once the data has been collected by file beat, it will send the data either directly to Elasticsearch, that is our database, or it will send it to Logstash. Now, what can be the reason that data is sent to Logstash? Now, if you guys remember, I told you that Logstash has two purposes, not just collecting data, but it also filters and processes data. So once the file beat sends the data to the buffer, this can be your Redis, where you store the data in your buffer before you send it to Logstash, then the data goes to Logstash and it gets pre-processed, because you obviously don't want the raw data itself. You will want only specific data out of that raw data. So you want to filter it and you want to pre-process it to clean it up so that you can basically analyze that data. So once the filtering and pre-processing has been done, Logstash will go ahead and send that data forward onto Elasticsearch. So the data will now go to Elasticsearch and it will be stored in the Elasticsearch database. Now this will map to your local system, or if you're on cloud, it will map to local or clouds, storage, and it will basically, first index the data so that it's searchable. It will make the data searchable, and it will go ahead and then store it. So once the data has been stored, the data flow kind of stops over here, but you make use of Kibana that actually references the data in Elasticsearch to create specific visualizations or dashboard. Or even if you want to explore your data, like if you want to just look at your data, what are the fields, what are the events, then you can use Kibana for that purpose. Just open a Kibana up, then discover the data, and then type in any query you want to search up certain parts of the data. Or you want to create visualizations or dashboards, then you can do that too. So this is where your Kibana comes in. So it does all of the analysis and visualization part of the ELK stack. So this is how data kind of flows within ELK architecture. First, it's collected from a server or a data source onto a collection agent like FileBeat. Now the FileBeat can directly send it to Elasticsearch, but it can also send it to Logstash, where it will go ahead for filtering and processing. And once that happens, it will go to Elasticsearch, where it gets indexed and stored. And from there, it moves on to the it's referenced by Kibana to either create visualizations, dashboards, or to just explore the data. And again, there is a layer of security around all of these stack of tools that inform you if there are any unauthorized accesses. And there are alerts that you can schedule within ELK if something goes wrong, like if one component stops working or if there's a data leak, then you can configure an alert to inform you through email notifier or Slack or PagerDuty, whatever you use. Alright, so guys, this is ELK architecture. What is Kubernetes? So Kubernetes is a very interesting topic that, it's a very interesting technology that is being used in our software development industry these days. Now, why is it so interesting and why are people using it? So to understand what Kubernetes is, we first need to understand how software development goes, right? So why do we need Kubernetes? See, the thing with Kubernetes is it's a part of software development. So if you're making software that, uses any concept of AI, then you are definitely making use of Kubernetes over there. Now, definitely, it's a strong term. I'm saying that because in software industry, a lot of people use Kubernetes for a specific purpose, and that is especially in software development. So if you're a researcher, you may not use it, but if you're in the industry where you need to make profits, so that time you will use Kubernetes. So let's understand what a standard delivery pipeline is inside of software development. So software development is the process of developing software. We have developers
who develop software. Now, these developers, their role is to basically create code. So what they do to create code is basically, they write the code down, they understand the requirements of the project, they write the code down. And once they do write this code, what they do is they send it ahead for building process. Now, what is the building process over here? So you guys need to understand that writing code is not making the software. To make a software, you need to add a lot of different things. This code can need a lot of external libraries or functions or frameworks or tools that are required for this code to run properly. So in the building process, you take the code, you take all of these external dependencies and you add it into a single thing. You call those things builds. Now, these builds can be packages or executables or artifacts. You can call it anything. Okay, so that's the building process. Now, once the code has been built, it goes for the testing. So what the tester does is the tester takes this code and he moves ahead for testing it. Like he tests it for different kind of things like requirement testing, acceptance testing, integration testing, unit testing, a lot of different types of tests. So he makes sure that this code goes, it's a polished code. There are no issues, right? So the tester will do that to his best of his abilities. And if he thinks the code is fine, he will send it ahead for deployment. Now, the deployment part is where the software goes to the end users, where it goes to the production environment. And inside of that production environment, it basically, is available to the users. So let's take this example of YouTube. YouTube is a software that allows us to stream videos, watch people talk and everything, right? So it's a software. So right now it's in the production environment because you can access it. So being in a production environment means it's accessible to the end user, right? So this is the standard delivery pipeline. Developer develops code, code becomes software, software gets tested, after testing it goes for deployment. Now, if there's any issue in testing, the cycle repeats and the general cycle also repeats when you want to make a new version of this code. But the thing is that there can be some issues over here, and that's why we talk about issues we face before containerization. Now, containerization is an important concept if you want to know what Docker is, right? So I see that a lot of people don't know exactly what Docker is, but they do know a little bit about it. So let me give you an idea what containerization is. So containerization basically solves a very big problem in the standard delivery pipeline, where here in this pipeline, there can be multiple issues. The one issue that I think is one of the most important issues is the compatibility issues. Like the developers and the testers, they have their own laptops. And the building that happens will happen on some kind of server. The deployment will happen on some kind of server, right? So when you have so many different kinds of servers and laptops being involved in this whole pipeline, you want to make sure that the code does not behave differently on these servers, because in different environments your code can behave differently because you might have a different version of a tool and that may cause the code to behave differently. So if you guys know about the Java story where you use Java for Java 8, you write the code in Java 8 but you cannot use it properly in Java 11 because there's a lot of differences over there. So you need to write the code for Java 11 and we don't want these kind of issues. So instead, so let's see the environments of developer and tester. You guys can see that these are the environment in which the developer is working. He has the CentOS operating system and he's using PyTest 5.4.3 to do his own tests. And he's using the PyCharm IDE. This is the integrated development environment where he writes all of his code, and he's using the Django backend code. He's writing that and he has a certain dependencies that he needs with this Django backend code. Right? So to work with this code, he decided he needs PyTest 5.4.3. He originally had 5.3.0, but he needed the new version because he felt that the requirement asked him to do so. So he changed to the new version. But the tester didn't know about this. He didn't know that he needs to change to the new version because the developer forgot to tell the tester. Even though they have the similar environment, only the difference is PyTest and the integrated development environment they're having, the issues can occur. The same test cases will not run, and the same code might say, tester might say the code is not running properly on my system. Developer might say the code is running fine on his system, because the system changes. The small configurations that the developer makes may not be on the tester's system. So you see what happens when you have two different systems handled by two different people. So these causes bottlenecks in your software development pipeline. These bottlenecks cause, delays in software to be developed because the tester is not able to test his thing. So he's not able to push it for deployment, right? So how do we resolve all of this? To resolve all of this, there is a simple answer. It is to maintain a standard. Now, the developers and testers can follow a standard, but that's a little hectic and tedious to do so. Every time the developer decides that you need a new thing, the tester has to sit down, talk to the developer, and add the new changes. Now, it is a better practice than what is being followed, but it is tedious. To again resolve this tediousness, what we do is we make use of containers. Now, think of containers as boxes. These boxes act as their own devices. Now, these are virtual devices. You can imagine them as virtual machines. So instead of the developer running all of his code on his system, he runs the code inside of the container. So inside of the container, he will have the operating system, he'll have all the tools and dependencies for the code, and he'll run it inside of the container. So he sees that inside of the container it runs totally fine. So instead of pushing the code directly, he pushes the container. Now, once he pushes the container, the other process, the building process happens in the container. So in the same container, right? No need of checking using another server. Just do it inside of the same container. So all of these processes will happen in the same container. This way, the environment remains the same. So let's say the developer set the environment as having sent to his operating system, PyTest 5.4.3, and the same Django code and same dependencies in the same container. It doesn't really matter what's there in the tester system or what's there in the server in building server or in the production server. It does not matter because the code will be inside of this self-contained environment called a container. And the container is the one that is going to go through all of these processes. The tester is going to test it inside of the container. The building will happen inside of the container. And the production will basically, the software will be deployed within these containers, right? So that's how containerization solves a lot of issues. That's why we like this topic of containerization. That's why we like this technology of containerization. Now, these containerization happens because of containers, these boxes, right? So to get these boxes, to create these boxes, or let's actually know what's a container. So containers are software that wrap up all the parts of code and all of its dependencies into single deployable units that can be used on different servers. What this basically is saying, you have the code and libraries and the environment. I did not mention the environment here, but imagine the environment also. And you put it inside of the container, and now you can run it in any system, any server, right? So that way you don't have any compatibility issues. Now, how do you create these containers? To create those containers, you need something called Docker. Docker is a containerization tool that allows you to create containers. It basically allows you to take your application, put it in a set of containers, secure it, and send it for deployment. So that's what Docker does. It's an open source tool that allows us to create containers. These containers take the application at hand and put it in, send it for deployment or do whatever process. Now, you can imagine containers as VMs also. So if you guys know what a VM is, you will have a better understanding of what a container is, right? So just keep that in mind, that containers are not exactly virtual machines, but they act like ones, right? But they're not the same thing. That is very important to know. All right, so why do we need containers? We've already mentioned one thing, that is having consistent development environments so that we don't have any unnecessary bottlenecks and compatibility issues. One more thing is microservices. Now, this is where all of these orchestration tools comes in, orchestration tools. So in the comments, I've seen a lot of people mentioning, talking about how it's an orchestration tool, right? So Kubernetes is an orchestration tool. Docker Swarm is an orchestration tool. They help us to implement microservices architecture. So what is this microservices architecture? So basically, when you deploy your application in the production environment, you don't deploy the single file, or you don't deploy just the file as it is, because that causes a lot of issues and it's very difficult to manage it, to handle it, and a lot of different things. So what we do instead is we take this singular app, we divide into multiple chunks. You guys can see 5 chunks over here. So these 5 chunks actually make one single application. Now, once they make that single application, basically we need to manage them. So what we do is we take certain features and we put them into these chunks. So let's say an app has 5 features. We'll take those 5 individual features and put them in these 5 chunks. Now we'll take these 5 features and we will put them inside of containers. Because they're inside of isolated environments, they can be a part of the software development pipeline. People can individually work on them. So you see this pipeline, right? So each of these 5 parts can have their own pipelines. You can have 5 teams working on these 5 parts and 5 pipelines, right? And in the end, all of them get joined together and form the app. So Google or Amazon has a lot of services. Now that would be a bad example. Let's say, let's take an example of, now the usual example I take is Swiggy, but I want to give you guys a different example over here so you get a better idea. Let's take Zomato. So Zomato has a lot of different services, right? They give a lot of different features. So in their app, you have the grocery buying feature, you have the delivering things feature, you have the buying food feature, you have the rating feature, and you have the video streaming feature. So all of these features have their own certain pipelines, and all of them get connected together to form the app, right? So that's how they implement it generally. They divide into multiple chunks and they implement it like that. So that's what microservices is. Now, to handle all of these 5 containers, how do you handle them? How do you manage them? Because that matters. How do you manage them is important, because when you want to remove something or update something, so let's say you wanted to update the video streaming feature, so you need to quickly do that without affecting everything else. So you make a new update and you push it, right? So to do all of those managing things, you use orchestration tools. Now, Docker is a very awesome tool that allows us to create these containers. But when you have multiple containers of these, how do you manage them? That's where Docker comes. That's where Kubernetes comes in. Kubernetes is an orchestration tool that allows us to manage all of these things. Okay. So we already seen what is Docker. Okay. Okay, so since a lot of you don't know what Docker containers are, since you didn't know before, now you know. Let me just tell you something, that you don't just have these containers, just like that created. To create containers, you need to create blueprints for these containers. So whenever you create a house, right, you use a blueprint to design that house. So similarly, to create a container, you need a blueprint for the container. And we make images. These images are these blueprints that tell us how a container is going to be constructed. So let's say you want to create an Ubuntu container, a container which has Ubuntu operating system inside of it. You will create an image inside of which you will mention Ubuntu as the operating system. And once you run this image, you will create the container that has Ubuntu inside of it. Okay. So this is what an image is. So when I say you transfer the containers across all of this pipeline, you actually don't transfer the containers, because containers are something you can, run at the click of your fingers. But images are the ones that store all of the information. So instead of passing the containers, you pass the images. These images get run on those servers to become these containers. Okay. So I hope that was clear. Images are basically blueprints that define how container is going to be run. All right. So yeah. So multiple isolated containers can be launched together to form microservices, and they are managed using orchestration services such as Docker Swarm and tools. So if you have 3 containers, they're all attached to each other, and you want to manage all of these containers, so you use either Docker Swarm, which is an orchestration tool that is provided by Docker itself. So Docker is a tool that allows us to create containers. It has a service within it that allows us to manage it also. Now, I told you guys we use Kubernetes to manage them. The thing is, Kubernetes is a separate tool that allows us to do so. But there's something called Docker Swarm, which does exactly the same thing, well, similar thing, and it allows us to manage the containers. Now, the difference here is that Kubernetes is more of an industry standard. People prefer to use Kubernetes because it's more secure, it's more robust, and people just like using it more. Docker Swarm is not used that much. There's very limited use, but don't take my word for it. There might be companies that actually use it but don't reveal it. They might be using it for proof of concept reasons or whatever reason. Okay, Kubernetes is generally overshines Docker Swarm as a tool. So people generally use Kubernetes to manage and Docker to create containers. All right. Docker is a containerization tool. Kubernetes is an orchestration tool. That's the simplest way you can define both of these things. Again, Kubernetes is an open source container orchestration tool that allows us to manage multiple containers in different types of environment. A pro about Kubernetes compared to other orchestration tools, such as Docker Swarm, is that it is very robust and a secure orchestration tool that doesn't leave us wanting much. So that means that Kubernetes is way better than Docker when it comes to thinking about security and being a robust tool that gives us a lot of stability, that doesn't mess up by itself also, because you want a tool that doesn't crash itself. because then it gives you very less number of options. Okay, so that's what Kubernetes is. It's an open source container orchestration tool. So if you look at features, you guys will get a better understanding of what Kubernetes can do. So first feature is easy updates and rollbacks. So easy updates and rollbacks. So let me talk about that microservices architecture again. Let me give Amazon's example. Again, these services, right? So these services are again given to us together, but they're probably put in the servers separately. So what happens when you want to update each of these servers, or when you want to perform a rollback? The rollback basically is, you roll back the current version and you put in the previous most stable version. Let's take example of EC2 and Lambda. So Lambda, let's say that Lambda's version 3 is being released and people really like Lambda's version 3. But then suddenly there's something goes wrong in Lambda version 3. So you want to perform a rollback because you want your users to be able to use Lambda, right? You don't want any downtime. To reduce the amount of downtime is the time in which your application is not available to the end users. So to reduce that downtime, what you do is you roll back the version 3 of Lambda and you quickly push version 2. Now, version 2 was working totally fine because you've used it for a long time. Version 3 is the latest release. So you push version 3 back and you put version 2 out, right? So that's a rollback. Now, updating is similar, where you basically update your services separately. So EC2, if you want to update it from version 3 to version 4, you can do it, right? Okay, so that's easy updates and rollbacks using Kubernetes features. So if you have a lot of different services together or features together, and you want to update certain ones, then it becomes easy to do so with the help of Kubernetes. Then you have storage distribution and secret handling. So let's go to storage distribution. Now, storage distribution, what it talks about is basically when you have multiple containers representing multiple features and you want to share data between these containers. The thing is, inside of containers, you cannot store data. That's one backside or drawback of containers. But then it's quickly overcome by the availability of volumes. Now, volumes are basically places where we can store data permanently. In containers, you can store data, but it affects the efficiency of the containers. So it's general better standard practice not to store data in the containers. So instead of that, you store it in external storage thing called volumes. These volumes are the ones that store the data. Now, when you want to share this volume between 2 or 3 containers, how do you do it? You use Kubernetes and you define how the volume will be shared among them. So that's why storage distribution. Then secret handling. Now, secret handling is basically defining how the secrets, these can be your username or passwords or very sensitive information, is managed between all of these containers. So that is something that Kubernetes can also do. Then it heals itself. So heals itself basically, okay, to tell you guys heals itself, I have to give you guys a better understanding of Kubernetes. So let's actually go to load balancing and easy scaling. Load balancing is dividing how the, okay, for this also I need to explain. Okay, here's what. So we'll pause, heal itself, load balancing and easy scaling. Before that, I will tell you guys how Kubernetes architecture is kind of like. So this is basically how your Kubernetes is going to be like. So you will have pod 1, pod 2, pod 3, service and ingress. Let's start with pod 1. So pods, what are these, right? We talked about containers. So suddenly where did pods come from? So when you have these multiple containers, let's say you have 3 containers and you want to group them together, you put them in pod 1. And these containers will have special characteristics between each other, that these containers are actually replicated. So let me give you an example. Let's say that there is a delivery company that does 3 things. The first thing it does is deliver food. The second thing it does is a video streaming service that they provide. And the third thing they do is they basically allow you to deliver packages. Okay, so these are the 3 things they do. So they use Kubernetes to manage all of these 3 services they have. So pod 1 is responsible for their first service, that is delivering food, right? So pod 1 will contain 3 containers. These 3 containers are actually replicas of each other. They're the same thing. They're just there 3 times. So in the first container, we will have all of the code, all of the tools, all of the environment that is required to run the service we have, that is delivering food. In the other 2 containers also, we'll have the same thing. Now, why do we have these 3 replicas? What's the point? Isn't it taking more space and all? So that's the thing. you create replicas of certain features to maintain availability or to have availability. So sometimes what happens is maybe your container one got crushed, like crashed. It crashed for some reason. Maybe it died off. So to make sure that there's no downtime. Now we want to make sure that there is no downtime or the least amount of downtime. That is a business related decision, because let's say my food delivery app is down, the person will go to the competitor's one. So we do not want that. So that's why we want to make sure that the downtime is very less. We don't want to cause any discomfort for the user. So that's why we have replicas. If one of them goes down, the other one will stay up or it will take its place. So let's say container 1 in pod 1 goes down, so container 2 will take its place. So we still have something representing the whole service, right? Similarly for pod 2, right? Pod 2 represents our second service. That is the video streaming service. Similarly, one container will be the one doing all of the work, but if it goes down, then we need a backup for that. So these other two containers are replicas, that those are backups. That if one goes down, we have the other one, right? So similarly with pod 3 for our third service also. So these pods represent our services, right? Okay, so I don't want to call these services because then you guys will get confused with the service idea. All right, so let me call them something else. Let's say these are features or functions. So what would you guys like? Let's say features. So this is my feature 1, feature 2, feature 3. So pod 1 represent feature 1, pod 2 represent feature 2, and pod 3 represent feature 3, which is the delivering packages. Now you have all of these together over here, pod 1, pod 2, pod 3. How do you control them? How do you manage them? How do you expose them to an external person, right? So to do that, what you do is you use a service, and this service basically acts as the interface. So it will basically manage all of the connections from pod 1, pod 2, pod 3 within the service, right? So this service will basically be representing our app. Okay, so why do we have an ingress over here since we already have a service? Now, sometimes what happens is you have very big applications like AWS. You have multiple. You have under compute, you have so many services. Under robotics, you have one thing. Under machine learning, you have, I can't even count the number of services there are. So let's say compute is one of the service. And within this service, you have pod 1, pod 2, pod 3. So let's say compute is one service, and within that service, we have EC2 as pod 1, Lightsail as pod 2, and Lambda as pod 3, and similarly. And this is service 1. Now we have service 2, that is machine learning. Within the machine learning service, we have more pods. Amazon SageMaker, Amazon Augmented AI, Amazon Code Guru, they have their own pods, but they're in a different service. So that's why I mentioned service over here. So you can have multiple services with multiple features within them, right? And all of these services will have one single orchestrator for them, that is ingress. Okay, so ingress is the one that manages all the different services. So what we're going to do is we are basically going to be installing Kubernetes. Okay, so let me do one thing. Let me go to EC2. Now in AWS, it's a cloud provider, so I'm going to launch a virtual machine in AWS. It's basically me launching an operating system in Amazon servers, so I can remotely use it. Now, why am I doing this? Because I don't want to use Windows, because Windows is not that amazing when it comes to using Docker and Kubernetes. You can use it, but I don't prefer to use it. So it's kind of a personal preference also, and it's a good thing because you guys will learn about Linux. So we'll be using Linux virtual machines. Okay, so let me just launch them. Right, so let's I'll be using Ubuntu server. Let me just open it up. So, okay, over here, what we're going to do is we're going to use t2.medium. Now, this is not a free tier, this thing. It's not a free tier, machine. I'm using it because of convenience sake. I think it will cost me around 20 or maybe 100 rupees. I'm not sure. Depends on how much time I'll be using it. So the thing about it is it's 2 CPUs and 4 GBs of RAM. We are using it because Kubernetes is a little heavy. It needs at least 2 CPUs. So that's why we're using 2 CPU and 4 GB memory one. Okay, we're not using the free one. Now let me configure instance details. We'll be launching 2. So I want to show you guys that we have 2 nodes within our cluster, Kubernetes cluster. So we can have multiple pods on those servers, right? Let me add tags. No need of add tags, just security group. I'm going to make it all traffic and anywhere. This isn't very safe, but it's convenience sake and for teaching you guys. All right. Okay, everything's fine. I'll just use the correct key and we'll launch it. So what we're doing basically, we're launching 2 servers. Yeah, ignore the rest. They were my practice sessions. I will name these so you guys know which ones are the ones that we want to use. So I launched only these 2 servers. Now on these 2 servers, I'll basically be installing Kubernetes, right? So let's open up the first one. I'm SSHing into them. Basically, I'm going into them. I'm using a client called Putty. You guys can use it too. You need your private key for this, okay? Or if you want, you can directly SSH using any bash terminal or PowerShell also if you guys want. Okay, so we are logged in, sudo su. All right, so let me just bring up my installation sheet. Okay, so these are the steps to install Kubernetes. First, what we're going to do is we're installing Docker. Now, you need Docker to run Kubernetes. Okay, so just think of the Docker as a dependency because it needs Docker to create containers. Okay, so first we need to update our instance. So I'll use apt-get update command. Now, I use the sudo su command to get root access. So make sure you have root access, and after you get root access, type in the command apt-get update. So this will update our instance package manager. Okay, so we have updated it. Now I'm going to install Docker on it. So this command is apt. Okay, let me show it to you. It just directly entered apt-get install docker.io. So this is the command that you use. This is the package manager. This is the command install, and this is the name of the package we want to install. That is docker.io. And -y is basically says yes, I want to install it. If you don't type the -y, it will ask you, do you want to install it, yes or no? So you type y there. Okay, so we've installed Docker. Now just to check the Docker version and see if Docker is installed properly. So this is the command for that, docker -- version. So Docker is installed, as we can see with the result over here. Now I will just start it, and we will enable it also. So sudo systemctl start Docker basically starts Docker, and the command I'm going to use now, enable Docker, basically tells this system, I'm telling my Ubuntu that every time you start up, you have to make sure Docker is started up also. Okay, so it's kind of like how you start your Windows, your Skype starts up without you even asking it. So that's kind of like it. Okay, then we're going to install some packages. Over here we're using the update command, and we're installing the apt transport https and curl packages. So we need those packages for working with Docker. So you have 2 more dependencies other than Docker. You have to install apt transport https. Curl you'll have in your system. Curl is a command that is used to get URL. Normally you should have curl. If you don't have curl, this is to cover up that up. And apt transport https is another, basically it's used to get data from https protocol. Okay, and this is Docker. So these are the 3 dependencies. Yeah, so these are the 3 dependencies. And now we're going to start getting Kubernetes itself. To get Kubernetes, first we need to get a signing key for it. So this key, so the thing with Kubernetes is we cannot directly type in, please install kubectl for me. Ubuntu won't know about it because it's not a thing that generally you can install in Ubuntu. So we have to tell Ubuntu that, I want to install Kubernetes. So first we will get a key that allows us to access the repository where Kubernetes is located. So let me just type in, you should get an OK over here. Okay, so once you get an OK, what we're going to do is we're going to get this command. No, not this command, sorry. This is to install Kubernetes. Right, so this is the command we need. So this will add the location where Kubernetes is into our apt repository. So you see the command apt add repository. So we are basically adding the Kubernetes repository into our apt package manager so that we can directly download from apt package manager. Okay, so once I press enter, you will see that Kubernetes repository is now added into this thing, apt. Now, apt is the package manager you use for Ubuntu. Okay, so once we get the location from where we can get Kubernetes, we will now download Kubernetes. So sudo apt get install kube admin, kubelet, and kubectl. So these are the three things that you generally need to run Kubernetes with. We'll mostly be running with kubectl, but kubelet and kubeadmin aren't, not necessary. So I'll install them also. So now we'll install Kubernetes properly. So you see there's like a lot of legwork to install Kubernetes in your system. And you need to make sure that you have a strong enough system to handle Kubernetes. All right, so it's installing Kubernetes for us. The next command is kubeadmin version. So we'll see if kubeadmin is installed properly or not. So let me type kubeadmin version. I will press enter. So it says, yes, it's basically installed. Version info. We got it. All right, so we've installed Kubernetes on this. Now let me quickly do it on the other system also. Now for this, I'm just gonna use a shell script. Let's give it a different color so that you guys can understand. All right, so sudo su. Now what I'm going to do is I'm going to create a script, and we'll run that script so that I don't have to type in all these commands. Okay. Okay, so let me just save this. Now, generally you can, just do the same steps again. This is just a very easy method for me to copy paste and press enter. So you guys can see it's already automatically executing. So you can execute shell scripts like that also. Just create a file called something.sh, type in all the commands you want to, and once you do that, execute it by typing in sh and the name of the shell script. Okay, and you can see that it's automatically doing everything. Okay, so with that out of the way, kubeadmin is downloaded. Now we need to initialize a cluster. So here's the thing, guys. When you have these multiple pods, right, you will have them inside of a cluster, which you will control with a service, right? So you need to initialize a cluster with one master. So I will create one node as a master. Let me go ahead and get the command for that. So this is the command sudo kubeadmin init pod network, and we'll press enter. So what it is doing right now, it's doing the pre-flight checks. First, it's pulling all the images required for setting up Kubernetes cluster. So it is using images. These images basically tell it how to create the cluster. So it's gonna take a few seconds or maybe a few minutes, depends on my internet, which is not that great. So hopefully we can actually do this in time. Okay, so we have Cube installed in that also. Now you might be wondering, why do we have one master and one slave? So we have one server for doing the master serve, and one is for the slave. So this is the one that's going to be having the pods. Okay. All right. So it's starting the process. Okay. So it's completed. Thank God it completed in time. So I can show you guys now properly. All right. So what we've done so far is basically we have installed Kubernetes, and we have initialized a cluster. So within this cluster, we can include multiple nodes. On these nodes, we can launch all these pods. So to the extent of our session today will be just to create the cluster and join all of the nodes. So whenever you finish this successfully, right? So the first thing you need to do is you need to copy this join token command. So just, carefully take all the command, copy it. Once you copied it, go ahead and paste it in your slave. And make sure you have Kubernetes and Docker installed. All the process that we did over here must be done over here also. Okay. So I paste the join command and I press enter. And you guys can see it's joining. It's doing the same thing. Okay, great. So this node has joined the cluster. which is awesome. We just wanted that. Now we'll come back to our master and we'll type in the command kubectl get nodes, right? So this will basically get the nodes for us. It should have worked. Did we mention the correct? Let me just check the security groups. Well, it's all sources, shouldn't be an issue. Yeah, Amit is asking how to list all the nodes. The command is kubectl get nodes, right? So should be giving us the answer we want. But I made sure to, make sure that there was no networking issue over here. Let's try sudo kubectl. I mean, we already have root access. Okay, so it's not able to connect. Okay, so I'll have to debug why this is happening. Give me a second, guys. We need to give it proper Kubernetes admin.conf. So we need to give it valid permissions. That's why it's not working. I just want to give you guys an overview of what we will be doing. Now, so this is what we'll be doing today, guys. We'll be basically going ahead and launching our static website. So I do not have an HTML file over here, but here's what I can do. I can go ahead and write an HTML code, a very simple code, no need to write anything fancy. My website title, and let me write a paragraph tag. Hey guys, I love ice cream. All right, so that's our paragraph tag. So this is basically going to be a static website. Now basically what we are trying to do over here is we are trying to we'll be trying to deploy this. So if we do it normally, let me go ahead and save this. Save as, right, as hello.html. You guys can see it automatically lit up. So if I refresh over here, yeah, so I have my hello dot, yeah, so this is what we should get. Hello guys, hey guys, I love ice cream. All right, so let's come back over here. Right, so what we're going to be doing is basically we're going to be using Git as a repository to store all of our code. We'll be using Jenkins to automate the whole process, and we'll be using Kubernetes to deploy anything we want. So what is the difference between all these three things? Let's go ahead and see them one by one. Now Git. So a lot of you may already know about Git. Git is a version control system, right? So here we'll basically be trying to use Git to store our code and to organize our code. So if I come to my browser over here and head to my GitHub account, so over here I can create repositories and I can store my code, right? Okay, so I can create a new repository and store code over here, and that is basically what Git does. It allows you to basically version your code, right? So let's say that you have two developers and they want to develop particular functions for their company. So what they will do is they will make use of Git to basically they'll write their code, and then they'll use Git to basically commit the changes that they made or anything new that they have added and push it to a GitHub repository. So these guys might share a singular repository, and from GitHub it can go for deployment, and that's what we will try to do. Right, so we will send it to Jenkins, and from Jenkins we'll try to send it to Kubernetes. We'll basically be using Kubernetes and Jenkins in the same server. So I'll tell you guys how it goes on. Okay, so Git is that. So I hope you guys know what Git is. All right, so this is like basically the life cycle. If you guys remember, I've taught this many times in my previous sessions also. We have assigning a working directory, initializing local directory, staging, and then committing, and then storing on GitHub. All right, so now let's talk about why do we need Kubernetes. So how many of you guys know what Kubernetes is? Because I know a lot of you may know about Git, but I am not so certain that you guys might know about Kubernetes. So let me know in the chat what is, if you know what Kubernetes is. Now, I know a lot of you have clicked on this session to know more about Kubernetes and how you can deploy on that. So go ahead and tell me if you know about it. And if you don't know about it, tell me any related topic that you might know about, Docker or something. Because I want to know what you guys know, so I can explain, fill up the gaps basically. So while you guys are giving me the answer, I want to start talking about why do we need Kubernetes. So in a normal deployment, when we talk about software development, we need to deploy our software. What is deploying a software? So let's first look at the pipeline in which we develop a software. Right? So a software developer will basically write the code that is required to run the software. Now remember, code is not exactly the same as software. Code is whatever syntax, whatever stanzas, statements that you write. Basically, all of this. This is your code, but it is not automatically a software, right? So it needs some other tools, some dependencies to become the software it is. Right, so with HTML, we might need other stack of technologies like the backend, and we might need the middleware and the database and all of those things, right? So all of those things together make our software. So what the developer does is he takes the code, he takes all the dependencies, and he starts building it into a software. Once he builds it into a single executable unit, he makes a software. Now this software gets tested by a tester. The tester tests it rigorously and checks for any mistakes if there are any. Now once he approves it, then this particular software can go ahead for deployment. Now the deployment over here is basically you're taking the software that has been tested and you're putting it in an environment or a server from where it can be exposed to the users. So let's say we're talking about YouTube. The YouTube end product is the streaming service that they're providing. So it is on a production server and it is exposed online, so anyone can use it, right? So that is basically your deployment process, where you put it in a particular server where it is exposable to everyone, right? So we'll see that. I'll give you guys an IP that you guys can target, and you can see the app that we have deployed. All right, so this is the standard delivery pipeline. Now, there are some issues that can happen over here because we're not using any complex methods. These guys are just transferring the code in either hard drives or sending by mail or messages, whatever. They're very amateurs. They don't have a clear-cut idea of what's happening. So over here, you guys can see the developer's environment and the tester's environment. So in developer's environment, you have the operating system that is CentOS, PyTest 5.4.3 for testing things, PyCharm IDE, and he's using Django backend code. He's writing that, and he has certain dependencies. Now the tester has a similar environment. The difference here is that he's using an older version of PyTest and he's using a different IDE. Now generally using a different IDE doesn't make a lot of difference, but here we see that the PyTest versions are different. Now this can be a problem. This is just for example's sake. I'm not saying that there's a proper differentiation between PyTest 5.4.3 and 5.3.0, just for you guys to understand. Now both of them have different application versions, so this might cause an compatibility issue because the developer might write the code for one version which may not work for the other version. So the developer and tester must have talked about it, about having a standard environment. Otherwise it causes problems, compatibility issues. The tester can't use the code that the developer is sending him, so he can't work with the code, right? So to resolve this kind of issue, where you do not have different environments and you have consistent environments, you make use of something called containers. Containers are basically like boxes. So instead of sending the code directly, what the developer does is he sends it in a box. Now this box will contain the code, the dependencies, and he will send it for all the processes. For the building process, where it becomes a software, for the testing process, where it gets tested, and in the production environment. So this is what a container is. And this is what container resolve. They basically help us remove that problem of consistency, right? That was not there previously. It allows us to give consistency. So that's why containers are very important, especially in today's development where you need to automate everything. So that's where Kubernetes comes in. Actually, that's where Docker comes in. So Docker is a tool that allows us to create these containers. So containers basically contain all of your code and libraries, right? Or any dependencies or the environment that you're using. So I haven't mentioned any environment, but you can think of it as here as an environment also. And all of them will be in container. You can use it in any system and server, this container. Now, generally, why do we need containers? One reason that we already stated was to have consistent development environments. Now, the other reason is microservices, right? So what microservices is basically, it's an implementation. When you actually work in the industry, you will not be deploying a single file like you did back in college or back in school, right? What you will do is you will basically divide your software into different parts like 1, 2, 3, 4, 5, and these 5 are logical parts that they have each function that they've assigned to, and they basically work in conjunction with each other. So instead of just putting those files out there, you can put them inside of containers and you can connect them in a network. So this way it's easy to manage them and easy to scale them. Like if you wanted to add more containers, more replicas over here, then it's easy to do so with microservices. That's why we use containers. So it resolves 2 problems. Now, Docker is a tool that allows us to create containers. So basically, if you have an application, you can put it in a set of containers and you can deploy it, right? So that's what Docker does. It allows us to create those containers. So when we talk about containers, when we don't generally talk about sending the containers itself, on the different servers, you talk about the images. So images are basically blueprints for these containers. And when you want to send a container, you will instead send the image of that container to the other person's system, and they will basically run the image in which the container will start, from which the container will start, and then they start working on it. All right. Okay. So that is it for Docker. Now with Docker, you can create a lot of different containers, not just one container. To manage them, you use services such as Docker Swarm, or you can even use Kubernetes. So Kubernetes is basically a tool that allows us to manage multiple containers. Let's say that you have 5 containers because you're implementing a 5-layer architecture for microservices where you have 5 containers containing 5 functions. To manage all of it, you use either Kubernetes or Docker Swarm. Now today we won't be talking about Docker Swarm, we'll be talking about Kubernetes. So let me go ahead and talk about Kubernetes. So Kubernetes is an open source container orchestration tool that allows us to manage multiple containers in different environments. So a pro about Kubernetes is that it's very secure and it's very robust. When I say robust, I mean that it is very strong. It doesn't break easily. And that is amazing, especially compared to other orchestration tools. So again, I'm telling you guys, Kubernetes is a tool that allows us to manage multiple containers. You guys know what containers are. And when you have multiple containers, how do you manage them? You make use of Kubernetes. Okay. All right. So these are the features of Kubernetes. You have easy updates and rollbacks. That means you can easily update any container. So if you guys remember, I was talking about the 5 containers. If you just want to update one container instead of the whole thing, then you can do that. You can easily update it. Or if you want to roll back a particular feature, you can do that. Storage distribution means that you can share data between these containers without any hassle by using volumes. Secret handling basically means, so Kubernetes is very secure. That means that when you want to connect it with your Jenkins or Git, when you're using private repositories, let's say you're using Docker Hub private repository registry, then you need to have a credential for it. So credentials are basically your secrets. So it handles all the secrets properly. Heals itself basically means that it makes sure that if any particular pod is down or a container is down, it will try to bring it up. So it does that automatically. You don't have to worry about it. Let's say that one of your containers that contains the payment feature, it crashes, right? And you did not know about it. The thing is that Kubernetes will automatically detect that and it will try to put it up again. Like it will try to put it on the production server again. Then there's load balancing, where Kubernetes is very good at dividing the load between multiple containers. So let's say that you have the payment feature again, and you have 2 replicas of those payment features. The replica basically means the same container, but the difference is that you use them in certain scenarios. So let's say you have one replica ready If the first one goes down, that means the first one crashes, you have the second one available. Now, sometimes you have a lot of people coming in also, and you want to divide the load between different containers. So you can divide the load between them. So let's say you're using a food delivery app like Swiggy or Zomato, and they see that they have 100 people only first week, but the next week they have 1,000 people. So those 1,000 people, to accommodate them, they basically scale their operations, where they increase the number of servers they have, and the load of the people coming in and requesting, asking for food, gets divided. Easy scaling. Again, I told you guys that you can scale the number, you can increase the number of containers you have for a particular service. So what do Kubernetes do, and how does it do it? So Kubernetes, the basic architecture is this: you have pods, you have a service, and you have an ingress. Now let me explain the pods. Pod is basically a representation of a particular, it's a representation of a particular feature that you're working with. So let's say your company has an application that has 2 features, or let's say there are 3 features. One is payment, one is tracking, and one is a map feature. So each of those pods over here will represent each feature, right? Or what you can say is that, yes, so let's take the previous example itself. So you have 3 features, and 3 features are represented by each of these pods. Now over here, the payment feature is represented by pod 1. The tracking feature is maintained, it's represented by pod 2, and the map feature is represented by pod 3. Now you can see that there are containers within these pods. So pod is a collection of containers. So these containers can contain different things that are required to run that feature. So let's say that your your payment feature requires a gateway, it requires a database, it requires some middleware connections. So all of that you can have in multiple containers that are connected to each other inside a pod. Now you can have replicas of this pod also. So let's say you have pod 1, and then you have pod 1A and pod 1B. So these are the replicas of this pod. So if pod 1 feature goes down for whatever reason, it crashes, you have pod 1A and pod 1B to replace its place. Similarly with pod 2 and pod 3 also. Now generally when you're inside Kubernetes, you can access the pod directly, but when you want to expose it to someone else, right, you use something called a service. So instead of directly exposing the pods, you expose it through a service. So let's say Swiggy's app, right? Again, it's a food delivery app. So it has multiple features. So what they do is they connect all of them into a service, and they expose the service to us. So we can access these pods through those services. Now, we're not going in the back end and accessing them, but we're using them over there. So that's what a service is. Now you can have multiple services. If you're a big company, let's say Amazon Web Services. Now, I don't know whether they use Kubernetes or what, but they have a lot of services over here. So you can see compute, robotics, customer enablement, storage. So all of these are services. Within those services, these particular services are there. Like EC2 is one particular service, Lightsail is one service, and each of them will be represented by a pod. Now, compute is going to be our service over here. This is the service, and these are the pods: EC2 pod, Lightsail pod, Lambda pod, and Batch pod. So when you have multiple services, you use an ingress to access them, right? So an ingress acts as a gateway for multiple services, right? So that's your basic Kubernetes architecture. I hope you guys understood that. So again, I'll just go and brief what Jenkins is. Jenkins is an automation tool that allows us to automate all the processes. So you guys remember that developers, right? They write the code, the source code manager. This is your Git. So Jenkins. So if you want, you can assign Jenkins to automate all of these processes. Okay. So I'm going fast because the deployment itself will take a lot of time. Let me just explain the pipeline to you. Then we'll go to the installation and all that part. Okay, so developer writes the code, he sends it to a source code manager. This is your Git, and Jenkins detects that a new code has been pushed. So it pulls that code and it starts building it. That means it starts making it into software, the code into software. Once it makes it into a software, it sends it for testing. It sends it to the testing server. Now, once it's on the testing server, the tests will happen. If all the test cases pass, the test coverage is 100%, then there'll be a feedback if something is wrong to the developer. If nothing is wrong, it goes to the staging environment. Now, it'll stay on the staging environment until it has been reviewed by someone or it has been documented. So once it has become a release candidate, it will go into production where it will be available to the users. So this is a basic Jenkins pipeline. All right, so now let us begin the whole thing. So first, what I'm going to do is I'm going to set up my environment. So guys, I'll be using AWS EC2 to launch virtual machines, and I'll be launching 2 virtual machines so that I have a Kubernetes cluster. Now, Kubernetes cluster is basically a cluster where you have multiple servers that can host containers. I hope that didn't confuse you. Multiple servers, as in you have 2 servers, and on both of those servers, you can have Docker containers, right? So generally, when we talk about Kubernetes, you can use a lot of different container services. Docker is one of the container services that is used most popular, which is one of the most popular choices. So I'm also going to be using Docker to create my containers. To manage those containers, I'll be using Kubernetes. All right, so yeah. So here I'm going to be using t2.large. Now I don't recommend you guys to use t2.large also. I mean, you can use if you have the fiscal means, because I'm saying this because this is not a free tier thing. You have to pay a little bit of money. It's not a lot of money, but you still have to pay the money. So please make sure that you know what you're paying for, what you're getting into. Okay, t2.large is not under free tier. I'm going to make these 2 instances because I want 2 servers. Now in security groups, I'm going to make sure that we have all the security groups, all traffic. So first we're going to name these cube manager, and I'm going to name this cube, let's call this slave. Yeah, so this can be master manager, whatever, that's fine. So first I'm going to take this one and I'm going to SSH into it. So we'll be using an Ubuntu instance for this purpose. I'll summarize it for you guys. First, what you need to do is you need to set up your GitHub repository. And once you set up your GitHub repository, you need to push some code to it. Now, once you've pushed some code to it, we will write some configurations, .yaml configurations. First, we'll be doing a first we'll be doing a deployment.yaml, and second, we'll be doing a service.yaml. So you guys can see those YAML files over here. This will basically allow us to launch our application. And once we are done that, we're gonna go ahead and deploy it using Jenkins. But here's what, I'll just show you guys the process of installing all of those at least. So first, I'm going to show you guys how you can install Jenkins. Now first, once you launched your server, you need to update it, sudo apt update. So we're done updating it. Now we're going to go ahead and install Java. Now Java is a requirement for Jenkins. So you need to install Java. So this is the command, sudo apt install openjdk 8-jdk. So if you guys want this command, just type in how to install Java on Ubuntu. All right. Now I added that -y because it asked me, do I want to continue or not? And I don't like typing yes every time. So I put that -y over there. Okay. So now this is installing Java for basically the Open Java Development Kit. So we'll be using that to launch our Jenkins. I can show you guys till then. What I'll do is I'll go ahead. We'll make a directory. All right. Okay. Yeah. All right. So actually I should have set it up a little earlier. Okay, now we install Java over here. Now I'm gonna go ahead and install Jenkins properly. Let's just first check if Java is installed properly or not. Yes. Okay. We do 1-. Yeah. And let me go ahead and install Jenkins. For that, first we need the signed key. So let me get that key. We got that key. Now we will add the Jenkins repository to our apt package manager. so that we don't get any issues. Now I'll update it again. We should see Jenkins. Yes, .io is one of the packages that we can install. So now we'll install Jenkins. So Jenkins installation is complete. Jenkins installation is this much only. If you guys want to go in more depth where I explain everything, go ahead and check out our Jenkins session video. Okay. So till that is happening, I'll just create my new kube deploy. Yeah, we'll make it public. I'll create the repository. All right, so this is done. So we have installed Jenkins. So what I'm going to do is I'm going to open Jenkins over here. And copy this, come over here, git remote add origin, right, git push origin master. So what I'm doing here is I'm basically pushing the code. Again, if you guys want to know more about Git, check out my Git session. I go into a lot more detail about this. So if you come back, refresh, we should see our code. And to install Jenkins, the whole process is there. You need to get the initial password. To get the initial password, just copy this, come back here, do a cat command. Actually, now we'll do the cat command. This is the first key that we need. We'll paste the administrator initial password. I'll continue. I'm sorry about the internet connection. Actually, since a lot of us are working from home, we don't exactly have the best internet connection. All right, so this will start working and we have the hello.html file over here. Great. So now the next thing I'm going to do is I'm going to just take these .yaml files. I'll come over here. Yeah. So over here, I'm going to add more files. Let's say we're going to call this deployment.yaml. I'm going to paste this. All right, let's save it. Now I'm going to create a service.yaml. I'm going to go ahead and paste this. All right, so let me go ahead and stage these. Sorry guys if I'm going a little too fast. I just want to show you guys, the output, the main part. This is all easy. Doesn't take a lot of effort. Again, if you guys want to know more about Git or Docker, we have specific videos for them. So you guys can see our YAML files are here and HTML file is here. Let me go ahead and finish. Remy, I'll put admin as a password. No need to give my proper email ID right now. I'll just save and continue. And this is the address. Now Jenkins generally starts at 8080, so we don't have a problem. So I'll click on save and finish. Start using Jenkins. Hooray. So finally we've done something in our session, right? I hope that is a milestone where we install Jenkins. So welcome to Jenkins message is a good thing to look at right now. Fine. So Jenkins is working. That's good. We can go ahead and create a job. But before we go ahead and create a job, we need to set up a Kubernetes cluster. So now I will take time to set up the Kubernetes cluster. So what I'll do is let me just open the steps because I don't have them by hearted. But our first step is to install Docker, right? So first, what you need to do to install Kubernetes is to set up your Docker. I thought I had not launched a proper instance, as in the one that is, this instance has at least 8 GBs of RAM and 2 CPU cores. So that is not a problem. Oh, right. So what I'm doing right now is I'm setting up Kubernetes. We have done Git, we have done Jenkins, and now we're setting up Kubernetes. So to set up Kubernetes, you need to install Docker. So we have Docker installed in our first server. So we can see, yes, Docker is installed. Now our next step should be to enable Docker. No need to start Docker. I think it should be enable Docker. Let me go ahead and enable Docker, which basically means that Docker starts every time this instance starts, right? Now I'm going to install some packages that are required for Kubernetes, like your apt transport package and the curl package. Now curl package is generally there, so I don't think there's a need to install curl with Ubuntu. Yeah, so great. So we installed those early packages. Now the next thing we need to do is we need to get the key for Kubernetes. So let me get the key for Kubernetes. So this is the command. We're curling this particular key from over this location, apt-key.gpg. Let me press enter, and we'll add the key to apt, right? And now once we've added the key, we can go ahead and add the repository. So this is how we'll add the repository. This is the command sudo apt add repository and the location of the repo. And once we add that repository, you guys can see packages.cloud.google.com. And next step is basically installing Kubernetes properly. So there's a lot of pre-steps over here. First, we need to install Docker. Then we need to install the apt transport HTTPS package. And then we needed to tell Ubuntu from where to download Kubernetes from. So for that, we needed the key first, and then we told the location. This is the location where we'll be downloading all the stuff from. And now we are installing it or downloading. So this is the command for that, sudo apt get install kubeadmin and kubelet. So you'll be using kubeadmin to initialize a cluster. You can use a lot of different ways. You can use Minikube, you can use Kops from AWS, or you can use the Google's whatever is there, right? And we're downloading kubelet and kubectl. Kubectl is the main thing over here. There's going to be a CLI, the main command line interface, with which you type in all the commands. So we have all the commands over here. So let me open my slave, because even in your slave, you need to install Kubernetes. So this I won't explain. I'll just directly do it. Let me color this differently so you guys have a distinction. Now, why do I have a slave? So generally in a Kubernetes cluster, you have one administrator and you have one slave, right? The administrator is the one responsible for doing all the managing, and the slave is basically the worker node that does all the work and everything. So sudo su. All right. Okay. So now here what we're going to do is same steps. In first update, then install Docker. Actually, this will take a long... Okay, here's what I can do. I'll install Docker. Let's actually create a shell file, shell script. Nano install.sh. So what I'm doing over here is I'm basically going to take all of these commands and I'm going to paste them here. Instead of typing them one by one, we can just type them, together. So shell scripts basically allow you to execute multiple Linux commands at the same time. Okay. I should have thought of this earlier. Since we are on time crunch, let me press enter, come out. You can execute it in two ways, /install.sh. Okay, so let's do sh install.sh instead. All right, so it will start executing all the commands on the go. Oh, Mayank, thanks for coming in and telling us about the telling Atif about what a YAML file is. Yeah, so here we have Kubernetes installed. Now I'll just check if it's installed or not. Kubeadmin, not init. It is version. Yes, version. Yes, so if you're getting this output, that means your kubeadmin has been installed properly. All right. So basically you have Kubernetes installed, but our cluster is not initialized yet. So we'll just have a second target ready. And once the second slave is ready, I'll initialize the cluster. Now that we have Kubernetes on both the things, first we will initiate our cluster, kubeadmin init. So generally, you just type in kubeadmin init and we'll start creating initializing a cluster for you. But we need to add one more certain thing. We need to add the pod networking location, right? So let me mention that and press enter. So right now it's doing all the pre-flight checks and checking all the things. Remember, Kubernetes requires a lot of resources, so you need a good enough powerhouse of a computer to run. or at least have 8 GBs of RAM. Okay, so if you have Ubuntu on your system, it will be much better for you. So since till it's initialized in the cluster, I'll tell you guys what YAML file is. So Kubernetes, again, I told you guys, is an orchestration tool. It allows us to manage multiple containers, right? Now, to create your containers, you don't need Docker CLI for that. You can create something called .yaml files. So let me explain those YAML files to you guys now. So first we have the deployment.yaml. Let me just take this, copy it, put in a new this thing. All right. So over here, yeah, so here this is a YAML file. So YAML file is basically a configuration file where you tell Kubernetes certain things. So if you have a deployment.yaml file, you're basically telling Kubernetes, I want these specifications in my containers. So first you use the API version. So this is important because you need there are certain APIs in Kubernetes that allow you to perform different tasks, right? So we want to perform a deployment. So we need to mention certain API for that. Then you need to mention metadata name of the deployment you're doing, then the specifications of the deployment. Now in the specifications, you mention the match labels. So your app name is going to be Nginx since you're launching an Nginx container. So I mentioned that. And next thing we are mentioning is over here is replicas. Now again, I told you guys what replicas are. They're basically copies of certain things. So if I say 2 replicas, it will launch an Nginx container, but it's going to launch 2 of those that are going to be exactly the same replicas of each other, you might say, right? And then we're going to mention the template, and then here we're going to mention the specifications for that template. So template is basically your container template, right? So labels, again, we're mentioning app as a label for that. And containers, you can see we are mentioning the name of the container and the image we're going to be using. So here, this is the image that we're using. So what it will do is, what Kubernetes will do is, it will make use of Docker, and once it talks to Docker, Docker will help it get the image that it wants. So it will go to Docker Hub. Yeah, so it will go to Docker Hub and it will grab the Nginx image that it requires and it will get it. Okay, so visibility is low. Let me increase that. Yeah. So it will grab the Nginx image and it will pull it and make it into a container. And we will expose the container at the port 80. So the container will be exposed at the port 80. So this is what the YAML file will do. So this is basically used to create our pods. If you guys remember, let me show you that diagram again. So here you see the pods, right? So these are the pods. To create one pod, we need a specific YAML file. So we're telling it. So this pod 1 can have multiple replicas. So pod 1A and pod 1B, that's what we're doing over here. And we're mentioning the image that is to be used for it. We're using Nginx image and we're exposing at the port 80, right? So now let's see, okay, the cluster has been initialized after we did that command. It generally takes a few minutes, maybe 2 to 3 minutes or 4 minutes. And in the end, it will give you a certain command. So kubeadmin join and the token. So you need to copy this token over here. Once you copied the token, you can go to your slave, and in your slave, you can paste the token. Once you paste the token, press enter, and it should have joined. All right, so we need to install Docker here also. Right, so Docker's installed. Let me try that command again. It's running the pre-flight checks. All right, so this means that the node has joined in the cluster, right? So one of our nodes has joined our cluster. So we can check with the kubectl command, kubectl get nodes. Right, so it will give us this issue. Now what we need to do is basically we need to use this command. So this command basically gives it the here's what, this command is not generally available. So pause the screen and just type this command out. Okay, now let's try that. Kubectl get pods, no resources found. Okay, fine. That means we just don't have any pods right now. That's all right. Let me go ahead and get kubectl get nodes. At least you will see how many nodes we have. So we have 2 nodes right now. They're not ready. So let's make them ready. We'll apply this particular network from kubectl. So it will apply a networking manifesto that will allow us to run these. All right, so let's check that out again. kubectl get nodes. So one of them is ready. Okay, both of the nodes are now ready. They're connected and they're ready. One of the master and the other one we didn't mention the role, we should have, but it is a slave, which is generally what we assume. Okay, so we have both of the nodes. Now if I do a kubectl get pods, you will see that there are no pods. Now if I do all name spaces, all right, so we have certain services running, so no problem. So quickly, I'm just gonna show you guys how you can, basically deploy your YAML files. So let me just go ahead and copy the YAML files I have. So I'll copy this. I'll come back here. I'll do a nano deployment dot YAML. Okay, I'm gonna paste this. Let's go ahead and deploy it. So kubectl create -f, and you mention the name of the YAML file. So this is the name of the YAML file. So here we're basically creating a deployment, right? So this is the deployment. We gave the name of the deployment. The name of the deployment is basically Nginx deployment. Okay. So this way we are creating pods. We'll be creating 2 pods over here. So let's press enter. So the deployment was created. So the first thing we will do we will go ahead and get the pods. kubectl get pods. So we have 2 pods and they are running. That means our Nginx containers are running. Yeah. Okay, so these things are running. That's really good for us, but we will not be able to access them at all because they're internally exposed, not externally. Now let's just do a quick check and we'll end the session. So you can use the docker ps commands and you can see there are a lot of containers running. So docker ps command basically allows you to run the containers, see all the running containers. So let's go ahead and do docker ps pipe grep and I'll type in nginx. Yeah. So grep command basically gets all the containers that have nginx in the name. You can see nginx is highlighted. So we have the nginx containers running on the pod running on our slave. It's not going to be running on a master. If I do a docker ps, we have some stuff running, but we will not have any of the nginx running stuff running over here. Yeah, so it's not running. It didn't give us anything. All right, so that's your internal deployment where you just have the pods deployed. You don't have a service at all to connect all of these pods. Even if you have 2 pods, you want to connect them with a service, right? So now let me go ahead and put the service in. So the service, same thing is happening. So first we need to go ahead and create the YAML file. I will say service.yaml and I'm gonna paste it. And we need to mention the namespace. So namespace is nginx. Let me go ahead and create that. First I will use the command kubectl create namespace and we're going to give the name nginx. All right, so let's just see if it's created or not. Yes, so we have nginx namespace created. Now we can go ahead and deploy our service.yaml file. So let me explain the service.yaml file. So basically we have a service. So this is going to be our service. And we have mentioned the metadata, the name of it, the namespace, and the labels it needs to that it needs to it has, and the specifications we're mentioning. We're using a node port. So there are a lot of different types of services. So this is the kind of service, but there are a lot of different types of services, right? So we're using node port for our service, and let me change this to 80. So node port is available at port and node port. Okay, so this is basically port exposing it at the exposing the host. All right, so let me just copy this instead. Nano service.yaml. Let me remove all of this, paste this. All right, so now I'm going to go ahead and deploy this. So kubectl create -f service.yaml. And so we're basically using GitHub to store all the configurations, like all the YAML files, the code and everything. We're using Jenkins to do all the automation where we create the pipeline and everything. That will basically have the steps. It will have the steps for deploying. So if you want to deploy, Jenkins is the one that is going to be deploying. Now, Kubernetes is basically our infrastructure. It's our infrastructure where we are deploying. Okay, so we have a local cluster that we created ourselves that has not been exposed anywhere, right? And it will be infrastructure. It manages all the containers, and Docker is the one that creates the containers. Yeah. So we store all the code and the .yaml files required for Kubernetes in GitHub, and in Jenkins we basically mention the GitHub link, and we basically clone the link, and then we run the Kubernetes commands in the pipeline that will basically execute all these commands only. The service.yaml create the services, create the pods, and once we put those commands in, we'll basically build the Jenkins job that we've created, and we'll configure it in such a way that it automatically gets built whenever we push code to YAML GitHub. So if I suppose push new code by changing the HTML thing with adding more stuff, then it will automatically detect that change happening, and it will go ahead and build our job, Jenkins job. And once it starts building that, it will deploy a new container on the infrastructure, on the cluster, and it should have been available to us by accessing the IP of the slave. So generally, if we put the IP, we should have been able to see at least the Nginx welcome message. Yeah.
I want to introduce you to Great Learning Academy, a free learning initiative by Great Learning, where you can access over 200 plus courses with 1,000 plus hours of free content on trending high demand domains such as data science, machine learning, artificial intelligence, programming, cloud computing, digital marketing, DevOps, management, and many more, absolutely free. Award-winning academicians and leading industry experts design these courses. You can also get a free certificate of completion when you enroll and complete these free courses. You also get access to the presentations, code, notebooks, datasets, and quiz. We have courses in English and Hindi to give you the best learning experience in the language you're comfortable with. Check out the description of this video to access the relevant course on Great Learning Academy. So what are you waiting for? Register now and start your learning journey today.